Space, the final frontier. These are the voyages of the starship Dgraph. Hello. Hi, sorry, I'm back. Space, the final frontier. These are the voyages of the starship Dgraph, its continuing mission to explore the strange new lands of API space, to seek out new GraphQL creations, and to boldly go where no one has gone before. Hello, everyone, and welcome to GraphQL In Space. I'm Shruti, and I'll be the host for today. We've got an exciting lineup of speakers and events today. We will be talking about GraphQL, we'll be talking about space. And now that I have your attention, I would like to start with some housekeeping, right? So fire exits that way. Oh, wait, we're doing a virtual conference. Thanks, 2020. Very strange year this year. And I do hope that you know where the fire exits and the toilets are from where you're sitting. All right, now back to the actual housekeeping. Now, undoubtedly, you will have questions for all the amazing presentations that our speakers have on their innovative views on GraphQL. And we have devised a way for you to ask questions. I'd like to please direct your attention to our Discuss page, which you can find the link below. Please post your questions there. I'll be monitoring the questions and redirecting to our speakers. The speakers will also directly answer the questions on the Discuss page after the sessions. Please note that this conference is being recorded and we do have a code of conduct. So please be mindful of it when you're interacting with your fellow attendees on the chat to the right. So the theme of this conference is space. And the first time I've heard of this conference, I mistakenly assumed that it was about the use of GraphQL in the space industry. And now I know that the theme is so much more ambitious. The theme underlies the very idea that we humans need to be a spacefaring species. That is, that space is infinitely large and we need to change, we need to grow, we need to adapt and evolve. Speaking of evolution, 5 years ago, none of us could have imagined how popular GraphQL would become, and neither can we actually accurately predict where GraphQL will go a decade from today. And that's because the industry is moving at light speed. And guess what? That's great, because that's the only real law in the universe, isn't it? You can't move faster than light speed. And there's been so many innovations in the field, and yet there is space for so many, many more. Like space, there's infinite room. And that's why we at Dgraph want to create an environment that promotes a culture of innovation. They say we live in a flat universe, or at least it's locally Euclidean for those of us who believe that we live in an de Sitter space. So that means space is endless. And just as space is boundless, we want innovations on GraphQL to have no bounds, just a white hole of ideas and endless founts of information unto the ether of space. Now, we romanticize space a lot, but the reality is space is extremely tough. It is very, very challenging and requires you to be constantly on your toes to innovate, to overcome the problems that it throws at you. And really, the only way to survive outer space is through cooperation and innovation. So too does the theme of space actually encompass the virtues of working together in collaboration and the virtue of innovation. Many talks you see today will feature a marriage of various different technologies, and it's only by collaboration can we forge ahead. So we're here in virtual space exploring API space. To explore space, to boldly go where no one has gone before, you need an astronaut and you need a starship. And guess what? We've got an astronaut on board with us today, a legendary spaceman, and you will be meeting him real soon. But now that we've got the astronaut thing sorted, now we've got to talk about the ship. The ship has a name, and if you paid attention to the opening, the ship's name is Dgraph. We're the vessel that helps you navigate API space. And at the helm of this ship is our fearless leader, founder, and CEO, Manish. He is the guy who will bring us to where no one has gone before. So let's give Manish a warm welcome. And over to you, our Capitan.
Hi, everyone, and welcome to the first ever GraphQL in Space conference. I'm Manish, the founder and CEO of Dgraph Labs. Today, I'm going to talk about serverless GraphQL, build apps, not infra. Let's start with a story of the most popular developers in the world, Alice and Bob. They want a GraphQL backend to serve a knowledge graph of sorts. They need to first fit their data model into flat tables. Now, based on data from schema.org, a person type has over 70 properties. Movies, book, photograph types, each have over 100 properties. And there are over 1,000 types of data in the knowledge graph. A typical app would use a subset of the properties of this dataset. How big of a subset would depend upon the breadth of the application. The more holistic an application is, the more types and properties it would need. The more types and properties it has, the more relationships could exist between those, which would then need more tables to capture those relationships. So they need lots and lots and lots of tables to capture all the information the world can throw at their app. Capturing something to the extent of schema.org could require thousands of flat tables interconnected with thousands of other tables to allow traversing the graph. But the database was not designed to serve so much complexity. They soon realized that queries are not performing as fast as they could, so they need to add a layer of cache. Then they need to write the code to do data retrieval. They need to write a layer of business logic, then a layer of authentication and authorization. Then they just need to solve a few issues like N+1 problem, query depth, scalability, replication, data consistency, backups, encryption, and search, and so on and so on. So you see, they need to build layers and layers of indirection to transform what they want to what the database understands and back to what they want. And it has to work across the various systems involved in each query. And remember, it has to be fast because users want speed. And if they need to change their schema, they need to add some tables. They need to remove some tables, they need to migrate their data, and then update all the layers above them accordingly. In all of this, Alice and Bob's speed of iteration suffers. Alice and Bob's story should give you a picture of the number of challenges a developer faces in building a backend. That's because backends today are full of layers. You have a GraphQL server talking to a backend server, talking to a cache, talking to a database. In between all of this is handwritten code which has to be built and maintained. Just getting it up and running is a big task. Then making it scale in production is even worse. And all Alice and Bob wanted was just a GraphQL backend, so they can focus on what they do best, build apps. This is the problem we set out to solve back in 2015. We wanted to create a fundamental transformation in how apps are built. We did not assume a relational database at the bottom of the layer. We went about building an infrastructure stack from first principles. A stack where a database works with the app, not against it. And to solve that, we started with a set of core beliefs. We believe in fast real-time applications. Data changes at the speed of light these days. Every millisecond counts. We want to enable developers in building applications with a snappy interface. We believe in simple backends which eliminate layers of indirection. Backends which enable application development, not hinder it. Backends which can scale as demand increases and can stay fast and nimble. Backends which are fault tolerant, which can survive unexpected events like server crashes or disk failures or network partitions. And they should not need hiring an expert of DevOps engineers to keep them running 24/7. We believe in iteration and evolution. Performance of a software is not the only metric that counts. Speed of iteration is a very important metric in today's agile world. Backend has to be flexible to adapt to design changes seamlessly and without any downtime. Data models today are rendered complex by the underlying limitations of the backend serving them. So we set out to create a technology which can simplify data models and enable a fast iterating, fast evolving product. We believe in clean, lean code bases. We think with the right technology, most code bases can be cut down significantly. We set out to create a powerful query language to do complex data retrievals for the developer without having to write code. And by eliminating layers of infrastructure, we can achieve a much leaner, lot more maintainable code base. And we believe in separation of concerns. N+1 problem, caching, query depth, scaling to terabytes of data, replication, consistency, periodic backups, encryption, search. These are not the issues application developers should have to solve. These are the issues that should be managed out for them with a new technology. We believe in providing an incredible developer experience and enabling them in providing an exceptional user experience. So all of these beliefs led us to our vision for GraphQL. And that is fast, scalable, flexible GraphQL. Developers want to use GraphQL to build their apps, and it better be fast. And it better stay fast when the data size increases or the query volume increases or when they get on the front page of Hacker News. Our beliefs propelled us to build a whole new system which can provide GraphQL natively. No layers, no indirection. Things are impossible until they are not. And with that thought, today, I'm proud to announce /GraphQL, a fully managed native GraphQL backend infrastructure. The entire Dgraph team has been working relentlessly towards this for the last 1.5 years, and I cannot wait to show it to you. Let's take a look. I am excited. That's /GraphQL. You saw a glimpse of the features that /GraphQL provides in the video. And now I'm going to walk you through these. /GraphQL combines the functionality of many layers of infrastructure. It provides a GraphQL endpoint, execution of custom logic, accessing remote endpoints, authorization, cache, and a database, all in one holistic system. And being a native GraphQL solution built from first principles, you deploy a backend by just setting GraphQL schema. No tables to create, no relationships to specify, nothing to configure. One-click deploy. Getting a backend up and running is one thing. What we have learned from building backends for a living is that developers need to iterate. They need to stay agile and change things. They want to update a data type from string to datetime. They want to convert a single object to a list. They want to search by full text and regular expressions. All of those things can be done with just one click. Just update your schema and click deploy. How easy is that? I think it's very easy. We didn't stop at one-click deploy. We took it one step further. We created a command line tool which can let you create and manage the backends, update your schema, import and export your data, all from command line. With /GraphQL tool, you can create a production quality GraphQL backend with just one simple command. Imagine running your test suite by deploying a backend, uploading some data, testing your app, and destroying the backend at the end, all from your CI/CD. How cool is that? Very cool. /GraphQL comes with built-in support for live subscriptions because I really like apps which update in real time. Security is very important for us. We natively support authorization in the system. So as a query is traversing the graph, it can check whether the caller has the right permissions to access the resources or not. And not only that, being true to the graph nature, one can traverse relationships to resolve those auth conditions. For example, you can show your posts to your friends of friends without having to change anything in your data model or denormalizing your data, all at runtime, without any loss in performance. All auth logic can also be specified directly in the schema and deployed with one click. Now, we wanted to avoid having a layer of logic because, as you might have picked up by a presentation so far, we want to remove layers of indirection. So we built 3 different ways of executing custom logic for developers. First is by running GraphQL +-. GraphQL +- is a fork of GraphQL that Dgraph Labs has been maintaining since early 2016. It provides a lot more power than the standard GraphQL spec, and it can be used to slice and dice the data in a lot more ways. Second is by triggering remote endpoints. These endpoints can be REST or GraphQL endpoints, and all of these can be mentioned in the schema as well. /GraphQL can then auto-resolve a query to hit these endpoints as and when required. And third, which is by far my favorite, is allowing developers to upload their JavaScript functions directly to /GraphQL. This JavaScript code can then be triggered by queries to run any custom logic that a developer needs. So all these 3 systems combined eliminate, or at least significantly reduce, the need for a developer to have to add another layer of logic. And it all just works as one system. /GraphQL is fully enterprise ready. Remember, a lot of the work that comes from /GraphQL was inspired by our work at Google. So it has advanced security support, including TLS and encryption at rest, can scale to terabytes of data, and can be run on VPC. So you must be wondering, what's behind all this? /GraphQL is powered by Dgraph, the world's most advanced GraphQL database. It is the top GraphQL database on GitHub with close to 14,000 GitHub stars and over 3.5 1.5 million Docker pulls. It has been battle tested, serves terabytes of data, and runs billions of queries per month in the wild. And that's billions with a capital B. Dgraph allows you to break away from the table mentality and deal with types as just nodes in the graph. This hugely simplifies the data models for the developers and allows them to think directly in GraphQL terms. And did I mention Dgraph is open source? Yes. So /GraphQL is different from other hosted services because unlike other services, Slash is running on open source Dgraph. We ensure compatibility between /GraphQL and Dgraph, so it's easy for anyone to switch between the two. Any /GraphQL user can just make the switch with little to almost no changes to their software, to their own code. There's zero vendor lock-in. And if you're unhappy for whatever reason, we make it easy for you to switch to a relational database. So you can move entirely away from the system. No questions asked. But a backend is only half the problem. The other half is the front end. So after making deploying a GraphQL backend a click of a button, we took it one step further. We wrote a bunch of GraphQL apps. Simple, useful apps like to-do list, survey forms, and so on, which can all be deployed with just one click. So in one click, we deploy both the backend and the front end. And I'll show it to you in my demo at the end of my talk. We plan to write more GraphQL apps, which can be used to solve common problems like NPS surveys, Discourse search, team directory, and so on. In fact, tweets.dgraph.io is one such app running on /GraphQL today. Finally, pricing. Our pricing model is simple. It is pay for what you use. Developers should not have to think about machines, RAM, disk, network, cluster, ingress, egress. They should not have to calculate how many resources they need, even before their app goes into production and they get some serious traction. So we charge users by queries performed. The more queries they perform, the more they get charged. The less queries they perform, the less they get charged. That's simple. Moreover, a simple lookup query should not cost as much as a query which touches millions of records. So we take a logarithm of the records accessed and use that as a query cost. So most queries, just to give you an idea, most queries cost 1 credit. And if you query 1,000 records, that costs 2 credits. If you query 10,000 records, that costs 3 credits, and so on. So now with that understanding, let me show you the cost of running your app on /GraphQL. There it is. All /GraphQL instances come free with 10,000 credits every month, completely free. Our standard plan is only $45 a month. So for $45, you can get 10,000 credits a month. And our premium plan is $99 a month, which gets you 250,000 credits. That's cheaper than a phone plan. So you get started with a free instance, then upgrade to a standard plan when you gain some traction, and then you go premium when your user base grows. So we built this plan keeping our users in mind. We want them to succeed with /GraphQL and only pay for what they use. I'm sure you guys would have tons of questions for me. So if you want to ask me questions, you can go to Discourse. I will answer all of those questions. I have created a small link for it, bit.ly/GraphQL-space-Manish. And we are also running our first hackathon. It's on bit.ly/slash-hack. That's your opportunity to create the GraphQL apps, which can be deployed with one click on our platform by /GraphQL users. So do go and check it out and participate. And for anybody signing up today, we'll give you 50,000 free credits to use for your /GraphQL deployment. So do sign up. And remember, build apps, not infra. Now, I promised you a live demo at the end of my talk. That's the end of my talk, and I'm going to show you a live demo of /GraphQL in action. All right, so I'm here showing you my /GraphQL dashboard. It only has one backend right now to a tweet site, which shows you tweets.dgraph.io. And that's the one that is running on /GraphQL. Then I'm going to use a /GraphQL tool. So in the next 10 minutes, I'm going to show you how easy is it to deploy with Slash. I'm going to demo you two things. One is the /GraphQL backend, which can store and serve tweets. And the second is to build an open source Surveyor app, GraphQL app called Surveyor, which will use to gather feedback from all the participants today. And both would be deployed live right now. So I'm going to use the command line tool here. I'm going to say /GraphQL deploy backend --help. I'm going to make some changes here. And it asks me for a name. So I'm going to call it GraphQL in space. All right. So this would take around 40 to 60 seconds. It's spinning up the backend. And we already have the GraphQL link here that we can use. And meanwhile, while it's spinning up, I'm going to show the schema that I'm going to set here. So the schema here contains tweets with the ID, text, user, timestamp, score, and streams. And the user here contains the screen name, description, followers, and so on and so forth. So on the right-hand side, our endpoint is ready. I'm going to use this endpoint, copy this endpoint, and I'm going to use this endpoint to update the schema. So update the schema would take in the endpoint and take in the schema file. All right, the schema has been updated. Let's go check it out. So I'm going to go to /GraphQL. It doesn't show. Let me refresh this page. And it has GraphQL in space. That's our backend. And let's look at the schema here. Great. That's exactly the schema that we had set. So now the GraphQL backend and the API is ready. I'm going to do one thing. I'm going to log into my workstation, which contains a script that I'm going to use to upload the tweets. It's going to search for the tweets live and upload them to the backend. Great. So it has searched a bunch of tweets live. These are all GraphQL related tweets, and they are being uploaded live to the backend. Now let's go to the API Explorer. This is, as you can see, that this is graphical. I'm going to click on the Explorer. I'm going to query for the tweets. Let's take the first 10, ID, score, streams, text, timestamp, and pick up the users, followers, name, screen name, location, and let's run this query. Awesome. So as you can see, we are able to see some GraphQL queries here. This is a fully functioning GraphQL backend. We are able to see the results here. Now, the next thing I want to do is to find the users with the most followers. So I'm going to go back here, remove this, query user, first 10, and order by descending order of followers. And I'm going to find their name, screen name, location, and find their tweets. The tweets are ID, text, and timestamp and score streams. All right, so we are, in this case, we are going from the user to the tweets. I'll run this right here, and great. And we forgot to ask for the Number of followers. Yeah, let's run that. Great. So on the top, we have TechCrunch, and then we have Captain Scott Kelly with 5.4 million followers, which we're going to, we're going to talk to Captain Kelly right after my talk. So I'm really excited about that. Now that's great. The third thing I want to do here is I want to search over the tweets. So if you go back to our schema, and if you see over here, we have the text here. So I can search over the text, but I don't have any search index. So I'm going to schema builder, go to tweets. I'm going to do the text, and I'm going to click on search and full text. And I'm going to click deploy. Great, it's up and running. So now if you go back to the API Explorer, I'll query the tweets. I'm going to search for filter by text. Now this is something new that just got added because of my update there. I'm going to search for any of text space. And let's put the ad, score, streams, text, timestamp. The user would have the followers, location, name, screen name. All right, great. And you can see our query here has returned a tweet which contains GraphQL in space. So we have around 4 tweets about space. How cool is that? All of this we were able to do with the command line tool and with just one click. Now, for the second one, I'm going to do go to apps, and I'm going to click on Surveyor. I'm going to click deploy here. Now, this is the one where we're going to deploy the backend and the front end together. So deploy. So this would take, again, around 40 to 60 seconds to spin up. And this time, it is not only deploying the backend, but also deploying the front end. And once it spins up, I'll create a survey that we can share with everyone attending today. And we'll use that survey to get feedback from you guys. So I'm going to set the questions in the survey and spin it up. And let's just wait for a few more seconds for the survey to load up. Hopefully you guys are enjoying the conference, because I'm going to ask you 3 questions in the survey, which is, how are you liking the conference? How did you, what did you like the most about the event? And how can we improve for next year? So now the backend is here and the front end is here. All of it was done with just one click. Now I'm going to take this, open this up right here. Cool, we have a fully functioning front end right here. I'm going to create a survey, new survey. I'm going to call it GraphQL space feedback. I'm going to add a question, rating says, how are you liking a conference? I want this to be a required field. Add another question. What did you like the most about the conference? And add another question. How can we improve for the next year? Create. Great. So my form is live. It's right here. I'm going to create a bit.ly link so that everybody can see. So it's GraphQL space feedback. Save. Oops. Okay, let's call it GraphQL space feedback, graph space feedback. GraphQL in space feedback. Yeah, that should work. All right, great. I'm going to copy this. Stickies. I hope you guys can see this sticky right here. So this is just an easy one. So it's GraphQL-space feedback. So one thing I want to show in this one is, let's go back to our /GraphQL. Let's go to the backend here. I'm going to copy the GraphQL endpoint. I'm going to take you to Graph Playground for this one, because I want to show you subscriptions. So you open this thing. Okay, so you can see the docs. And those already contain, it's able to like to do the introspection to create the queries for us. So what we're going to do is query form. And in the query form, we'll have the ID, the title, and the responses. And in the responses, we'll have the ID, entries, and in the entries, we have ID, rating, text. Yeah, close this right here. I'm going to run this thing. Oh, looks like we already have, wait a second, did I use the right? Yes, looks like we already have some responses here. So that's great. That's awesome. Now I'm going to do one thing. I'm going to show you subscription part of this thing, subscription, and I'm going to run this thing. So we can see live what's changing. And I'm going to go back. Oh, looks like somebody has already added their feedback here. So as you can see, subscriptions is working just as expected. All right. And with that, I would like to conclude my demo. I'm going to stop sharing right now. In this demo, I showed you how easy is it to deploy a GraphQL backend with /GraphQL. I think the developer experience that /GraphQL creates is unparalleled. And I hope you are as excited about it as we are at Dgraph Labs. And remember, anyone signing up today is going to get 50,000 free credits to build their GraphQL backends. So enjoy the conference. I'll be around to answer any questions on Discords. Thank you very much. Beam me up, Scotty.
Thank you, Manish. That was pretty cool that you can actually get a backend and frontend just for free, just with a schema and 1 or 2 clicks. Now, for some housekeeping, just a reminder that there is a code of conduct, so please be mindful of it and please be respectful of that, of your fellow attendees. I'm very excited to introduce the next speaker, but we'll have to take a short 3 to 4 minute break as we set up our new speaker. So we'll be back in 3 to 4 minutes. again. Do you have a favorite space captain? Mine's Jean-Luc Picard. He's a decisive captain who believes in the power of intellect over brute force and cynicism. Sure, the latest Picard series has changed things up a bit, but at the core, Jean-Luc Picard is still a decisive and ethical leader who helped his crew members grow as people. The issue I have with Jean-Luc Picard is he's fictional. The next person I'm going to introduce is a bona fide space captain. He's a former military fighter pilot, a test pilot, an engineer, a retired astronaut, and he's a veteran of over 4 space flights and the only American astronaut to have spent over 500 days in space. Everyone, please welcome Captain Scott Kelly.
Throughout history, people have done things that are risky. Even though it is a risky thing to be doing, and I think it's a lot more risky than some people might think, I still think it's worth it.
Astronaut Scott Kelly will try something no American has ever done before. This spring, he will leave for a mission and spend a year in space. His twin is former astronaut Mark Kelly.
Genetically, the brothers are almost identical, so scientists will be able to measure how Scott and Mark change physically and emotionally as months pass.
Warm up a little bit. This one's a bit of a Hail Mary. Here we go. Boom! Astronaut Scott Kelly at the International Space Station.
Scott Kelly has been working toward this mission his entire career. He's been working toward this mission his entire life in some respects.
I decided that the challenges staying in space for a whole year presented was appealing to me, even considering the sacrifices.
The human body was made for living in gravity. Strange things happen to us when we spend long periods of time without it. But that never deterred the former Navy test pilots from dreaming of becoming astronauts.
Pretty much anything we've ever put our mind to, we've been able to accomplish. Doing pretty good. I do feel like I've been up here for a really long time, and I look forward to getting home soon.
Interesting to watch. What a great story. Great story and a fascinating experiment.
Space is still the most exciting thing I can imagine, and talking to someone in orbit still is, it's like I am an astronaut right now.
Are you concerned about the toll, the physical toll that this will take on you?
I do think about the effects of radiation. You know, the reason I'm here is to learn more about it, so someday we can travel further from low Earth orbit than we ever have before. A year is not short, but it was very rewarding. It was enjoyable. It was something that I feel privileged to having got to do.
Go ahead, Scott.
Well, it's great to be here with all of you today. Actually, after a year in space, it's great to be anywhere with gravity. You know, on the space station, I changed positions so many times, you would have thought I was running for president. So to those out in the audience that do not appear to be space aliens, I'd like to say good morning, wherever you may be. If it's morning, maybe afternoon. To the rest of you, I come in peace. So on the space station, we have to learn to live with very little stuff. I actually wore the same pair of pants for an entire 6 months in space, but I'm adjusting to life very well here back on Earth. I'm actually not really in space now. I'm back on Earth, but I'm adjusting to life very well here back on Earth. I've actually only been wearing these pair of pants for a month now. So when I did this in person, I would generally apologize to the people in the front row. Actually, now that I'm doing this virtually, I'm not even wearing pants, but I'm pretty sure you don't want to see that. Anyway, people often ask me, what is the best part about flying in space and having this job? I really do consider it a privilege, but what is the best part? Is it the launch, the landing? Is it floating around in zero gravity? Is it looking out at planet Earth back there, which is incredibly beautiful? What do you like about it? And for me, all those things are great, but really the best part about it is that it's a really, really hard and challenging thing to do. And that's what I want to talk to you a little bit about today before we get into the Q&A. It's about doing hard and challenging things. Not the easy stuff. Anyone can talk about that. I want to talk about the hard things and how I was able to do that in my career at NASA. And for me, the hard things involved, some other skills. It was about having a goal and a plan. It was about taking risks, being willing to make mistakes, at times being willing to fail. It was about focusing on the stuff that I could control and ignore what I couldn't. And of course, it was about working as a team. Because in my experience, when I was able to put all these things together, what I learned is that the sky, or maybe the sky, is not the limit. Little cliche, I know, but absolutely true in my case. So I shared the secret about my pants, and I'm going to just share another one with you. And that when I was a kid growing up, I was a really, really bad student. And I was the kid that sat in the back of the room looking out the window, or looking at the clock, just trying to make it run faster. So me being an astronaut was never a possibility. It actually was, right there up there with kids' aspirations to, be a dinosaur or something. It was something I was interested in, but never in a million years actually dreamed I could do this. I came from New Jersey, 1960s and 70s, so the space program was a big thing, but never thought it was possible for me. I do remember the first time I said I wanted to be an astronaut. I was in the boys' bathroom, standing right next to the urinals, next to one of my classmates in front of the urinals, doing what first grade boys do in there, both peeing on the floor. This kid turns to me and he says, "Hey, Scott, what do you want to do when you grow up?" And I said, I don't know, play baseball for the Mets. I was a Mets fan. And he turns to me and he says, "I'm going to be an astronaut." Thought how cool that sounded. So I said, I'm going to be an astronaut too. He says, "You can't be an astronaut because I'm going to be an astronaut." Was not my twin brother, Mark, by the way, who also went on to fly in space 4 times. So that's where I got my start. My dad was a police officer, one of these stereotypical, like Irish, cop guys you'd see on TV. My mom was a secretary and a waitress. And about the time my brother and I were becoming teenagers, she decided she wanted to become a cop like my dad. And this was a time in New Jersey when there were very few female police officers. She had to do all the same tests as the men, the physical fitness tests. And it was really hard for her. But, I remember her having this goal that she thinks she could not possibly achieve, a plan to get there, and then working really, really hard at something. And eventually she became the first female cop in my hometown. I'm always proud of her for doing that. Unfortunately, this did not inspire me to become a better student. I still struggled a lot. And it wasn't until I was in college and I discovered Tom Wolfe's book, The Right Stuff. I actually had it right here with me, sitting next to my desk. And always in a good spot. And that inspired me that I could actually do something I never quite thought was possible. Kind of gave me a goal and a plan to get there, and worked really hard. I thought it was possible. Maybe I could become a pilot in the Navy, and if not the U.S. Navy, maybe the U.S. Air Force might be a little bit easier. Maybe a test pilot, maybe quite possibly even an astronaut someday. And, I know what people think, 18-year-old kid reads book, decides he or she's going to become an astronaut. That's a giant leap. But really for me, it was a step into the unknown, certainly, but also in retrospect, a bunch of much, much smaller, manageable steps to get there. So I went in the Navy. I wasn't the best pilot at first. What I found in my life is, how good we can become at anything has no relationship whatsoever with how good we are when we started. And that was absolutely my experience. Fast forward 18 years from the day I read Tom Wolfe's book, The Right Stuff, and I'm getting ready to fly in space on my very first mission. This is a picture of Buzz Aldrin on the moon. Fan of Buzz. It was 1999. I was almost 18 years to the day of when I read the book, The Right Stuff. I'm heading out to the launch pad with my crew. We get out to the space shuttle. It was actually Space Shuttle Discovery. This picture I like is Atlantis. And the launch pad is like completely abandoned of people, giant, basically a bomb on the top of the hill. We get inside the cockpit about 3.5 hours prior to launch. And closeout crew straps us in. They bolt the hatch closed. They take off. They get about 5 miles away. Clock's counting down towards zero. In the course of the next 3 hours, you're getting over 2,000 switches and circuit breakers ready for launch, all these procedures. At 9 minutes, that clock stops, which is to give you time to catch up if you happen to be behind on what you're doing. It's also the moment you think to yourself, man, this is really stupid. Flying in space, your first time, you don't really know what to expect. A lot of unknowns there, but you're committed, you're strapped in, the hatch is bolted closed, can't get away. Plus, it would look really silly to be the first astronaut to ever run away from the launch pad. So you're committed. Clock starts going again. At 6 seconds, the main engine's light, three giant main engines, but you don't go anywhere because you're bolted to the launch pad by these 8 giant bolts. Then the clock goes 5, 4, 3, 2, 1. At 0, those bolts are exploded open. The solid rocket motors light, and it feels like the hand of God is literally lifting you off that launch pad and throwing you into outer space. And I know if you've seen a space shuttle launch, maybe on TV, maybe in person, looks like the space shuttle lifts off slowly. When you're inside, there is nothing slow about this. You get the feeling you're going somewhere. You're not sure where you're going, but you absolutely know that you are not coming back to Florida. Within 8.5 minutes, we're flying around the Earth at 17,500 miles an hour in space, heading to the Hubble Space Telescope, emergency repair mission, my first flight in 1999, right before Y2K. They actually had us come home early. Like everyone else, NASA was worried that the computers on the space shuttle were going to divide by 0 and we were going to go through a wormhole, maybe. But so we came back early. And after that first flight and my second flight that I flew as the commander on the space shuttle, people sometimes ask me, "Hey Scott, what does it look like when you're punching a hole in the sky?" I'm like, I have no idea at all. Never really looking out the window on my 2 launches into space. And you might wonder why. You're sitting in the front row. Why wouldn't you look out? Well, in the Navy, I was taught this idea in the military of compartmentalization, focusing on the things that you can control and ignoring what you can't. And that was absolutely been a part of my success, knowing the things we have control over. And that might be the case in your business. There are certain things you have control over and many things in our world today that we don't, like this pandemic, when it's going to be over, things with the economy. Knowing what we have control over, compartmentalizing, such a factor in my success. Like I said, I flew 2 flights on the space shuttle. A following flight to the International Space Station. I used to call a long duration flight 6 months. And when I got back from that, that's when NASA started talking about sending 2 guys into space, me and a guy I now refer to as my Russian brother from another mother, Mikhail Kornienko, Misha. And we were going to go spend a year on the International Space Station, or nearly a year, because someday we want to go to Mars. It's going to be risky. I think part of people's success in life is willing to take risk, at times being willing to fail. Always the case for me. Like I mentioned earlier, I wasn't necessarily the best pilot in the beginning, but, I knew there was risk of failure and I took it. And I always encourage people to do the same. So in March of 2015, second time in my life, I'm in this place called Baikonur, Kazakhstan, Central Asia, middle of nowhere, getting ready to launch on this Russian rocket. You get up to the launch pad of the Soyuz, And it's not abandoned like the space shuttle. There's like 100 people at the base of this rocket. Some of them are smoking cigarettes. I kid you not. Smokers, base of the fully fueled rocket. You want to get out of there as quickly as possible. There's an escape system on the top. You get in the Soyuz, it's about as small as it can possibly be, and you can fit 3 grown people in there. You're elbow to elbow. Your knees are up to your chin. It's hot. It's loud. It's dark. No countdown clock in the Soyuz like in the space shuttle. After about 3 hours, some guy just comes up on the radio and says ignition in Russian. And I could just picture one of those smokers with their lighter there lighting that rocket. Soyuz does lift off slowly, but still within 9 minutes, you're flying at Mach 25 times the speed of sound. 6 hours later, we approach and dock with the International Space Station. A couple hours to do leak checks. And then Misha and I, my Russian brother, we float through the hatch together to the International Space Station because we're in this together, him and I, for a year as a team. I get inside the space station. I'd been there 4 years prior. The place looks the same, sounds the same, smells the same. Day one of a year in space. And I think to myself, man, this is a stupid thing to be doing. I mean, being an astronaut in space, probably one of the only jobs you can't quit. You can't call an Uber to come home. You are absolutely committed to the unknown, really, never having spent that much time in space before. You might wonder what the space station is like. It's really big, 1,000,000 pounds. You put it on the ground and cover a football field. Really a great example of a renewable energy system. Giant solar rays collect energy from the sun, powers all of our equipment. We take our urine on board, we turn it into water, which we then drink. Then, of course, we turn it into urine again. Then we drink it again. Actually, we drink it after we turn it into water. I know what you're thinking. That guy drank his pee for a whole year. Actually, I drank everyone's pee. It's all mixed together, but it does taste better than the water in Florida. And that is an absolutely true statement. The space station is about the science we do on board. Some of that science is dedicated to life on Earth, basic research in biology, chemistry, physics, material science, pharmaceuticals, fuel efficiency. And then a lot of the science is based on us going to Mars someday. How does this environment affect us physically? In space, we lose 1% of our bone mass a month. We didn't do anything about it. So in 100 months, you'd have no skeleton left. You'd kind of be like Gumby, maybe. Muscle mass, there's a loss, effects on our vision, our immune systems, our microbiome, radiation. So these anywhere from 10 to 20 chest x-rays every single day we get into space. So these are the things NASA's trying to learn. So someday we can send people to Mars. One of the experiments that got a lot of attention was with my brother, Mark, who's also an astronaut. It was called this twin study to look at our mostly genetics. And there were some interesting results there. I don't really have the time to go into them now, but a lot of things that NASA expected would happen to me in space was actually, somewhat different. So it was very, very successful mission from a scientific perspective. But, one thing I've always found, in my career and maybe my life even, the best thing about having an identical twin, possibly the only good thing really, is the spare organs. Fortunately, neither of us had to use those yet. But on this mission, I had the opportunity to do a spacewalk. One of the most challenging things, both mentally and physically, I've ever had to do. And this is absolutely one of those moments where you need to just focus on the stuff you can control, which is your tethers, your tools, your procedure, your jobs, and ignore everything you absolutely have no control over. And the fact that you were in a vacuum, flying around at 25 times the speed of sound with this huge distraction in your face, which is our beautiful planet Earth. Beautiful, and at the same time, sometimes kind of scary to look at. The atmosphere, very, very thin and fragile looking, pollution over certain parts of the globe almost continuously, and of course, the depletion of the rainforest. So we launched in March of 2015, returned in March of 2016, nearly a year in space. But, after, being up there nearly a year, it was time to come home. All good things must at some time come to an end. And me and my Russian colleagues, we get into the Soyuz spacecraft. I told you it was small, right? Really, really small. We close the hatch, we undock, we get about 5 miles away, fire this deorbit engine, very much like the space shuttle comes home. You fire the engine, and that slows you down by a few hundred miles an hour. The space shuttle, very risky. I had 3 of my classmates and 4 other colleagues killed on Columbia during re-entry. But the space shuttle's big. It lands on a runway. It's kind of more like driving a Rolls Royce down Park Avenue. Soyuz, much more medieval experience. The engine cuts off. The 3 sections are exploded apart. You're in the middle one. There's all this debris flying around outside the window. Pretty soon you're in this 3,000 degree fireball, and pieces of the heat shield are flying by, and the window is right on the side of your head. It's like the sun is right here. It gets hot inside. The whole thing's kind of like going over Niagara Falls in a barrel, but while you're on fire. And as soon as you realize you're not going to die, it's the most fun you've ever had in your entire life. Parachute opens and you're thrown around like crazy. Your vestibular system's messed up, so it's probably not as crazy as you think. But then you drift gently down towards planet Earth. Kind of like a car crash. Not a slow one either. A few minutes later, the Russian rescue forces show up. They open the hatch, and it, smelled like the first time I had ever breathed fresh air in my entire life. They pulled me out of the cockpit. I wasn't really feeling all that great, but, I had this big smile on my face, only because I was trying to look better than my 2 Russian colleagues. Within 24 hours, I'm home in Houston, Texas, and I get to see my family for the first time in a year. Get home and I walk in the front door, out the back door, jump in the swimming pool, come back inside, had a beer and an apple pie that was sent from the White House. Took a shower for the first time in a year, slept in a bed. All those things were great. But the best part about this was just knowing that I did the hardest, most challenging thing I think I will ever have to do in my entire life. And then being able to share that experience with my family, my friends, and you guys here today. I didn't feel great, physically. I felt, really, it really took a toll on me. Soreness, stiffness. I would stand up and I feel all the blood rushing out of my head down to my ankles. My ankles would swell up like water balloons, hives and rashes anywhere my skin had, touched anything. I was nauseous. I was dizzy. But after, probably about 6 or 8 months, I felt almost completely back to normal. I learned a lot being an astronaut. I learned a lot about leadership, and they're all different styles of leadership. People used to ask me, well, what kind of leader are you? And I think, sometimes it's important to, recognize members of your team that know more than you do about something and defer to them. Other times more collaborative. Sometimes I would get people's opinions. I make a decision. In space, every once in a while, it's time to be the authoritarian. Time to be the dictator. If there's a fire in space, just, decide what to do and announce it to your crew. Learned a lot about diversity working at NASA for my first part of my Navy career when I was really in the Navy. It was a bunch of white guys flying airplanes. And it wasn't until I got to NASA that I realized, the power of having this team that comes from different backgrounds, different cultures, different educational experiences, really different whatever. When you have people that are different, they're going to bring different solutions to problems. That's basically what NASA does. We're really good problem solvers. Learned a lot about, planet Earth and, how we need to take care of it. I'm a big believer in going to Mars, but not at the expense of this planet. I mean, we need to take care of this planet. It is the only one we will, as a species, really be able to inhabit. And of course, you get this perspective of being in space that some astronauts have termed the overview effect or orbital perspective, where you see Earth, not as different countries. You don't see political borders in space. You see a planet, people are on there. We are all connected, with this pandemic, more so than I ever really thought we were. And we need to work together to solve our problems. When I was leaving the space station for the last time, I'm looking outside at this incredible facility we built. And I'm thinking, we built this 1 million pound structure while flying around the Earth at 17,500 miles an hour in a vacuum, in extremes of temperatures of plus or minus 270 degrees, built by an international partnership of 15 different countries, different languages, different cultures, different technical ways of doing things, connecting modules together, some of which had never touched each other before on Earth. This space station, it's the hardest thing we have ever done. Harder, I think, than going to the moon. And if we can do this, we can do anything. If we want to go to Mars, we can go to Mars. If we want to cure cancer and put the resources behind it, we can do that. Get through this pandemic, fix the challenges in this country, economic or otherwise. After spending a year in space, I was absolutely inspired that if we can dream it, we can do it. If we have a goal and a plan, if we're willing to take risk, make mistakes, times being willing to fail, if we focus on the things that we can control and ignore what we can't, and if we work as a team, because teamwork makes the dream work. We can choose to do the hard and challenging things. And if we do that, then the sky is definitely not the limit. Thank you very much, ladies and gentlemen. And would love to answer any of the questions you have. Thank you.
Right. That was some truly inspirational stuff. As a fellow bad student, that was truly inspiring. And I still maybe have some chances to become an astronaut. I'm still learning how to take risks, though. That smoker's story just had me with sweaty palms. I highly recommend him reading his experience in a book called Endurance. It was such a gripping read, and I would like to thank Scott for sharing his wisdom and experience with us today. We're setting up for a Q&A right now with Manish and Scott, so please hang tight for a bit. In the meantime, please do tell me. I am reading the chats. I'm looking at all the chats. So if you've got any other questions that you would like to share, just talk about it on the chat, right? Yes, and we'll just doodle around for a bit while we wait for Manish and Scott to get set up for their Q&A. What did you like best about his Scott Kelly's talk? Go on. The book's name is called Endurance. And I would highly recommend reading the part where he comes back. That was gripping. And the thing is, Scott Kelly was so descriptive with his words. That's pretty much how I would put it. I mean, choice quotes like, "You float gently back down to the earth, kind of like a car crash." Wow. Yeah, he's a great person. I agree. Dashaita, I agree.
Thank you, Captain Scott Kelly. I absolutely loved your presentation. You are such an inspiration to the entire world. And I'm truly honored to be speaking to you, Captain Kelly. It's such a dream come true, not only for me, but for all the audience that are switching in live to watch you today. We have so many folks tuning in today to listen to you speak, including a class of first graders from Atlanta, Georgia. And we ourselves have tons of questions for you. So I'm going to start you with some controversial ones. Which movie do you like more, Gravity or Interstellar?
Wow, that's a tough question. They're both good for different reasons. I think, Interstellar is more of a scientific or sci-fi movie. But I would have to defer a little bit to Gravity because, that's one of the few space movies I've watched in space. I actually watched Gravity on the International Space Station. And, I know people have a lot of criticism over the physics of it. When I watch a space movie, I kind of look for the things that are right about it, not the things that are wrong. And when I watched it on the space station, it was just really fascinating how all the CGI stuff and how the realism of the space station looked. It really made me feel like I was on the space station, which of course I was. But it's actually like watching a movie of your house burning down while you're sitting on the couch. So a little bit weird. But I would have to say Gravity. But now that you asked me that question, I'm going to have to go watch Interstellar again.
Absolutely, you should definitely watch it again. What kind of internet speed do you get at the ISS now that you are streaming movies there? Is it good?
Well, you don't stream movies. They actually uplink them. Maybe you can now, I don't know. But, the capability is always getting better. When I was there, you could watch like a YouTube video, but it would be almost like when we used to have dial-up. And I know their kids are like, what's dial-up? They probably don't even know what dial-a-phone really means. But, our bandwidth was, challenged. It probably still is. But, our connection capability is pretty good. I mean, you can get on the internet and look at things, but streaming video at the time was hard. We actually have live TV that isn't great quality, but still allows you to watch things live. But most of the stuff, the video content is stuff that they uplink over a long period of time while you're sleeping, and then it's available to you the next day.
Very nice. Next controversial question: Are aliens friendly, and can they code?
Are aliens what?
Are aliens friendly? Are they our friends?
Navy, I visited Area 51, and I hate to tell you, there are no aliens there. It's because we moved them all to Area 52.
All right.
Actually, when I became an astronaut, I was hoping for the briefing on my the alien thing and the astronaut bonus, and neither of those exist. So, but if you consider the size of the universe, I would actually think that it's probably likely that there is intelligent life out there somewhere. And if you think that if there is intelligent life somewhere, it's probably pretty prevalent considering the size of the universe. And I would imagine they code, right? Because what kind of aliens wouldn't code? Seems like an alien kind of thing to me.
And I hope they code in GraphQL. So this one is from me. I'm a father of a 4-year-old daughter and a newborn, and I'm always looking for parenting tips. Now, you grew up in a family which created 2 astronauts. What do you think your parents did right to raise you guys?
So our parents, they weren't the type of parents that would sit down and help you with, help us with our homework. Like I said, I was a bad student. My brother was a bad student starting off too. He kind of figured it out much earlier than I did. But, one thing they always left us with this feeling, and I think they probably told us this is why I had this sense growing up, and that is, it was possible for me to do anything that I aspired to. There was nothing that was outside of my abilities or reach. So, despite bringing home bad grades, I still always had the feeling that, if I wanted to do something, maybe be even like a medical doctor or something, that was possible for me. It was just a matter of me choosing to do it. So they kind of just left my brother with this idea that everything was available to us if we were willing to work hard enough for it. And that's kind of what my mother showed me as a kid when she became, a police officer at a time when that was not very common for women.
That's an amazing message there, I think. Giving the kids the freedom to choose and making them believe that they can do anything. So this next question is from the class of first graders from Atlanta, Georgia. Why is the work of astronauts important?
Well, the work of an astronaut is, you're at the kind of the tip of the spear for NASA. You're the visible person that has this privilege of flying in space. But I think space flight in general is a very important thing. When we do the hardest things we can possibly do, it provides benefits on Earth. It develops technologies or maybe not develops them, but absolutely accelerates them. Those are technologies that we use in our daily lives. It allows people to, dream that it is possible to do things that we don't really think is capable. NASA's budget is, a lot of money, but I think the value we get at it is so much more than just, thinking about, doing science on the space station. If you consider the effect of the inspiration NASA provides to kids all over the world, not just in the United States, to study science and math and become engineers and scientists, and how so very critical and important that is to our economy, to our national security, to the economy of the world. It is, I think, something that you really can't put a value on. So, I'm a big believer in space flight, a big believer in going to Mars. We will get there someday. I hope it's in my lifetime. Possibly, there's a kid out there right now watching that would be potentially the first person to step foot on Mars someday.
Absolutely. I think that Mars is extremely exciting for all of us in the entire mankind. And I think that's the next question is about Mars. In fact, how different might living on Mars be compared to the International Space Station? Would it be easier? Would it be harder? How would that be?
Well, it'd certainly be different. I mean, the gravity will help. Having 1/3 of the Earth's gravity will be very helpful. You'll feel better because of it. You're not going to have this fluid shift to your head like we do in microgravity on the space station. It'll make many things that we do in our daily lives easier. For people out there, just think about the room you're sitting in. If there was no gravity, how everything would just be floating around unless you put it away. So those kind of things will be easier. I think the reason it will be harder and more challenging is you're so far away from Earth. Not only is that going to affect the people psychologically, but it'll also affect your ability to talk to people real time. I mean, you're going to be relying on recording videos and email to have conversations that are going to, it's not really going to be a conversation. It's just going to take a really long time. The other thing about, living on Mars is, you can't go outside like the space station. I mean, you can do a spacewalk, it'll be similar, but, the idea of just walking out in your yard and getting some sun on your face, some wind, some rain, like the space station, that's what people are really, really going to miss. I don't prescribe to this idea that you would, send people on a one-way trip to Mars. I wouldn't be interested in that myself. I'd certainly be interested in watching that reality show, because I think after a while, when the novelty wears off, it'll probably be like Lord of the Flies.
That's such an interesting comparison to make, and probably and quite true. The International Space Station is such a collaboration, right? Different countries, different people, different cultures, different languages, trained in different systems. As you mentioned, Russian spacecraft does not have the countdown as NASA spacecraft does. So what techniques do people use to keep everybody in sync? Is it hard because of different languages?
One thing NASA does well that I think all of our other international partners do is we have a selection process that kind of vets people to be the type of people that would work well together, be part of a team, have demonstrated that ability, and also people that are good with handling the challenges of the unknown, the stress of, living in space where, in an instant, you can go from, everything being great to, trying to affect your future and your life and that of your crew members. So, I think we do a good job of that. We actually take astronauts and cosmonauts and send them on trips in the outdoor to stress them and challenge them in a difficult environment. We have a facility that we've use that is under the sea in a situation where you're diving it's called saturation diving, where you can't surface. So, it's a combination of vetting and training that allow, people to function well as part of a team in these kind of challenging environments.
And I know we are almost out of time here, so I have one final question. You mentioned COVID-19. A lot of people are stuck at their homes, which reminds me somewhat of the confinement that you might have experienced at ISS as well. How do you maintain a positive mental health during confinement like this?
Yeah, and that's kind of one of the things I wanted to talk about at the end to kind of summarize. And so I'll just go into that right now if you agree that's okay.
We could probably cut to your closing remarks in that case, potentially.
Okay, why don't we do that? Because that's what I wanted to close with.
Awesome, great. Well, thanks a lot, Captain Kelly. It was great to ask you all these questions. And again, great to be talking to you. Over to you for closing remarks.
Well, thank you. Thanks for having me. And, I just want to say a few final words, especially you mentioned there are kids out there. And these are certainly challenging times that we're living in. I spent a year on the space station. I was able to get through that with as much energy and enthusiasm at the end that I had in the beginning. And I think part of that was having a plan, having a schedule, understanding that this was my job. And, I think, dealing with this pandemic, it's all of our responsibilities. And, it's not easy, but it will someday be over. And when it is, I think we all should strive to look back on this experience and think that, we contributed to this, the solution in a positive way. I think it's important, to schedule time for work or homework or going to school, to schedule time for hobbies, for exercise, to get outside if you have that ability. Get your information from trusted sources. There's so much disinformation out there now. One thing I learned at NASA was everything we did was not rocket science. But when it was rocket science, you need to trust and get your information from rocket scientists. So, look for information from the experts, from trusted sources, and understand, we're all in this together. And, like I said earlier, teamwork makes the dream work. So thank you very much.
Right. Thank you, Captain Scott. That was quite an interesting Q&A, quite an interesting talk to begin with. And I've learned a lot what it means to be resilient and what it means to endure, to overcome the challenges that life throws at you. So once again, thank you, Scott Kelly. It was an amazing talk, amazing Q&A. We do have other events coming up. Our next speaker is Robert Zhu, Principal Developer Advocate at AWS. His talk will go into one of GraphQL's superpowers, which is type safety. Now, as a guy who owns this book, I'm so excited to see what type safety actually means. He will show us how to bootstrap a TypeScript project that uses the GraphQL schema as a way to detect and prevent API changes. So let's welcome Robert.
Hello, everyone. Welcome to GraphQL in Space. Big thank you to Dgraph for hosting this conference and for having me. This is a picture of the International Space Station, and it is absolutely incredible. Just take a look at the size of this thing. There are apparently 3 people living and working on it right now. And we know that it's too big for any spacecraft to deliver into orbit in one trip. So that means it had to be delivered in pieces, and then it had to be assembled in orbit. Could you imagine when those 2 central modules had to fit together for the first time and form that perfect seal and start communicating status to one another, start transferring electricity? It must have been an incredible moment. And that kind of integration challenge, as an engineering problem, software professionals face this kind of thing all the time. Now, they don't have to do it in space, but nonetheless, they face conceptually similar integration challenges. That's why I want to talk to you about full stack type safety with GraphQL. I'll be your host, Robert Zhu, and I'm a principal developer advocate for Amazon Web Services. Now, let's say that we're trying to integrate a client and a server. One of the most important considerations you can make about the client and the server is the protocol that they're going to use to communicate with one another. In many ways, the protocol is going to dictate the shape and the style of the client and the server. It can have deep implications for what kind of performance your application can achieve, how quickly it is to build new features. And just to give you a couple of examples, the protocol also operates at multiple different layers. At the lowest layer of abstraction, we might be dealing with UDP versus TCP. And as we move up the layers in terms of abstraction, we might be talking about HTTP request response, or maybe we're using a WebSocket. And even higher than that, we might be talking about the architectural style. Like, are we using REST or are we using GraphQL? Now, one really important aspect of protocols, and one aspect that I'm really happy to see a lot of development on over the last few years, is an emphasis on the type safety of the protocol. Now, what I mean by type safety is, let's say you have a server, and the server creates appointments for you. The client is trying to say, hey server, I'd like to create an appointment. Here's the start time and end time. As it sends those two pieces of information, how does it express that? Are those timestamps Unix epochs? Are they strings that follow the ISO 8601 datetime format? The client and the server have to agree, right? Because that's not a trivial difference. One, first off, just as a data type in any type-safe language, that's the difference between a string and a number. And the second thing is, even if it were a string, you have to kind of agree, like, what is the encoding of the string? Now, it's no coincidence that I call out type safety, and type safety happens to be one of the superpowers of GraphQL. So here's what an application of GraphQL might look like when you fill out those boxes. On the client, you might have a web application built with React, and then on the server, you might have a GraphQL endpoint built with type GraphQL and Apollo server. And of course, tying together both of these components is your GraphQL schema, your definitive type system that spans the client and the server. Now, once you have a GraphQL schema, on the client, you can use a tool such as GraphQL Code Generator, and you can consume the schema to generate type-safe client bindings. And this can create a huge difference in the development experience as you build the application. It can create a totally different experience when you detect API breaking changes or when you add new features. And I want to show you how all this fits together in an end-to-end application that uses TypeScript and the following architecture. Here's the repo that we're going to use. Feel free to clone this and follow along, or just read along and go through the code as I show you. All right, let's get into the code. Before we dive into the code, let me give you a quick tour of the application. It's a to-do list manager. I know, you've seen 1,000 of these. And I think the reason why we keep using these as examples is because you know what you're building feature-wise. It's just variations on what the tech stack looks like. So here we go. I can create a new list here. Let's say I want to build the International Space Station, and then I can add to-do items to this, like learn how to build solar panels, or find a rocket. That's going to be important. And then as I'm done with these, I can check them off, and then I can clear done. All right. Hopefully that's pretty self-explanatory as for what we're building. Now, as I was going through that though, you can probably infer that there were a couple different API calls going on between the client and the server. We built a list, for example, but in the very beginning of the application, we also loaded lists and existing lists, right? We added an item, we checked off an item, and then we cleared done items. So let's take a look at the GraphQL API just to see how all these different API calls are structured. So here's GraphQL Playground. GraphQL Playground is one of the GraphQL IDEs. And with GraphQL Playground, we can author our GraphQL query in the left, hit play, and then we'll see the response come back in the right. But what we're really after is the schema. What does the schema look like for this particular application? And here it is. It's really simple. And whenever I open a schema, the first two things that I look for is the query type and the mutation type, because this tells me what is the system expressing in terms of its capabilities for reading data, and what is the system expressing in terms of its capabilities for mutating that data. All right. So with query, really simple. I've got all lists, and I can fetch a list of to-do lists. Okay. With mutations, I can add a list, I can add an item, I can set an item to done, and I can clear a done item. And these are all of the operations that we identified just kind of by analysis, right? Now, obviously, we can do this with a really simple application, but with a more complicated application, it'll be hard to exactly correlate what you see happening on screen versus what GraphQL queries and mutations and subscriptions might be going on in the background. Nevertheless, always really, really important to take a look at your GraphQL schema. Now, the other thing I want to point out is look at to-do item. To-do item has a breakdown in terms of the scalar fields that it supports and their types. For example, it's telling us name is of type string. And not only that, this exclamation means that it is a non-nullable string. Priority is of type float, and it is also non-nullable. And done is Boolean. Now, this is what I was talking about with respect to type safety and why GraphQL is so good at this. Because the schema definition language here is telling us unambiguously, if you ever get a to-do item out of the API, this is the structure and these are the types for all the scalar fields. That is incredibly powerful, and we'll see how to combine that shortly with GraphQL Code Generator to turn this into client-side static types. Okay, we've got our repo cloned, and I have it open here in VS Code. And what you should see when you clone the repo is two folders at the root, one called API, the other called dub. And these are two separate projects. Dub is just a folder containing the contents of create React app with the TypeScript argument. And then API is a Node.js project that is going to be running type GraphQL along with Apollo server, and of course, all built with TypeScript. Okay, let's take a quick tour through each one so you can see how all this fits together. Starting with API. Okay, within API, let's go into the source folder and open up server.ts. This is our entry point. And what we can see here is there's not a lot going on. We're creating Apollo server here. We're listening on port 80. And we're building a schema to pass to Apollo server. Now, we only have a single resolver in this list of resolvers, this to-do list resolver, which means that all of those operations that we saw in the GraphQL schema must be defined within this one resolver. So if we navigate to the definition of the resolver, we can see that indeed, yeah, this is it. Not a lot of code. We have that one query, which lets us fetch all lists. And let's just take a look at this one. Remember, in the schema, we had a type query, and the query type contained a single root query, which was called all lists, and returned a collection of to-do lists. Now, the way that we express that in code is just these 4 lines. We have this @query decorator, and this is a decorator that comes with the type GraphQL package. And what we're saying is that it returns a list of to-do lists. And then here's the function that runs, that backs the resolver. So this is a promise, and then it's going to call get all lists. And get all lists is just going to perform an async read from a file, basically. In this demo, it's really simple. In production, of course, you'd be backing this with some sort of database. Either way, it's going to be an async call, so this function is asynchronous. And then all of these are decorated with mutations, which means that this is what is causing those 4 root mutations to appear in the mutation type. Here you can see that we've got add list, add item, set item done, and clear done items. This is it. So now we have this one resolver file that almost looks a lot like the schema. And in fact, if you take a moment and familiarize yourself with this, you should be able to predict exactly what the schema is just by looking at the combination of resolvers. Now, that's it for the server, really. There's not much else to it. As you're playing around with this demo yourself, if you're wondering where the data is stored, that's going to be under the data directory under state.json. Not a whole lot going on there. I'll let you explore that on your own. So let's move on to the front-end React application. This is www. And again, we'll drill down into the source directory. Of course, index.tsx, our standard create React app entry point, just says, hey, look, we're going to render this one root element called app. That's going to be defined in app.tsx. And the potentially the most interesting thing going on here is this store provider. So this is how we're doing state management for this demo. We're using the use context React hook, which is a way to do really lightweight state management. I do not recommend you use this for larger applications, more complicated applications where a lot of data is changing. It's not that efficient at that scale. You probably want to reach for something like Redux or Relay even. But in this case, just for the purposes of this demo, the store use context hook pattern for React state management is sufficient. It's super simple. We have up here use effect. And all this is doing is it's replacing component did mount. Whenever the component has mounted, we just want to call store.refetch, and that will refetch all of the lists in the server. And down here we have pretty simple. We have a header, and we have a button to add these lists, to add new lists, and then we have a lists grid down here. All the other items I think are really simple. They're self-explanatory, so please feel free to explore them at your own pace as far as the React application goes. Now, the thing that makes this React application interesting is its integration with the GraphQL server. And to see how that works, let's open up the GraphQL folder. And let's take a look at a couple of these files. Probably the first one is this getAllLists query. It's a .graphql file. And you can see up at the very top, we're defining a query called getAllLists, and then we're just fetching the AllLists root query field. And we're saying for each list inside this AllLists field, we want to fill that out with this fragment. And a fragment is just a reusable snippet of GraphQL. But within the, when you use the combination of fragments with code generators, you get another quality, which is that the fragment becomes its own type. So it's a way to take a very large type that would have had all these fields and nested fields embedded in a single type, and to break it out and say, hey, that nested field that goes two levels deep, that's actually a separate type. And by defining these things as fragments, you get two separate TypeScript types generated out of these. So what we would see here is there's going to be something generated, a type generated just for full list details, and another type generated for full item details. And that's going to be really useful as you start to pass around these different parts of these documents that come back in your GraphQL response. Okay, so this is getAllLists, and let's just go through one more .graphql file just to make sure that we see the different variations here. We'll look at add new item. Add new item is a mutation, and this takes in new item input, and it fetches a bunch of fields when you've added a new item. Pretty simple. And the way that you can do this is you don't have to write these .graphql files by hand. You can just author these right within GraphQL Playground. And then when you've got the query looking exactly as you want it, you can take the entire query and paste it into the .graphql file and then run code generator. Speaking of running code generator, let's take a look at that. I'm just going to open up embedded terminal within VS Code here, and then I'm just going to run npm run codegen. Now, Oops, I'm not in the right directory. That's why. So I need to be in www in order to run npm run codegen. And you can see that it's really fast because the server is running on localhost, and I've configured CodeGenerator to talk to the local GraphQL server, pull down that entire schema, and then generate the TypeScript types. So what it's actually doing is two steps. When it pulls down the GraphQL schema, it stores that in this graphql.schema.json file right here. And you can see that this is the JSON representation of that GraphQL schema, of the entire GraphQL schema. So that the file can actually get quite large. And I don't think a lot of people read this file manually, but you can. It does make sense. It's just a little bit verbose. But this is the schema. This is our serialized schema. Now, the second step that the GraphQL code generator is going to do is it's going to take a look at these GraphQL files. So let's say add new item, right? When it overlays this mutation .graphql file on top of the schema that we have, it's able to generate a type-safe TypeScript type. Because it knows, well, if you executed the add item mutation, then where you're getting back is a to-do item, and if you try and select these fields off of the to-do item, then we know the types of those items from the schema. And as a result, we can generate a type that exactly matches the structure and the shape of this .graphql file here. Okay? And that's exactly what it does. And when it does all of that, it dumps it all into this generated .tsx file right here. This is a generated file, and of course, GraphQL code generator can be configured to put this file wherever you want. Lots of different options, but we're not going to dive into that in this talk, though. You can take a look at the docs for that. But this generated file then, you can then go and create some really simple wrappers. One way you can integrate this is to integrate this directly within Apollo client, and you can basically use all these things as a higher order component. Or another technique that you can do is kind of like what I did right here, which is that you have a wrapper function around any particular function that you want, and then you can pull them out and use them outside of the context of a higher order component. And I think this offers a little bit of flexibility, but at the cost of, you know, a little bit more typing. So that's it for the tour of the code and how these two projects fit together. Next, I want to show you what happens when you make a change to the server. So in other words, what does an API breaking change look like, and how does that affect your developer workflow? All right, last thing I want to show you is what the developer experience looks like when you have API breaking changes. And while it's desirable to avoid API breaking changes whenever possible, sometimes it's inevitable. And in order to simulate this, let's say that we've been gathering feedback from our users and they love the to-do list app, but they just want one addition, which is that we add the ability to specify the priority for a given to-do. That's really easy to do. You just come in here and you go into new item input. And remember, new item input is an input type that describes all of the input variables that we need to collect when we're creating a new item. Here we have list ID, name, and description. List ID being the ID of the parent list that this to-do item belongs to. So in order to add one more field to this input item, we can just follow this pattern here. Just grab one of the description fields here, and I'm just going to change this to priority, and then change the type to number. And then by virtue of having this TypeScript type annotation of number, type GraphQL is going to pick this up and say, this is something of type float. Now, what we've done here is that we've basically, by default, type GraphQL will say all the fields here are required. And if I wanted to make it optional, or in other words, nullable in GraphQL terminology, I can come in here and say nullable equals true. Now, if I did this, then that means that this is actually not a breaking change, because prior versions of the client are sending the prior 3 fields. They don't include the priority field, but the server says that's okay. And again, in order to induce the error, we're going to make it work like this. And what this is going to do is say, anytime you try to create an item, you need to provide these 4 fields. But we have a web front end that is not providing 4 fields. So we should expect to see it fail. And it'll be interesting to see how exactly it fails and whether or not there are any important error messages that help point us along the way in terms of fixing this problem. So first, let's flip back over into our browser. And the first thing is I'm going to refresh GraphQL Playground. I'm going to pop open the schema. And right here on the new item input type, we can see that the change that we made is now live inside GraphQL Playground. It is now present in the schema, saying that anytime I get a new item input type, I have to have a field of type float called priority. So far, so good. Problem is that this client over here is not sending that priority field. Let's see what happens and how it breaks if it tries. So first thing is we're going to have a test list here, and now test item. Okay, didn't work. Unhandled rejection, error, network error, not responsive. So I think probably what we want to do is open up the network tab here. Try again. Okay, so we see that there is this one HTTP status code 400 in response to our post. And the response, I know the text might be a little bit small, but you can see here, hey, we got a bunch of errors here. It looks like there was one error, no data. And the error is message, variable input got invalid value, list ID, name, description, field value.priority of required type float was now provided. There we go. Now it makes sense. That's the exact error that we would expect, although we had to do a little bit of digging through the code in order to find it. And we can definitely change the front end to look for these network errors. We just don't have a lot of good error handling in place for this demo right now. But you can imagine, proper error handling means that you can bubble this up and make it much more visible, either through development or even in production. Okay? So, how do we fix this? All right. Well, back in the editor, we have that neat little code gen function, right? We've updated the schema on the server, but the client thinks it's talking to an older version of the server. In order to resynchronize the client and the server so that they're talking about the same version of the schema, we just need to run code gen. All right, code gen succeeded. Now I can run TypeScript, compile. All right, so it says, TypeScript says property priority is missing in type, name string, etc. And we actually have to-do list view.tsx line 53. Let's go there. Here it is. Line 53. So if I add something like priority 5, and come down here, run TypeScript again. And my error has gone away. Okay, that's all it takes. And I want to point out that this is TypeScript catching this type error right now. This is not necessarily GraphQL. This is development time static type checking with the TypeScript bindings telling me, hey, this local TypeScript definition, this type definition, you're not meeting the constraints set by that type definition. Where did that type definition come from? It came from the code gen process where we downloaded the schema from the server, and then we paired it up with the local .graphql file definitions. And I know I'm trying to describe this same process in a number of different ways, but I think it's a really important concept to really understand in order to figure out what's going on here. Because if you take a development workflow like this into production, you definitely want to understand all the different ways that it can break, all the different integration points. But yeah, that's it in a nutshell. I think this is a pretty good developer experience. This is definitely a step up in terms of developer experience relative to a lot of REST APIs that I've worked with, where oftentimes the only way that you can detect whether or not this breaking change occurred is if you actually try and use the API, right? And then if there's some sort of minor API breaking change, well, all those handcrafted types are kind of outdated and you have no real way to update them. You can find an error, trial and error, oh, change this way, okay, go and update your local type definition and then hope that works. And so I think because GraphQL includes this type system, you now have this end-to-end tooling that can enable this much more high confidence workflow, we'll call it. So hopefully that makes sense to you. If you want to take a look at the code, if something doesn't make sense, by all means, leave a comment in the repo and we can interact there. But that's all I have for you today. Thank you very much, and I hope you enjoy the rest of the conference. Goodbye.
Wow, that was an amazing talk. I think I learned a lot more about TypeScript than I had expected to. That was surprising. I would like to remind participants that questions can actually be posted on the Discuss link. And at the Q&A session at the end of the day, we will answer those questions. We'll get the speakers live to answer those questions. We also have a post-talk survey for Robert's talk. It should be on a link on your chat room right now. We will reach out to folks who have filled out the survey to distribute the conference t-shirts. So the link has been posted. If you could fill that out, that would be fantastic. Thank you. Up next is Andréa Piazza, a full-stack developer at Grapl Inc. Her talk will be going into how Grapl uses GraphQL to actually help people, customers explore their data more effectively in order to catch hackers in their networks. Let's welcome Andréa.
Hi everyone, my name is Andréa Piazza and I work for a company called Grapl, where we take a graph-based approach to security. We recently transitioned our REST API to use GraphQL, and I can't wait to tell you how we use GraphQL to catch hackers. But before I can do that, I want to explain what a graph is, because it's fundamental to GraphQL and our product. So a graph is a data structure that holds on to information like a list or a hash map. It's composed of nodes and edges. We can think of nodes as nouns or things like a person or a place, and edges denote the relationships between them. So if we had two friend nodes with the name properties of Joey and Chandler, we could have an edge between them denoting that they are friends. Graphs encode information about relationships directly into their structure, which makes them powerful visualization tools. Now, I love graphs because they're so intuitive to how we think as people. There's a type of learning called classical conditioning, which takes place through the formation of associations, because learning through association is one of the most fundamental ways that people learn new things. Now, we can apply this principle when working with data, because when we can start to connect our data, we learn new things about it, and it starts to tell us what it means. Now, humans love naturally connecting things. We know this because we see patterns everywhere that we look. Think about the constellations. Different societies throughout history, in spite of being separated by time, language, and geographical barriers, have all been able to look at the stars and see the same shapes. Now, let's say we were given this data that represents stars in the form of a table, and we were asked to figure out how these stars are connected. We can see the properties of each star. There's a lot of really good data here, but it's not all relevant to connecting the stars, and we can't easily see relationships between them. Now, GraphQL lets us take only the data that we need, and we can easily start to see how they're connected. In our case, we're going to take the ID, the proper name, and the connected to ID columns. And when we visualize this as a graph, we can recognize that this data is representing the Big Dipper. It's a lot easier to understand how our data is connected visually. When we look at this figure, we can see how these stars are connected, and the relationships are so much easier to understand using a graph than trying to connect the data in the table on the previous slide. Now, I know you're here because you want to learn how we catch hackers using GraphQL. And the way we do that is by leveraging graph-based technologies for efficient security investigations. And we can't do that without GraphQL. We want our users to stop fighting them with their data and start connecting it. So let me show you how that works. At Grapl, we want data to be approachable and easy to understand quickly, because we want defenders to do what they do best, which is defend the network. Our goal is to help security engineers quickly identify how a compromise happened so they can fix it, instead of spending time sifting through logs. When a network is compromised, every second of an investigation counts, because they are not just defending arbitrary users, they're defending us and the people that we care about. Now, most security products force analysts to work with raw logs, like pictured on this screen. A log is just a textual representation of some sort of an event, like a process executing or a file being downloaded. A process is just a file that's running, and they often execute from a file. Logs contain a lot of information, but they don't always express relationships. As an example, if we pulled down these 4 logs and took a look at them, they might look like isolated events, but actually there are implicit hidden relationships in these logs. When we visualize logs as graphs, the relationships become clear and explicit. And this is how we catch hackers at Grapl using GraphQL. We can see that the parent process ID in one log is the process ID to another log, and we can start to think about the structure of an attack instead of just its properties. Attackers can change properties, but it's much more difficult to change behavior, so we describe data in terms of how it behaves. Now, one attack that Grapl makes really easy to identify is the technique of a dropper. It's an extremely common malware attack that stages itself across multiple processes. It's a process that downloads a payload and executes it. It's a good example of a general structural pattern because we don't care about specifics like process or file names. Now, when we visualize our dropper as a graph, we can see that this graph is telling us a story. It's describing malicious behavior in terms of its entities and relationships. So we can see that this process executes, so maybe someone clicked a link that they shouldn't have, and the malware reaches out to a network where it downloads and creates the malicious file. Once that malicious file is executed, our system gets invaded and we're in some trouble. Now, we started expressing dropper behavior using REST, like most security tools, to expose their data in the form of entities and lists. And this is really expensive for a dropper attack because we would need 4 different endpoints and a lot of code to map between them. You can see that to express the dropper behavior on the previous slide, we would have to make 4 calls to our server using REST. Now, let's contrast this with our GraphQL query, where we can express the entire attack in a single query and a single server call. So GraphQL makes expressing a dropper really easy for us. It quickly became apparent that REST was no longer working for our product, and we needed something more powerful. We had a lot of overly specific endpoints, which were really slow for our server and for us as developers. Building specific endpoints for every variation of data can get tedious, and if you've ever built REST APIs, you know what I'm talking about here. We had a lot of inefficient queries because there's this trade-off with REST where you can over-query the server and get too much data back, or you can make a lot of very specific queries and make a lot of server calls. We only wanted to get the data that we needed because we ingest a lot of data, sometimes terabytes a day. So that means there's a lot of data that we don't need. We wanted to be able to describe exactly how our data should look. And finally, building REST endpoints were just not an efficient use of our time at Grapl. Our front-end work was often blocked waiting for new endpoints, and we needed to iterate quickly. And GraphQL was simply more efficient. Now, once we decided to make the move to GraphQL, I was a little bit intimidated at first because I knew very little about the technology and nobody at our company had ever used GraphQL before. All of my experience was with REST and SQL databases, so this was all very new to me. When I started to look into GraphQL, I was quickly overwhelmed because most of the resources were tied to vendors, so it made it hard to tell where to start with the ecosystem. I just wanted to learn how to build and use a GraphQL server and figure out the best practices later. I kept going back and forth on whether or not to use the SDL, but ultimately we chose a code-first approach. We wanted to keep it simple, stick to what we know, and leverage the features that we already knew in a language that we were familiar with. In our case, it was JavaScript. So our first iteration avoided custom clients with fancy features because we just weren't ready for them yet. And our conversion journey began. So our first step was to build our GraphQL server. We chose to create an Express server using the Express GraphQL library. This helped limit what we had to learn to get started because we used an Express server for our REST API. We used GraphQL HTTP to set up our GraphQL server, and it's the only endpoint for the entire project. It's /GraphQL, and it handles all of the requests coming in. We then passed in an empty schema from our schema.js file and deployed it to an AWS Lambda. Now, if you are thinking about a conversion, after your GraphQL server is up and running, you can follow the next steps in whatever order makes sense to you. GraphQL is language agnostic, so there are many different ways to approach a conversion. So do what works best for you and your team. What made sense to me was to pick an endpoint that I was familiar with and convert that first. We chose to analyze the data that it returned and started to create types around the returned data. Now, GraphQL is very strictly typed, which is beneficial because you know your data, but it's also challenging because you have to know what to return. You might have to add or remove fields until your type is right, so this step takes some patience, but you'll get there. So this is our process type, and you can see that we were using some scalars like ints and strings, and we were also using some custom types to support our process type, like our file type and our process outbound connections. Once we had our type, we could start to create our schema because we knew the data that we wanted to return to our clients. Our schema consists of a single root query, and it has different fields that we can query for. A query field in GraphQL is similar to a REST endpoint. A GraphQL query requests and returns data just like REST endpoints. So instead of having a process endpoint, we now have a process query. So you can see that we have a process field in our root query. This is the implementation of our process query that returns a list of process types, which we saw the definition for a few slides ago. It takes one argument, a process ID, and it's an integer. Now, once we know the data that we want, we can implement retrieving that data for our query in the form of a database call. This was pretty simple because we already had our database calls from our REST endpoints. We use Dgraph on our backend, which is a really natural fit for our product because they use GraphQL as a query language for their graph database. We have a lot of data that is constantly changing, and Dgraph supports ACID transactions, which help keep our data consistent, so we don't have to worry about it getting corrupted or out of date. They have an extremely strong write performance, which is important because Grapl ingests a ton of data in a streaming fashion. They also have a strong commitment to open source with an Apache 2.0 license. We are an open source product, so we love other open source products too. And they run in Docker. So this code implements our resolver. We call a function called getProcess and pass in a process ID. Our getProcess function opens up a client stub to Dgraph, where it makes a query to our Dgraph database. This looks really similar to our GraphQL queries. We use the arguments passed in as functions to our filters to Dgraph so we can retrieve our data. Then we return our data from Dgraph as a JSON object. Once we complete our query, we want to make sure it's working. We do this by testing in Graphical. Now, Graphical is every developer's dream tool. It's self-documenting, so we know what queries are supported and what types we can query for. Now, one thing I wish I knew before using Graphical is that you have to refresh the page to see your types. This is probably very obvious to most people, but if you work with React like me, you're used to your websites automatically updating. And this took me longer than I would like to admit to figure out. But we can query for a process with the ID of 1389, and we ask GraphQL to retrieve a node key, a process ID, and a process name. If you think back to our process type that we worked on earlier, you'll remember that it is comprised of many different fields. We look at the response from our query, and you'll notice that we only retrieve the data that we asked for, which is so cool. Finally, we find where we were calling our process endpoint on our front end, and we replace that REST call with our process endpoint to our GraphQL server. This should look familiar because it's very similar to REST. We make a post request to our GraphQL endpoint, passing in the query that we just wrote in Graphical, and we send up some headers, some credentials, and they return our response as JSON, and we can display this data to our users. Now, overall, our transition went really well. GraphQL was not as intimidating to work with as I initially thought. They make it really easy to work with once you get the right mental models down. But of course, there were some challenges. Finding resources, like I touched on earlier, was a little bit more challenging because it took more time than I'm used to. I was constantly second-guessing my approach because there were many resources indicating different ways of using GraphQL, and a lot of the resources out there just weren't useful because there were a lot of people just experimenting and not a lot of resources about GraphQL in production. We found that Slack channels and communities made this a lot easier. Now, we work with a lot of dynamic types, which are still an ongoing issue. At Grapl, we store nodes with types that are provisioned at runtime through our plugin system, so we don't know what every node looks like on the front end because our users upload them. But GraphQL has to know every field that you're querying for. And so for our dynamic types, we're currently grabbing every field and storing it as a GraphQL JSON object. This works for now, but we're losing some of the benefits of GraphQL and still considering other ways we might be able to solve this. Now, GraphQL has a completely different method of handling errors than REST. All errors come back in an array as a response from our server. They are notoriously vague and hard to decipher. For now, we have a generic error encoded into our server anytime encoded into our schema anytime a query fails, but we're still working on supporting more descriptive errors. Now, Grapl supports a lot of node types, currently around 25, and it's still growing. We need large unions to retrieve our graph, which is not enjoyable to work with, so we end up writing lots of partial fragments, which means we have a lot of code just to pull data out. It's good because we can get the data that we need, but it's not fun because it's a lot to type out as a developer. Now, overall, our conversion went really, really well. We are already experiencing so many benefits. One of the benefits that I enjoy the most is introspective. Like I mentioned, GraphQL is self-documenting, so it tells you what queries are available and what fields you can query for on the server. Our development is a lot faster because we no longer have to write our tedious REST endpoints, so we are more productive. GraphQL is also typed, which helps us catch bugs, making it easier to understand what our data looks like, in turn making it easier to work with our data. And there is a lot less server strain. As you saw in the beginning, we have fewer calls to our server, which means there are fewer resources on our server to handle the work. So our product is faster for our customers. Now, the benefits I just mentioned are often mentioned in most GraphQL talks. But at Grapl, we're committed to building powerful APIs for our customers so we can enable clients to think about data in terms of how it's connected. We believe that GraphQL is more than just a query language or a REST alternative. It's a way to shift thinking about how you work with your data. The key innovation of GraphQL is that we stop thinking about our data as isolated entities, and we start thinking about our data in terms of how it's related and connected, which means we get to learn more about the meaning of our data. You could have the coolest technology in the world, but if you can't do something new with it, it's not innovative. And what you won't get with REST is the ability to think in graphs. And that's when the innovation happens, and that's when the real power of GraphQL comes in. Now, I want to end on a quote by the researcher Brene Brown. She applies this quote to people, but I think it could just as easily be applied to data. She states that connection gives purpose and meaning to our lives, in our case, our data. It's neurobiologically how we're wired and why we're here. So I hope you were able to learn something useful. Thank you so much for spending time with me today. If you have any questions, please feel free to reach out to me. I am AZZA_314 on Twitter. And if you want to follow along with what we're doing with Graphs at Grapl, you can follow us at GraplSeg. I hope you're doing okay out there and that you enjoy whatever time you have left in your day. Thanks again for being here. Have a good day. Bye.
Well, that was interesting. And one of the things I've learned from Andréa's talk is that you can think of an attack structurally. As a former mathematician, this pleases me a lot. So thank you, Andréa. We will be addressing the questions in the Q&A session at the end. I saw that you guys have been posting questions to Andréa in the chat. That's great. We will also be picking some of these questions to talk about it. So if you have further questions for Andréa, please post them on Discuss. And please remember to fill up the survey on Andréa's talk in order to get your t-shirt. Speaking next is Alex Moon. I did say we are going with a space theme, aren't we? He's a software engineer at Gatsby, and he's working to build better data integrations. His talk will go into how you can build highly scalable web apps deployed at the edge using Gatsby, Dgraph, and TinaCMS. Take it away, Alex.
Hello, everyone. Welcome. Thank you for coming. My name is Alex. I am a contract engineer at Gatsby, and I currently have the pleasure of working with our partners and those in the open source to help them create better integrations and source plugins with Gatsby. So we have a super packed schedule, so let's get started. Gatsby, it's a meta framework, there's React, there's GraphQL, there's all these good things, and there's tons of plugins and APIs and stuff to help you build things. And those APIs and that data layer are what we're talking about today. And to give you a quick introduction, if I want to add something to the data layer, I need an API called source nodes. Now, once you're in source nodes, you can do whatever you want. So you can be fetching data off of Mars once we have databases living there. That is fine. You just need to as long as Node.js has the ability, you can fetch data. And ultimately, that data gets stuffed into a function called create node, and it creates a node within the Gatsby data layer. And with that backing, we run into a problem. What if where we're sourcing from is already GraphQL? After all, GraphQL has all this introspection and schema query ability that should make it a lot easier to integrate. We're basically having to recreate a GraphQL server in Gatsby just to source from a GraphQL endpoint. That seems redundant, and it seems like there's a better way that should just work. Before we go on, let me give you some numbers to put this problem into perspective. So our most downloaded plugins in the Gatsby ecosystem, plugins that are used on almost every site, see anywhere from 1 to 1.5 million downloads per month. Contentful, which happens to be our most popular CMS source plugin, but is also like the next most popular plugin period, sits at 230,000. It's one of the most used plugins, except for one. And that other plugin is Gatsby Source GraphQL, which will source data from any GraphQL endpoint. It's got its problems, but despite them, it's insanely popular. So let's talk about those problems, how we're trying to resolve this problem so they're not there anymore, and fix 294,000 problems. All right. So we used to have to make a custom source plugin. We covered that. Then we had Gatsby Source GraphQL. So here's the problem with Gatsby Source GraphQL. It uses something called schema stitching. And this was invented about 1.5 years ago in Gatsby to solve this problem. But it created problems. See, schema stitching doesn't use the Gatsby data layer. It kind of circumnavigates it and just makes it look like one piece, but it's really not. And where that comes into problem is content like Markdown. So usually in the Gatsby ecosystem, Markdown comes in with the MIME type of Markdown, and the Markdown plugin in Gatsby looks for the MIME type, finds it, parses Markdown, creates all the data, structured, and adds it to your GraphQL schema so it's there and available to you to use that rendered HTML directly in your React components. It's super easy. You don't have to ship code client side and slow down your users' browsers. Unfortunately, schema stitching doesn't allow that. None of those APIs are accessible on the data you pull in via schema stitching. So none of that's possible, and none of that ecosystem works. So it's very broken, and it's very confusing for new developers. And this is why we've created Gatsby GraphQL Source Toolkit. And by we, I mean Vlad. Vlad has been working on the Gatsby team to put this out there and open source it about a month ago into beta, and hopefully it's going to be 1 year soon. And this is what we're going to get into here quickly. But the toolkit basically is a set of primitives that help you do introspection and code generation to automatically query all this data from your GraphQL endpoint for you. So let's take a look. So here in our Gatsby site, we have a lot of things going on. In our local plugins folder though, let's check out our source Dgraph. So there's a lot of code here. There's about 180 lines, and here are 3 endpoints, and there's source nodes we talked about. And these are the 3 Gatsby APIs we end up having to implement, but most of this is boilerplate. Most of this is directly copied and pasted from Vlad's example. The only thing I had to customize is up here, and it's right here. It's how I'm getting the different types out of the database. And this was more how I built the schema and less about anything else. So this says, hey, get all the types, filter them down to just the valid types. And I also added additional filters so I didn't have to fetch all those types. I only fetched the types I wanted, which in this case is just film. And this is what this ultimately ended up creating, is a series of queries and fragments that the toolkit then uses to fetch and source all this data and keep everything synchronized and up to date. We'll see more on that in a bit. So with that said, we now have a site that's working, and we can actually make these queries here in our GraphQL database. So let's use that data and create ourselves a site. So we're going to create this little film database here, and we're on a page called films that will list all of our films, but as you can see, it doesn't exist. So under pages, we're going to create a film directory, and we're going to create index.js, and that'll define the path @/film. And this is a pretty basic Gatsby component. This is called a page query. It's fetching all the films and the data we want. Gatsby passes that in here as the data object, and we create this. So now if we go to films, voila, we've got our films listed out here. Now, eventually what we want to be able to do is click on these and link to a page with more information. So let's create those pages with more information. And this is where we're going to use the new file system routing API, which is also still in beta. If you look closely, you might see a bug or two. So we're going to create, next to index, with these curly brackets, which tells Gatsby this is a statically generated, like app build time page, and we're going to use the GraphQL type Dgraph film and the field name to create the slug of this page. And then, like the other one, we have our GraphQL query that fetches the data. And additionally, we have a collection query to define how to get a list of all these pages that it has to create. So with that, we can come here, and if we happen to know, there we go. We've got a page for at least Nostalgia Fire, but we have it for all the films too. Now, let's connect these up before we go any farther. So we're going to come back here to our index.js, and we're going to add this query for Gatsby path, and we've got to add some information. This is basically built in as part of the file system routing, so we don't have to make up that slug somehow. It just gives it to us. And we can pass that into a link component. And now, if we go to our own films, voila, we can link to all of our films. And we are off to the races. All right, so if we check out one of these films though, we can't see these actors and actresses yet. There's no pages for them. So we're going to create now a client-side route. So this has always been possible in Gatsby, but the file system routing makes it so much easier now. We just square brackets, ID, and that'll get passed in this params element. So let's see what this looks like. Voila. Okay, we got the ID. Now we can use this ID to make a request to our GraphQL database. And this is where TinaCMS comes in. So TinaCMS, according to their site, is not a CMS. It is a framework for building a CMS. So we define our form for what we want to be able to, what's on this page. In this case, it's just a name. And we define this function called load initial values. And here we're making a GraphQL request to fetch the actor, information about them, all the necessary variables. And now, instead of just an ID, we load this character's name and the characters they've played. So this is awesome. We want to edit this data now. So let's work on that. So in addition to our load initial values, we now want to add this on submit. On submit will, when we submit the data, it'll take that form data, it'll make a GraphQL notation and load us all up. So let's check it out. We are on Nathan Ramos here. Let's edit him. He is a senior, evidently. I know none of you knew that, but I did. We hit save, we get some notifications that this saves, and on refresh we see a nice little bug, but when it does load, Nathan Ramos is a senior. Awesome. And we can remove that if we like. all good to go. All the bugs. All right, there we go. So that is good. Let's go back to our films and make these editable. So we come back to our file for these. We define our CMS and our form config, and we're going to be able to have a name and a description here. And that is going to be an HTML editor. We have our runs, but we don't have to load the initial values because Gatsby was doing that for us. So we get film information here, and instead of loading them, we're just passing it in as a static variable. And then but if we want to be able to save that, we do need to be able to write to the database. Gatsby is not going to handle that for us. So we define our on submit, and again, we have to define our GraphQL mutation here. So let's go to, we got it. Yeah. Let's pick, let's edit this one, sugar, sweetest movie you'll ever see. I believe that's an app description. I am 100% making up all these descriptions based on the title. All right, save. It's been saved, and let's refresh, and it's gone. Oh, right. Because Gatsby fetches this data at build time. We didn't tell Gatsby the data changed. There's nothing to trigger a build, so we need to figure out how to do that. And this is where incremental builds comes in, and this is about to get really cool. This is like absolutely the coolest part of this demo, and maybe this entire conference you are going to see. So Gatsby has a refresh endpoint. It's what drives most of Gatsby Cloud and incremental builds and all these fancy things. So back here in our component, on our submit, we just need to post to a webhook in Gatsby Cloud. And that is going to, we're going to tell it the type of content that changed. So we've edited a film. We're telling it that it's updated as opposed to being created or deleted. And then we just tell it the ID. Notice we're not telling it what changed. It's going to handle all that for us. So, welcome to Master Branch, finally. Moviedatabase.moonmeister.net. If you want to go check this out, you can spam it away and it'll probably fall over and break, and then I'll just take it off the internet. So, we're on full moon. The movie here, there's nothing. Let's get our login working. All right, let's give this puppy a description. The best view you'll have all week. Let's save it. So this is going to go so fast, hopefully, that your mind will be blown. So what's about to happen? I am going to hit save. That is going to save it to the database. It's going to trigger a build in Gatsby Cloud, or wherever your build engine is, and using a webhook. Gatsby Cloud is going to do incremental builds, which means, and the toolkit's going to handle the data and refetching of the data. Once that's done though, Gatsby itself is going to go, hey, this one little piece of data changed, which means I don't really need to rebuild the whole site. I just need to rebuild this one page, this movie, and we're all good. And all that should happen in around 30 seconds. It feels like being a little slow, maybe a minute. So let's go. We hit save. On our cloud, in the next couple of seconds, we should see a build come through. It's so fast, you're not even seeing it. All right, it's already built in 4 seconds, and we're already deploying it, and we're already 10 seconds into deploying it. So as soon as this is done, deploying to Fastly, by the way, so there, 22 seconds, we were built and deployed to Fastly. We give Fastly another couple seconds here to get its stuff figured out, and this should be refreshable. So let's try hitting refresh. And it disappeared, kind of like I might have expected. We'll give it another couple seconds here. And there we go. Full moon, the best view you'll have all week. Welcome to the film database. Please go check it out. The code is all on GitHub. Please check it out. Big disclaimer, it's in the README. This is very much proof of concept. It is not production ready. So enjoy it, check it out, and have fun creating awesome, completely like client-side awesomeness that can also be great in for speed and performance. So my name is Alex. You can find me at these places, and enjoy the rest of your conference. Thank you very much.
So today I learned what Gatsby is and how integrating with Gatsby is surprisingly straightforward. And that built-in editor inside the app, ooh, I might go have a play with that now. So thank you, Alex. A reminder that you can post your questions on Discuss, and we'll talk about them at the Q&A sessions later. And Alex will be there answering questions live during Q&A. And also, please do fill out the surveys in order to get your t-shirts. Up next, we have Sam Julien. He's an Angular Google developer expert and a collaborator. He's a senior developer advocate engineer at Auth0. And his talk will go into demystifying authentication while learning how to use JSON Web Tokens with GraphQL APIs. I think this is going to be a good one, and I'm really excited to hear if he's talking about JWEs as well. So take it away, Sam.
Hey, everybody. Thanks for joining. In this talk, we're going to talk about becoming a secret agent, securing your GraphQL backend with JWTs. So this talk was inspired by an article that Hasura put out about a year ago, almost a year ago to the day. This article was about securing your front end with JWTs, and it sparked a lot of conversation and a lot of confusion and a lot of questions about then how you would use JWTs on the back end. So that's why I wrote this talk. And the truth is that auth in GraphQL, authorization and authentication, can be really confusing. We're used to doing things in REST where we maybe have this endpoint and we know we need to secure it. So we go ahead and just kind of slap a middleware onto it where we authenticate, and then we send the user a response. And this is sort of a familiar process to us. But when we start building a GraphQL backend, we kind of run into this issue where we have one endpoint instead of multiple endpoints, just this /GraphQL. So what do we do there? Do we just put middleware blocking the entire endpoint? Do we need to add authentication to our resolvers? It can be a really confusing scenario. And that's what this talk is all about. So I'm Sam Julien. I am a developer advocate for Auth0. We're an identity as a service platform. Basically, we handle your authentication and authorization so you can focus on building the features of your application. I'm also an Angular and web Google developer expert and part of a collaborators program with the Angular team. I also love to teach. I love to teach through video. So I've made videos for Thinkster and Egghead, and also have an NG upgrade course that I've made. So in this talk, all of my examples are going to be in JavaScript, usually using Apollo, but the concepts aren't really specific to JavaScript. You'll see JavaScript syntax, but this should be applicable to whatever backend language you're using. Okay, so in this talk, what we're going to do is first we're going to have some auth background. We're going to talk about some concepts of auth, and then we're going to get into JWTs. What are they? Why do we use them? And then once we cover that, we're going to focus on authorization in GraphQL. So let's jump right in. First, let's cover some auth background. I used the terms casually earlier, authentication and authorization, but what do those terms actually mean? So authentication is basically, are you who you say you are? Basically proving your identity. On the other hand, authorization is concerned with, do you have permission to access certain resources? So authentication, are you who you say you are? Authorization, do you have permission to access what you're trying to get to? So if we look at our user in relation to GraphQL, the user is interacting with our GraphQL server, maybe through a client of some kind, a front-end client, and then the GraphQL server is interacting with our database. So if you think about this, the GraphQL server is really just this intermediary layer between the user and the database. And because of this, the GraphQL server doesn't necessarily care about the user proving who they are. It actually just cares about who has access to what. So instead of the GraphQL server caring about authentication, it's mostly concerned with authorization. And we use this word access. And this is sort of the crux of the problem when it comes to GraphQL and authorization. So let's look at a common scenario that happens. Let's say we have a backend and a front end on the same server. So we have, for example, maybe a GraphQL server and then a Next.js front end. What happens is that the user will go ahead and send their credentials to the browser, and then the browser will pass that back to the server, and then the server will use those credentials to create a cookie that then gets sent back to the browser. And that's how we keep track of a session. And for this simple scenario of just a backend and a front end on the same server, this is perfectly valid, perfectly viable way to do this. But when we start getting beyond this kind of simple example, things get a little bit more complicated. Oftentimes in the real world, we end up having a scenario more like this, where we have a single front end that then is calling multiple backends, maybe our GraphQL server and then several other APIs in the cloud. Another really common scenario is to use an API gateway. So the front end is calling an API gateway, and then that API gateway is going out and getting data from various APIs around the internet. And so here what we have is a little bit more complicated scenario regarding access. Because instead of just needing access to resources that are on the same server as the front end, what we have is this problem called delegated access, where we need access not only to something on the same server as the front end, but access to multiple third-party servers and APIs. So instead of being able to do something like this, where we can just pass our credentials and get a cookie, we need another artifact, something that's going to help us in this scenario where we have multiple APIs or maybe an API gateway. The thing is that cookies don't really work in these scenarios. Cookies are really not meant for these kind of third-party scenarios. You may have heard of CORS errors, cross-origin errors, and this is sort of one of the reasons why cookies aren't a great fit for this scenario. But if we can't use cookies, what is it that we need? We need something that can contain useful information, something like the claims that the user might have about this data. And we also need this thing to be able to be signed and verified. We need to be able to prove that the little artifact that we have came from where we expect it to and is the right thing. We can't just let anybody send this artifact over and just blindly trust it. So what is this thing, and how do we safely create it? Well, this artifact is called a token. And a token is what we're going to use to store this information and send it to our servers. We create the token with an authorization server. The authorization server is what helps us make these access control decisions in your app or API. So this authorization server is going to create something called an access token. It's going to be a little token that informs the API that whoever has the token has the permission to access what they're trying to access. And here's how this is going to look. We're going to have this server, this authorization server, and it's going to create this access token. It's going to send it over to the front end, and then the front end is going to attach that token to the request that goes to our server. And this might be our GraphQL server. This also works in the scenario of the API gateway. This also works in the scenario where we have multiple servers as well as an API gateway. So an access token. What is an access token? you've probably actually seen an access token before. You've probably seen this on a header, this authorization header, and then there's this bearer word, and then there's just sort of this string of things that comes after the bearer, and that's what the actual token is. So we mentioned that this needs to be able to contain useful information and also can be signed and verified. So there's a format for this that's actually very convenient, and it's called a JSON Web Token. Now, this is a really commonly used format for an access token. It's not actually required. It's not mandatory to use a JSON Web Token, but it is a convenient format for it. And JSON Web Tokens look like this. And at first glance, this can look like just kind of a bunch of garbage, right? We don't know what's going on here. But if we break it down, it's a little bit easier to understand. What's happening here is actually that a JSON object is being run through a encoding algorithm, and then it gets spit out as this string of letters and numbers. It's called base64 encoding. And a JSON Web Token actually has 3 parts that look like this, and they're separated by periods. So the first part is called the header, and this is the algorithm and the token type. The second part, after the first period, is the payload. This is where all kind of the good stuff is. And there are some things that can be included in here and some that cannot. The one that I really want to draw your attention to is this subclaim. It's kind of like the equivalent of a user ID, and that'll come back a little bit later. The last part is known as the signature, and this is what lets us know for sure that it came from the authorization server that we expect. So now we have something that can both contain useful information and can also be signed and verified. An example of this is in Hasura. If you've ever used Hasura, if you want to include claims in your token, you add this little namespace that says hasura.io/jwt/claims, and you can add things like the roles that you expect this user to have. And then when you send it over to your server, you can just pull off those claims from the token. So what happens is the authorization server sends over this token to the front end, and then it sends it over to our GraphQL server. And so now we've got our layer between the GraphQL server and the database, or between the user and the database for our GraphQL server. And now we need to do some sort of work with that token. And remember, we said that the GraphQL server isn't necessarily concerned with proving the identity, with the authentication part, but it is concerned with the access management, basically. So the authentication piece will probably live outside of your GraphQL server. It'll either be through some third-party service or you'll make it yourself, which begs the question, should you just build your own authorization server? That's a reasonable thing to do. You totally can. The thing is that you want to be sure that if you are going to build your own authorization server, you need to remember how to implement proper password controls and make sure that you're transmitting your password securely. It's a lot of stuff to prevent, a lot of security considerations to take into place. So I do want to recommend that if you have a large, complex application, that you consider outsourcing this piece of your app. Now, I know what you're thinking. You're thinking like, yeah, this guy works for Auth0. Obviously, he's going to say that. But bear with me. It doesn't really matter if you use Auth0 or not. You should still consider using one of these types of services just because of the sheer volume of security considerations to take into place. Okay, so we've got the scenario where we've got multiple APIs, we've got an API gateway or something, and we're using an access token. Now we need to actually do something with it. And that's what we're going to talk about with authorization in GraphQL. So what happens is we get this request, and on that request to the server, we've got this authorization header, and it's got our token on it. So now we need to do something. We need to verify the token, and then get the payload off of it and do whatever we need to do with it. So we'll get the token, and then we'll parse the claims for authorization. So how do we do that? Well, the first thing we need to do is just actually grab the token off of the request and put it in our context. So what we can do is in our, this is the constructor for Apollo, we have our context function, and inside of here, we can just look for that authorization header and pull off the token and return it in our context. But we can't just blindly pull it off and then send it on our way. We actually need to verify that it's a valid token and then pull off the payload from it. So how do we do that? Well, we're going to make this function called verify token, and it's going to take in the token that is on the header, and it's going to return the payload to us. So remember, we've got this bearer word in front of the token, so we need to actually pull off, separate those two out. We can just do that with a string split, pull it out, and grab just the token. We don't need the bearer word. And that last part of the token is the signature, and this is what we need to verify. So to do that, there's actually a format called the JSON Web Key Set format. And what this is a kind of public and private key encryption. So we can go to our authorization server and say, hey, I've got this token. I need to know that you are the one that actually signed this key. So what we'll do is we'll add some information from our server for this endpoint that stores the public key. And then we can use like a library, a JSON Web Key Set library, go get that public key off of that endpoint, and then pass it on to the rest of our function. We'll use some sort of JWT library and verify it by passing in the token, the public key, and then some information about our authorization server. Once we do that, we're either going to get back the payload or we're going to get an error. So we're going to wrap that in a try catch, and we're going to get a look for the payload. If we get the payload, we'll return it. If not, we'll go ahead and throw an error. So now we have our verify token function that takes in the token and returns our payload. So the question is, where do we actually do this? Do we do this inside of our resolvers? Well, we could. It's just that if you think about it, we'd end up doing that a lot. Basically, anytime we had a protected resolver, we would need to duplicate this functionality. And so that doesn't feel right. That doesn't feel very efficient. It's better if we do this in our context. So let's take a look at what that is. So in our context, when we create our server, we can actually create this create context function. And inside of it, we can initialize two variables, a token variable and a current user variable. And we're going to go ahead and initialize them to null and return them no matter what. The reason we want to do that is sometimes we're going to have public-facing resolvers, right? We're not always going to protect every single resolver. You might, but if in the case that you have a mix of public and private, you're not going to want to error just because the user doesn't send a token along with the request. So we're going to do some try catch, and we're going to do this where we go ahead and initialize some null values. So first we need to see if there is a token attached to that request. We're going to go grab the token off, and we're going to call our verify token function. If we have a token, we'll call that verify token function. And then what's neat is that because we're going to get the subclaim off the payload, which is basically the user ID, we could then go and query our database for the user that is making the request. And then we can add that to our context. So if we don't have a token, or if it's not actually not if we don't have a token at all, but if we have an invalid token, maybe it's expired, maybe it's been hacked some way, we can just throw an error and say that we're unable to authenticate. And then we'll just go along, and now we have both the token and the user in our context. So we'll just use that create context function when we're building out our server, and we can pass in the request to that create context function. And so now when we go into our resolvers, let's say here we've got this create event resolver, and inside of there we've got our parent, our arguments, our context, and our info. We can actually check and say, hey, if I have a user, then that means I'm authenticated. If not, I can go ahead and throw an error because I want this user to be authenticated before I let them create a new event in the database. So if we do have a user, we can pull it off of the context, and then we can check to see if they have the right permissions and proceed to create the event in the database. So this is one way of doing it. There's a few different ways that we can make this a little bit more elegant. And one of them is by composing resolvers together instead of having to do that manual check every single time. So here's what this looks like. Basically, we can pull out this isAuthenticated function as a higher order function where we are going to pass this function the next resolver. So we have our isAuthenticated, we're going to return the next resolver. If we're not authenticated, meaning we don't have a current user, we're just going to throw an error. Otherwise, we'll move on to the next resolver that the function is wrapped with. Here's what that looks like. we have our isAuthenticated. So this is our create event resolver again. And we've got our isAuthenticated higher order function that's wrapping the rest of the resolver. So we can check for it. And if all goes well, then we're going to have the current user in our context. Remember, we were throwing an error in the isAuthenticated function, so we won't reach this point if we're not authenticated. Otherwise, we can go ahead and check the permissions and create the event in the database. We could also go one step further and pull out the check permission function and then do the same thing, basically. So we're passing in the next resolver, and we're going to check for those permissions and then move along if we don't have them. And so now the kind of double wrapped create event resolver looks like this, where we have isAuthenticated, which is wrapping check permissions, which then wraps the call to the database. So this is one way of doing it. It's a little bit complicated, a little bit hard to read. And so the community, the JavaScript GraphQL community, has come up with some other ways that we can accomplish this. There's a library by Lucas Constantino called GraphQL Resolvers that lets you do this. It adds kind of a layer of abstraction that makes this a little bit easier to understand. So we have our isAuthenticated, and then what's nice is we can just basically check if we have a user, and if not, the GraphQL Resolvers library provides this skip function that basically just means like, don't do anything and move to the next thing in the sequence. So here's how this looks with this library. What's nice is we have this combine resolvers function that this library provides us, and so then we can chain together, compose together the other functionality that we need. So we have isAuthenticated, followed by check permissions, followed by the creation in the database. There's another library called GraphQL Modules that's a slightly different approach to this, where we can compose together resolvers. So we have this resolvers composition object, which gives us an array, and inside of that, we have our isAuthenticated and our check permissions, and we can kind of chain them together. So basically, this library is saying, hey, when you encounter the create event mutation, first tack on these other two resolvers that we've created for checking authentication and permissions. Another approach, which is a little bit different than this, is using a middleware approach. And there's a library by Prisma called GraphQL Middleware that makes this a lot easier than writing it ourselves. So for example, we could basically create a auth middleware object. It's kind of like a key value map almost of saying like, hey, when you come to create event, I want you to run this isAuthenticated function before you run the create event mutation. And then we just kind of pass in all of these different middleware objects into an array, and when we construct the server, that gets put into place. In fact, there's actually an entire library based around this approach for specifically auth and permissions, and it's called GraphQL Shield, so you can check that out. The last approach that we're going to look at for authorization is custom directives. So custom directives are kind of neat. You've probably seen them before because they're actually part of the GraphQL spec. Here's one that you've probably seen. It's the deprecated directive, where you can, if you have a field that changes name, you can give the user a reason, and that way when they try to call that field in their query, they'll get a little notification like, hey, the location field has been deprecated. It's now called event location. So we can actually make these ourselves. The deprecated one, for example, gets added here when you're defining your query, and we can do this ourselves. So custom directives are pretty interesting. They're actually part of the GraphQL spec. As I mentioned, they are best used to change behavior at runtime. And because of this, there's a lot of different use cases for them. One really popular use case for them, other than like the deprecation thing, is internationalization, because they can maybe change a string on the fly, do some translation, and it's kind of an intermediary use at the time of the request. So it's pretty neat. And we can also use custom directives to control access all the way down to the field level. So if you only want to show certain fields for certain users, like maybe you have admin users and you don't want other users to see other fields, you can use a custom directive for that. So if we look at the anatomy of a custom directive, it has a few different pieces. First, you have the name of the directive. Here we're creating a directive called has permission, and then we're going to give it an argument called permission of the type string. And then we also need to specify where this gets used. So here we're going to use this on the field definition. You could also maybe use it on the object or other places. So once we have that, then we actually, this is sort of like the designation of the directive, but we actually need to define the functionality of it. So this is an example using Apollo in JavaScript. Other libraries kind of do similar things, but in Apollo, what you'd do is you'd have this class where you have this, call the class has permission directive, and it extends this base class that is provided for these directives. And inside of that, you have to define this function. You basically override a function called visit field definition that receives the field. And inside of here, you're going to pull off the permission that is used in the argument. So let's say we had a create event permission, and we put this directive on a field and pass that argument in as the permission we want. So we're going to pull that off. And then when we go to resolve this field, we're going to pull off this little function called resolve. And inside of here, this is where we're going to do all the work. So we're going to say, hey, okay, I need to check to see if we've got the current user. If not, we're going to throw an error because we want the user to be logged in order to get to this field, in addition to having the right permissions. So we'll do that check. And then we're going to we're going to use our little has permission function, and we're going to pass in both the user and the permission that we pulled off the arguments. And then we can check to see if the user has that permission. If so, then we're going to go ahead and resolve the field. Otherwise, we're going to throw an error. There's kind of a lot going on in this function. So if at first glance it looks confusing, that's because it kind of is confusing. But don't worry, just kind of walk through it and step through it piece by piece. Okay. Let's get through that. Okay, so then once we have the directive defined, we can actually add it to our schema. We can create this object called schema directives and pass it in. And once we've done that, now we're able to actually use it in our schema. So for example, we've got the create event mutation, and it's going to return an event, but we're going to add this has permission directive with the create permissions permission. And so now the only time a user can call that create event mutation is if they have that create permission. So custom directives are really cool. They do have some downsides that you should be aware of. They're really powerful, but the one issue to be aware of is that they couple your logic to your schema. This isn't necessarily a bad thing, but it is something that you want to be aware of. The other thing about custom directives is they can be quite difficult. I mean, if you just saw that class just to get this simple one working, there's a lot that happens here. And what's difficult about this is that it's hard to remember all of the different edge cases that you might come across. When you're tinkering with logic down at this very rudimentary level of the field, you've really got to be careful about thinking through like all of the different times you're going to need to access that field. So be careful, use a lot of testing. This is kind of a whole subject that you can dive into. One great resource on this is a talk that Ryan Chankey gave a couple of years ago called Supercharge Your Schemas with Custom Directives. A nice little dive into this. Also at GraphQL Asia in I guess that was this year, goodness. There were actually several talks about custom directives. So encourage you to go and dive into these things. The Apollo docs actually have an example of authorization with a custom directive. So that's another great resource on this subject. Okay, I've hit you with a lot here. So let's just do a quick review. We talked about how for the user, the GraphQL server is really just sort of an intermediary between the database. It's a layer over the database. And in a simple scenario where we have the server and the front end on the same server, we might be able to get away with just using a cookie and a session and everything's fine. But when we get a little bit more complicated, we start having to deal with third-party APIs, maybe an API gateway, and the problem becomes one of delegated access to things outside of just the first-party server. So we talked about the access token and how the authorization server will send that access token to the front end, which will then pass that along to our GraphQL server. We also talked about how a great format for this is the JSON Web Token. And the JSON Web Token, the JWT, is a great format for this because it can both contain useful information like claims, and it can also be signed and verified, so we know for sure where it came from. We talked about how the best place to pull off a token and verify it and return the payload is in the context. And then we can check in our resolvers if we have our current user to see if we're logged in, and then work on finding our permissions and calling the database. We also looked at several libraries that can help with authorization in GraphQL, like GraphQL resolvers, where you can use this combine resolvers function and pass in a few different methods there. We talked about GraphQL modules, which is another great library by the community, where instead you can kind of add this map to say, okay, when you come across this mutation, use these other resolvers on top of it. And we also looked at GraphQL middleware, where you can define these kind of key value pairs of middleware that you want to run before a mutation or query is resolved. Lastly, we did a quick look at custom directives. So we looked at creating this has permission directive that takes in a permission, and it's on the field level. And then we looked at being able to add that to our create event mutation and control who's able to actually run this mutation. So I just want to leave you with, I don't know how many of you have listened to Nader Dabit's GraphQL Patterns podcast. They've had a couple of episodes on auth that are really helpful. And there were just a couple of takeaways that I wanted to leave you with. So one thing that I think is really important to remember, if you kind of step back and look at the big picture here, is that really good schema design is really the most important goal of what we're doing here. As with most back-end things, kind of garbage in, garbage out. So design the schema to require only as much auth as you need. Think through whether auth is needed at the object level or the field level. I mentioned how with custom directives, if you're at the field level, you're going to have a hard time remembering all the different little edge cases that you need access to that field. So think that through. And lastly, don't design mutations that can change arbitrary objects. Instead, do some experimenting. Think through whether you want to send a null value instead of throwing an error, and kind of consider the trade-offs with that. Most things with GraphQL are a little bit nuanced and require looking through your use cases, and auth is really no exception to that. So thank you so much for watching this. I have all of the slides as well as a whole host of resources and sample code at samj.im/GraphQLauth. And with that, thank you and have a wonderful rest of the conference.
Thank you, Sam. That was a very, very nice in-depth look at the notion of directives in GraphQL. And again, as a programming language theorist, I love the craziness of all these GraphQL extensions, and they make me tick. So thank you, Sam, for making my mind expand. Once more, I would like to remind attendees about the post-talk surveys and also of our code of conduct. The link is now in the chat room, and Sam will be sticking around for the Q&A session, so do ask questions in Discuss, okay? And speaking of being a programming language nerd, I had a lot of misconceptions about what GraphQL is when I first started at Dgraph. And our next speaker has done a lot to help clear up that misconception. Our next speaker is Shruti Kapoor, and she's a senior software engineer from PayPal. Her talk will be live, so and she'll talk about the common misconceptions of GraphQL. So take it away, Shruti.
Hi, everyone. Thank you so much for coming here. Today, I'm going to be talking about what is in GraphQL. When I first started with GraphQL, I had so many misconceptions about it. I thought it was like a graphing software, and I was like, why do I even need to use it? I wasn't super bought into the hype. So I want to take this time to kind of debunk some of those misconceptions and walk you through what isn't GraphQL. Let me introduce myself. I'm Shruti Kapoor. I'm a senior software engineer at PayPal. I've been working at with GraphQL for over 2 years, and I love solving challenging problems with GraphQL, JavaScript, React. I also send newsletters on these topics at tinyletter.com/ShrutiKapoor08. If there's anything that I'm more passionate about, it will be dev jokes. So I'm going to be asking you questions, and I will monitor the live chat here. So you can put your answers in there. So the first question for you is, where do programmers hang out? And I'm going to look at the YouTube live chat for this. So you can put your answers there. I'll give you maybe 30 seconds to answer. So where do programmers hang out? GitHub. Cafe. Yeah, programmers do hang out at cafe. Programmers hang out at Foo Bar. All right, next one. How did HTML get drunk? The answers are great. How did HTML get drunk? With JavaScript? Watching the marquee tag too long. That's a good one. I like that. The HTML got drunk by having too many BR. All right, next one. What did the developers say to the Git repository? Drinking its own dog. That's pretty good. What did the developers say to the Git repository? The developer said, fork you. So if you want to learn more dev jokes, you can go to my GitHub, where you can find all the dev jokes. Now, I'm super excited to announce this for the very first time, that to add a gift dev joke, now you don't need to go to dev jokes repository anymore and create a pull request like you had to and write markdown. But with the help of Dgraph, there is a UI with which you can add dev jokes. So let me quickly demo how this works. So you go click on the create button here, add a dev joke. Let's say you can select what kind of jokes you want, if it's a text joke or a meme. So let's say it's a text joke, and the joke can be, let's pull it from one of these jokes here. There's a really cool joke that somebody added yesterday. What is a computer's favorite beat? An algorithm. So I'm going to add this joke here. You can copy and paste, and it shows up in an image right away. So it's super easy to check it out, super easy to read. It's posting the joke posted, go back to the home page, and the joke is all the way. I lost the joke. Where is it? Where is it? There it is, an algorithm. So now it's super easy to add a joke, and you can also spend your free time at work browsing dev jokes. So I wanna give thanks to the Dgraph team, especially Omar, Naman, and Minhaj, for helping me out with this Dev Jokes app. This app is powered through Dgraph and built on /GraphQL. So thank you so much again, team, for your efforts. So coming back to the talk, we're going to be talking about the misconceptions of GraphQL. This is what we're going to talk about today. I'll briefly talk about the differences between GraphQL and REST from a communication to the API perspective. I'll talk about some common misconceptions of GraphQL, some parts of GraphQL that I found really useful in development, and if you're interested, how you can get started with GraphQL. So the first part is the difference between GraphQL and REST from an API communication perspective. So for the purpose of this presentation, I'm going to be talking about this library app. And basically, the only thing you need to worry about is two fields that we're going to be using for the app, which is the title of a book and author. The title of a book would be a string, and author is going to be an array of strings. So as you know, a book can have one author or more than one author. Similarly, our data would be an array of one or more than one authors. So the first step in sending an API, talking to an API, is understanding what data we need to send to the server. In REST, what we do is we inspect an API documentation. We look at what resources we might need to use. So we might have endpoints like /books, /authors. We look at the sample response that it sends and the parameters we'll need to send. And that's how we'll think about how we need to construct our request. In GraphQL, what you need to do is first think about what data you need. So in our case, we need the book, its title, and its author. So those are two fields. The title and the author are the two fields that we need. The next step is now I need to send a request or create a request for the server. In REST, we'll have an endpoint like /books and author. So what I may need to do is that if a book has an author, two or more authors, and I need to find out more information about the author, I might need to get an ID of the book from /books endpoint and then use that ID to send it to the /author endpoint. So I'm using one endpoint to get an ID and then using that ID to talk to another endpoint to get more data on that ID. In GraphQL, what we do is we only have one endpoint, the /GraphQL endpoint. So to send or to get data, we need to first understand the schema of fields that we need. So for example, here we need book, the title, and for author, we need the name. So instead of talking to multiple endpoints, we're only going to be talking to one endpoint. The next step is to understand what we need to send. For REST, it comes down to what kind of operation we send. The most common types of operations are get, post, patch, delete, and put. Whereas with GraphQL, the most common operations are query and mutation. Once we have figured that out, we'll need to build the resources on the server side. So for REST, this comes down to resource implementation. This is typically done in Java or JavaScript. And so what we'll be doing, retrieve authors, it accepts these parameters like author ID, and then we'll be sending our resources and talking to the APIs in our resource implementation. Similarly, in GraphQL, we'll have a resolver for each field. For example, if you have a book or if you have title as a field, then you'll have a resolver for that specific field. And the final step when the server has sent data back to the client is to parse that received data. In REST, as you may know, you get everything that the server has sent you. So you may have fields in addition to the ones that you requested. But with GraphQL, you only get the fields you requested. So if you ask for title and name of the author, that's the only two fields you'll need to get. So this way, you'll have to parse very little data on your client side with GraphQL. So that was a basic difference between GraphQL and REST and how to communicate with an API. Now let's talk about the common myths of GraphQL. So to understand what are the common myths in the community, I wanted to do my research and hear from the community. So like any professional researcher, I did my research on Twitter. And I asked the community, what are the common misconceptions you have with GraphQL? And what are some myths that people who, when you introduce GraphQL, do have, especially the new folks? So here are the common misconceptions that the community has right now. The biggest, which misconception which I had as well was GraphQL is similar to like a graphing software, or GraphQL equals graph, or that GraphQL equals SQL because of the QL in its name. Another common misconception is that GraphQL only works with graph type data. And the one big misconception that I had when I started was that data fetching kind of works magically. So if I have a field book, it just knows what to get. Another one is that GraphQL replaces Redux. A big misconception that is still existing is that REST and GraphQL can't coexist. And because they can't coexist, it is difficult to introduce in an existing project. A lot of front-end folks also talk about GraphQL, so that kind of also leads to the misconception that GraphQL is only used for front-end. Another big misconception is that GraphQL will write the database queries itself. You don't need to do the magic. And that GraphQL requires complicated clients. So let's start debunking these myths. The first one being GraphQL equals graph. I think the common misconception here is that it's kind of used for like Facebook's graph, or it's somehow related to D3.js. So the graph in GraphQL is used to represent a graph type of structure. So for example, you need to think about how the data connects with each other. It doesn't necessarily need to be in a graph form. But for example, here, let's say we had 4 books. Every book could have one or multiple authors. The author would have a name, an email, and bio. Out of those 3 fields, we're only interested in name. So this way, we're connecting a book to an author, and we're drawing the graph between a book and an author. So it's kind of conceptual graph instead of an actual data structure type graph. So that's where the graph in GraphQL comes from. Another misconception is that GraphQL is equal to SQL because of the query language, or that it's a query language only for a graph database. So a SQL query may look something like this, like select star from books where title equals pragmatic programmer. So in GraphQL, instead of talking to the database like select star from books, or defining which table to read, instead we say, get me a book with the title, The Pragmatic Programmer. So it's kind of different way of thinking. With GraphQL, we're actually querying an API instead of querying a database. It's not a database language. However, there are libraries like Dgraph that are built completely in GraphQL, and they talk to database in GraphQL as well. Another misconception is that data fetching works magically. And I think this comes from the fact that we say you can get books and GraphQL will give you only the books. So when people say that, they actually mean that the resolver that you write will actually only give you books instead of GraphQL doing the data fetching magically for you. So just like in REST, you will need to write each of the resolvers and data implementations on the server side yourself. So every field will need to have a resolver. Another misconception is that GraphQL replaces Redux. And I think the misconception here is that why bother with GraphQL if I only have, why bother with like Redux if I have GraphQL, or GraphQL is just a fancy JS library. So the thing is that with the help of GraphQL, you get less data on the client. GraphQL is a way for talking to the APIs. So you still get data on the client. With help of Redux, you actually manage that data on the client. Redux is a state management library. So now that you're getting less data, the need of using Redux reduces, but it doesn't mean that GraphQL is a state management library. GraphQL is used for calling an API, whereas Redux is used for managing the data that comes back from an API. So you will still need to manage your data somehow on the client side, but there are some libraries you can use to do that, which is like Apollo Client, Redux, or you could just use React hooks itself. Another common misconception is that you can't have REST with GraphQL. And I think the beauty of GraphQL is that you can combine different types of APIs. They don't even need to be all GraphQL. You can have REST APIs, you can have SOAP APIs, you can have GraphQL APIs, and you can get exactly the data that you need. So it's kind of like building a unified API on top of all these distributed APIs that you may have. And this works really well in an enterprise level architecture. And we leverage this heavily at PayPal as well. So we may have 5 different APIs, and we only need maybe like one field from that API. And all these APIs could be REST. With the help of GraphQL, we build like an orchestration layer on top of these REST APIs. So instead of getting tons of data back, we only pick one field and then use that to call another REST API. A very cool library that does this really well is OneGraph. And it's able to talk to multiple different APIs underneath, like Twitter and GitHub and Stripe and Spotify, with just one GraphQL endpoint. So for you, it looks like you're talking to a GraphQL endpoint, but underneath, it's actually talking to multiple different REST APIs. So GraphQL does this really well, and I think that's very powerful. Another common misconception is that because it takes so long to adopt GraphQL, it's very difficult to introduce in an existing project. And this could come from the fact that people think it's all or nothing. They would need to replace or rewrite their entire REST API in order to introduce GraphQL, or it's only meant for like greenfield projects, which is starting from scratch. So this is another thing that we leverage very heavily at PayPal, which is to introduce GraphQL incrementally, one component at a time, one endpoint at a time. What we try to do is we pick one endpoint, see how that's performing, if there's any data in there that we are not using, and if that's a good client for GraphQL, we convert it into a GraphQL endpoint and see how that performs. And if it does very well, we convert other endpoints as well. So this way, we are incrementally adopting GraphQL one component at a time. Another common misconception is that GraphQL is only for front-end folks. And I think it probably stems from the fact that front-end folks are so passionate about GraphQL, just like I am. But I think that the real beauty of GraphQL comes from the backend, because on the backend, you're able to not only look at what data is coming, but you're also able to analyze which endpoints are not being used. So for example, in my book and author endpoint, if I can say that author field is not being used, I have the power to deprecate it without impacting customers who are actually using it currently. If I can see the analytics, if I can see the data that the author field is not being used, I can deprecate it and let the customers know that this field would be deprecated in the future. So I think the real beauty of GraphQL actually comes from the back end. In the front end, we kind of use it as an orchestration layer, but in the back end, we can use these fields to add to existing API. Another common misconception is that GraphQL writes database queries itself. I think it's probably also stems from the fact that GraphQL kind of sounds like SQL. And the common misconception that people have is that you send in a complex query and some magical engine works out all the subqueries to get the data for it. And it ties it all together and sends it back to you. But basically, the thing is you need to write all the logic of the database queries yourself. So again, in your resolver, you might be talking to an API, or you might be building GraphQL from ground up. In your resolver, you will need to let GraphQL know how to talk to the database or how to fetch data from the database. However, there are certain libraries that do it for you, like Neo4j and Prisma. Another common misconception is that it requires really complicated clients to get started, and that getting data from a GraphQL server is really hard, and it requires third-party client, which is problematic in sub-language. And I think one thing that this person highlighted very well is that a lot of people forget it's just an HTTP request. So let me show you how that works. Because it's an HTTP request, you can actually just make a curl command to call it. So here in this code, there is a curl command. I'm passing in some data, which is query post title, which could be just for any, which is just fetching like the title of a post. And the API there is /endpoint, /GraphQL endpoint. So because it's an HTTP, you don't need any client to talk to a GraphQL API. You can just simply make a curl request. And a lot of tools actually, like I think OneGraph also does this curl command export for you. So here are the common misconceptions that we talked about. GraphQL is equal to graph or SQL, and that GraphQL only works with graph type of data. Data fetching kind of works magically. GraphQL replaces Redux. REST and GraphQL can't coexist, and it is difficult to introduce in an existing project. GraphQL is only used for frontend. GraphQL writes database queries itself, and GraphQL requires complicated clients. So now I'm going to talk briefly about what I like GraphQL, why I like GraphQL, and what are the things that I like most about GraphQL. So I've kind of worked on GraphQL from both a front-end perspective and this and back-end perspective. And I think the biggest thing that I like while working on it from the front-end perspective is the type definition that comes for free with GraphQL. So no longer do I have to validate my data anymore. So for example, if I have a form and expecting that the field from this or the type from this one particular field would be string, I just need to define it in my GraphQL. I don't have to like do any more validation on it. So this way I'm reducing some code that I'm writing. Another cool thing is that it brought our front-end teams and back-end teams closer, because in the beginning of the project itself, we had to establish a contract and a schema for front-end and back-end. Because we were talking about what fields we'll be using, we also were able to shave off some fields that we're not going to be using in the front-end, and hence we're able to reduce the payload that we were sending back. Another cool thing while working on the backend is that we had very strong analytics over the data and the fields that was being used. So instead of just like blindly deprecating any fields, we knew if a field wasn't being used, it was safe to remove it. Another cool thing, again, on working on the front-end side is that I only had the data that I asked for. So this way I had very little data that I had to manage with a third-party library. And one cool thing that came out of that was I was able to completely strip out Redux and just use React hooks to manage my state. And because we only have one endpoint to rule them all, it's pretty easy to talk to one endpoint and get all the data that you need. So that's why I like GraphQL. Now, if you're interested in GraphQL, I want to give some resources away so you can get started. These are the three main resources that I found very useful. The official docs at graphql.org are very straightforward, and I found them pretty useful while starting. They also have best practices, so I really like them. Apollo, which is a very common client that is used for building GraphQL, has also really good documentation. And when I was getting started, I loved Prisma Docs, which is kind of like a game-based approach, like a quiz-based approach on understanding GraphQL, and I found that really fun. To try out GraphQL, you can use tools like Graphical or Playground, which lets you fire a query or a mutation and see the data that you're going to be getting back. And then on the right-hand column, you can also see that it shows basically a documentation of your query or your GraphQL API. Graphical can be found on GitHub at this URL. And here are some cool learning resources that I found. There's a lot of courses on Egghead that I found really useful for learning GraphQL. The Learning GraphQL book by Eve Porcello and Alex Banks is also really useful and super relevant. I also really like the course by Stephen Grider on Udemy, GraphQL with React. I found it very useful, especially in the context that I was working on. If you're interested in learning more, I've also written a blog on getting started with GraphQL, which has all these resources pointed out. You can find out that article in my GitHub, which is github.com/ShrutiKapoor08. Blogs. So basically, what communicate with each other, how to communicate with GraphQL and REST in an API. How to communicate with an API using GraphQL and REST, 10 common misconceptions of GraphQL, some things that I really like about GraphQL, and if you're interested, how you can get started. That's all I have for you today, but I do want to leave you with a last dev joke. Thank you so much, everybody. You guys have been an amazing audience. Again, you can follow me on Twitter at ShrutiKapoor08, where I will tweet the slides. And you can also follow the newsletter, tinyletter.com/ShrutiKapoor08 for more updates on JavaScript, GraphQL, and React. Thank you, everybody.
All right. Thank you, Shruti. The dev jokes had me in stitches. I did learn a bit more about GraphQL, and I hope all you audience members have too. Now, a quick reminder that Shruti will be answering questions live during the Q&A, so please ask her questions in our Discuss page linked below. And also please remember to fill out the post survey talks in order to get your t-shirts. We will be going on break from now until 12:45 San Francisco time and Indian time. We'll be back at 12:45. Hey, and we're back. Hello, hello, hello. We're back. Okay, now up next we have Joschka Tillmanns, a software engineer and recent co-founder of the startup Mooncamp. Again, Mooncamp. His talk will dive into Mooncamp's experience with Dgraph and GraphQL, and then he'll share best practices to help improve its workflow. Take it away, Joschka.
All right. Hi, and thank you for joining my talk today. I'm going to talk to you a bit about Mooncamp and our journey with Dgraph. We have actually been using Dgraph with GraphQL for the last 2 years, and we had an amazing experience with it. So what we also did was learn a few best practices using this technology, and I want to share you some of this today. So first, let me give you a little bit of context where we are coming from. So we are a startup. We founded in January 2019. So we are a young startup. We have a software as a service product. We are in HR tech, so we are doing goal management, and you can increase your employee engagement with us through surveys. So all in all, we are trying to up the culture at the organization. We made the transition from relational database right around the start of our product development. We really tried to increase our development speed. And we found that having this traditional setup of a relational database with GraphQL didn't quite take it for us. So we were looking outside of the box, and we were very early on finding Dgraph, and really fell in love with it and what you can do with it. You can actually have a look at the blog post that we published a few weeks ago, and we'll give you a more in-depth, more detailed history of what we have done with Dgraph at Mooncamp. And let me tell you that we are very, very happy with the outcome of using Dgraph at our startup. We have a very high development speed, and we were having very much success with it. Just a short disclaimer, although we are using GraphQL with Dgraph, we are not using Dgraph/GraphQL product. Just for the reason that the product, of course, wasn't live when we first started development of our product. Instead of what we've done, we built our own GraphQL implementation on top of the quote-unquote normal Dgraph that would be like Dgraph with the GraphQL ± interface, which I now believe is called DQL. And like I said, we built this homebrewed GraphQL implementation, which is actually very similar to what /GraphQL gives you right now. This also means that I'm not 100% up to date with the features that /GraphQL gives you at the moment. However, I'm sure that most of what we have learned is also applicable to you if you decide to use /GraphQL. And also, let me say to you, I'm a very big fan of their efforts and what Dgraph has done with /GraphQL and this whole product, because it really mimics a lot of the stuff that we have done. And like I said, we had this huge success with our product development, and we would never ever think about going back to a more traditional setup. All right, let me tell you a little bit about the goals that we have set for ourselves early on during product development. So like I said, we wanted to achieve a very high development speed, and we wanted to achieve this high development speed really through not reducing any of the Dgraph API. So it should really feel like you are using the Dgraph API right from the front end, so that you don't need to consider any like things that maybe come through a backup implementation. And of course, have a very high security standard. So we wanted to have a system where we have this security by default and have this security by default access management. And we did that, like I said earlier, by implementing our own like GraphQL implementation that gives us, of course, security and access management, which also allows us to do custom implementations for data consistency, so that you, for instance, can modify data. So let me give you an example. You would create a new user, and this user has some default settings that you can automatically create a node for the user settings, and then it also does data validation. So, for instance, if you put in malformed email, you can just reject the request. All right, then let's dive into the stuff that we found out, into some of the strategies that we found while developing with this setup. Let me first introduce you to to this little example right here. So you may have a cookie jar, and this cookie jar is filled up with cookies. And then you have users, but not all users can get access to the cookie jar. And what you can do in a graph setup is you can define who gets access to the cookie jar by a relationship. And then you can have a system which automatically defines who gets access to the cookie jar through the graph. However, we found that this might not scale very well, because you don't only have one user, but you have a lot of users, and you maybe not only have one cookie jar, but a whole number of cookie jars. So then you find yourself ending up with interfaces like you see on the right here, where you have one poor admin define who gets access to the cookie jars. So whenever there's a new user, he has to put him in, and whenever user is leaving your organization, for instance, he has to be deleted. And what you really want to have for more scalability is the system where, depending on who the user is, you define whether or not the user gets access to the cookie jar. So for instance, when you get access if you are an engineer or if you have a management role. The issue with this is, however, that you don't have this direct relationship between the cookie jar and the user anymore, because now the access is defined through the properties that the users have, not based on a relation inside of the graph. So what we found is that if you introduce a concept which we call a resource filter, that you can have basically the best of both worlds. So you have a resource filter, and this resource filter knows when a user would get access to the cookie jar. So for instance, again, the user is an engineer or the user has a management role. And what you can then do is translate this resource filter into a query. So as you can see, you would query for all properties and filter the property by the types, or in this instance, management or engineer. And then you can go back from the properties back to the user and really get a list of users which actually have access to this cookie jar. And then you can automatically build up this list of users and link them back to the resource filter, so that you get sort of this network of nodes, but without the hassle of maintaining each user which gets access to the cookie jar yourself, but really by the properties that you define. Right, and you can do this maintaining of the list from resource filter to user, either whenever you modify, mutate, or create a property, or you can even do this asynchronously, and this is what we are doing, because it simplifies your whole system by a lot, and we see that maybe having a delay of 10 minutes of data inconsistency doesn't really hurt your system. All right, this was one best practice that we have found for queries. Let me go into something more deep into mutations. So let me introduce you not only to the cookie jar, but to the cookie jar app. So what you have is a cookie jar application, and the cookie jar application has a dispenser, and you can also give ratings on the cookie jar. You can do updates on the cookie jar. So for instance, eat or fill the cookie jar back up again. And the promise of GraphQL, of course, is that you can have one single query which gives you all of the data that you need for this single page. So you don't not only query for the cookie jar, but you query for the dispenser, you query for the rating and the updates and whoever owns the cookie jar. And similarly for mutations, you also push back the cookie jar and all of its subnodes to the server, and the server is left figuring out the relationships and of course doing what a graph database does best, and resolving all of this for you. So this means if you do an update to the dispenser, you store the cookie jar with the dispenser subnode, and if you create a new rating on the cookie jar, you store the rating with the cookie jar node again. The thing is, though, that of course you have to implement security, data consistency, and validation rules for the mutations that you do. And this means that you of course have all of those things for a cookie jar, but also for the dispenser and for the ratings as well. So if you store a new rating on the cookie jar, the code would execute for the dispenser as well. So your security data consistent validation implementation would execute for the dispenser as well, which can lead to cluttered up code and complex code and really violates the single responsibility principle. So what we have found, instead of building up those super nodes, which in this case the cookie jar would be, you can just reverse relationships. So you store the dispenser on its own, or you store a rating on its own, and then you create a reference in the reverse direction. So the dispenser has a relation to the cookie jar, and not, as you can see here, the other way around. And this way you can implement security, data consistency, and data validation for each of those subnodes and really simplify your code base. And sort of the last example that I want to give you today is how to deal with data consistencies or data inconsistencies and deletions. So again, we have this example of the cookie jar, and in this case, I would like to remove the complete cookie jar. However, if you just remove the cookie jar node, of course, you're going to end up with a bunch of dangling nodes in your system, and this might violate your rules regarding data consistency. And this is why we ended up with a bunch of manual implementation for each node type, and this really increased the complexity of our system and made development slow. And this is, of course, the opposite of what we wanted to achieve. And this is why we came up with this concept we call a delete graph. And the delete graph is basically a GraphQL query which reaches out to all the nodes, which should also be removed whenever you, for instance, delete a cookie jar. So in this case, you would also reach to the dispenser or to all the ratings. And then we have a little implementation which takes the response of this query and also removes all of the nodes that come out of this response. So in this way, you're always going to have a very consistent state. You don't have to worry that much about dangling nodes, and you have to end up with a very clean and simple implementation. This was already 15 minutes, and I realized that 15 minutes is not a whole bunch of time to go through too many examples. I hope that you could take away a little bit of what we have found out at Mooncamp, and I want to thank you for listening to my talk. And I hope that you get the same success when you start using Dgraph and maybe a GraphQL implementation, maybe / GraphQL, because like I said, I'm very excited about this whole ecosystem and it helped us by a lot. All right, thank you very much. And yes.
Sorry, I was on mute. All right, thank you, Joschka. Your title's a bit wrong, though. I do find best practices that are not boring, and the super node thing was super interesting. Of course, it makes sense to not have a single point of failure. And of course, now I would like to also remind the audience to once again submit to the post-talk surveys linked below. And if you've got any questions for Joschka, please ask them on Discuss. All right. So our next speaker is Sean Grove, the founder of OneGraph. His talk will dive into storing GraphQL queries on the server and persisting it for clients for reference later, and how that enables new kinds of apps, new kinds of APIs. Take it away, Sean.
I'm going to talk about persisted queries in GraphQL today, what they are, what they're good at, why we might want them, how they work, that sort of thing. But I also want to talk about a grander narrative, and that is the tension that typically exists between a very flexible, bespoke API and a rigid, more static API, where both of these two different ends of the spectrum offer lots of benefits and different costs to different parties. But I'm particularly interested in exploring that middle ground and seeing if there isn't some way to kind of bridge that gap and maybe pluck a little bit of the best of both worlds. So a quick bit about me. I'm Sean, coming out of San Francisco. I work at a company called OneGraph. Before that, I ran engineering for a payments company, and developer tooling has kind of been my bread and butter for a long time. So I've worked on automated testing systems and compilers and type systems and all sorts of stuff. So good developer experience, good user experience is very near and dear to my heart. So let's go ahead and dive right in with the good points about GraphQL. I think everyone who's watching this, and including me, is a big fan of GraphQL, and it has a lot of benefits. You know, there's no more overfetching, underfetching, which is great for our users, right? They're getting exactly the data they need when they need it. And for developers, we have much more flexible queries. We don't have to worry ahead of time that some sort of preordained endpoint has exactly the data we need and no more. We could just specify what we need, and this is a really liberating experience. And I would argue that over the medium to long term, this leads to a much faster product momentum, being able to deliver a product much faster. And part of that is the technology itself, and part of that is that developers tend to be much happier when using GraphQL over a longer period of time. Because of the more liberating nature, because of the happier users, there's this really lovely kind of positive feedback cycle that means that you have more energy to work on things, to solve real problems, and to ship your product faster. That said, everything does have trade-offs, and I think it's really important to acknowledge them, even in GraphQL's, or maybe especially in GraphQL's position, because for those of your colleagues who are maybe less enthusiastic about it, if you don't acknowledge the trade-offs and the challenges that GraphQL is typically associated with, then your arguments about why it's so great are going to be much less effective. So what are some of the problems that are typically associated with GraphQL? Like there are quite a few. So consuming GraphQL API is typically heavier than a REST alternative. The request bodies can get quite large. A lot of the infrastructure and tooling that we build doesn't really work with it, including stuff like caching and rate limiting and whatnot. There's a new problem kind of around query complexity that can be difficult to implement. So let's take those at face value. So let's compare them. So for example, GraphQL is typically considerably heavier to consume than a REST API. And here we have two requests. The top one is just a simple request to a REST API, and it's going to hit the Twitter API, and it's going to pull out a list of tweets for the currently logged in user. And you can see that I have a few things. You know, I have the authorization header here. But other than that, like I basically have like a little named URL and some JSON. So I can tell maybe the intent of this thing. I can tell the data I'm going to get back, and I can very like succinctly summarize what I'm trying to get. And if we compare that to a well-formed GraphQL query, We have, our content type headers. We have our authorization header, but we also have quite a bit more text in there, right? Like we have the exact query that we're trying to do. There are a few things in here that can be a little bit nerve-wracking. So the first 10, this is an argument that's required that you may not notice just by scanning this. So GraphQL kind of just textually is quite a bit heavier. And if we were to take two different developers and just have them glance at this, most developers, and speaking honestly, would probably say that this one looks a little bit less intimidating. Also, each request is kind of unique. With that REST, URL-based approach, I can just read the URL and see /statuses, /homeline Twitter, and I get a sense of what the semantic intention is just by reading the title. Whereas every GraphQL query is kind of unique, and that makes inferring what the intention behind that query is a bit more challenging. Everyone is bespoke and a little bit of work. But also another thing is just names. Names are really, really important in life, but also especially in programming. And REST kind of forces you to give names to lots of things. And not everyone gives every GraphQL operation a name. And that can sometimes mean that there's an important bit of semantic flag that is just missing. And I typically think of this as kind of GraphQL is more like clay, and REST is more kind of like a megalith. And REST is a megalith in that it's visually very simple, right? Like rocks, just big flat rocks, are kind of very simple to visually parse. Conceptually very simple, right? You have a HTTP verb and a URL that you're hitting. The thing is, though it's visually and conceptually quite simple, it rarely fits together in the way that you're hoping it does, right? So some endpoints are too small, some are too large, and you as a consumer really have no control over that. And so you end up with something like this structure, where yes, it is visually very simple. You don't need much technology to kind of get started with something like this, just a lot of effort. But ultimately, the structure that you're building is unlikely to fit together in a seamless way. And each of those gaps represents work that you are going to have to do as a developer to make up for it in order to provide a good user experience. So either you do the work of manually filling in those gaps, or the user experience will suffer. And on the other hand, if we take raw GraphQL, so just GraphQL as it's usually written, it's very, very flexible. You can mold it however you would like, exactly the fields you would like, and the fragments, and all sorts of great things. But flexibility implies a very, very heavy trade-off, which is that it is easy to build the wrong thing, and it's easy to break things. You can pull off a bit of clay and attach it to a different part of your clay as much as you would like. But it is very likely that it is going to fall over at some point. Any sort of structural integrity, any sort of aesthetic beauty, any sort of functionality is often up to you as a developer to ensure. So it's a lot of responsibility to take on for the gain in flexibility. And as a quick aside, it's not entirely fair because most REST APIs do tend to grow a sort of expansion field approach. So Stripe has it, Twitter has it. Where you can see here, I'm pulling out a tweet, but I'm also saying, well, I'd also like to expand the attachment media key because I don't want to hit the attachments endpoint. And for the tweet fields, I really only need to have these specific fields. So you can see that even REST APIs tend to try to recover some of the built-in flexibility that GraphQL has. And again, that's all about trying to fill in those gaps in between those big megaliths. All right, so let's move on to the second point, which is that GraphQL requests are typically bigger. And this is because you send over the full request, and sometimes not just the query that you're trying to send over, but you can send over a full operation document. And then you can, in the JSON, you can specify which of the operations you want to run. And this might have multiple mutations, some subscriptions, a query, some fragments, and it's your whole application's operation document. When really you only needed to have some subset of that. And really every byte does count because uplinks are typically much, much slower. And very importantly, they have much higher latency than user downlinks. And this is very bad on mobile But given the theme of this conference, it would be especially bad in space, right? The latency would be tremendous. And so we really want to think about how can we minimize every bit or every byte that we're sending across the wire, if at all possible. And REST, looking at that request that we saw earlier, it was smaller. And how is it able to achieve this space savings? And really, it's by ahead of time coordination, where what's in an ideal world anyway, what's happening is that the API consumer and provider have sat down, they've discussed use cases and the needs and the apps that are going to be built, the services that are going to be built around this API. And they've kind of agreed on a certain set of endpoints that should basically make both sides happy. The client will be happy to consume and build on top of it. The server will be happy to build and provide support for. And you can kind of think of these endpoints as effectively just kind of queries that have been baked in. And the client can go and retrieve them later. And the other cool thing is that each of these queries now has a name, right? It's in the URL. The URL and the verb form a name in the REST culture. And that's really important because as GraphQL stands right now, it typically breaks a lot of the caching techniques. You really need to have a good name, a good identifier to cache something. And if you have this kind of rigid static approach, it makes it much easier to say, this is a thing that we're going to cache. Versus with Clay, you can mold whatever you want, and that makes it very challenging to cache. If you think about the process, you'd have to do something like make sure the query operation is exactly the same as the one that you've cached. Make sure that the variable inputs that are going into this query are exactly the same. Make sure that the auth is exactly the same, whether it's public or private. And this kind of goes into the query complexity as well. They're effectively, you have to become deeply familiar with both the domain and the technology in order to implement things like caching and complexity analysis. And REST is really nice here because REST is pre-arranged, where the server people get to kind of hold on to say, well, we know all of the endpoints. We know some are going to be smaller, we know some are going to be bigger, but we can kind of keep an eye out for which of these is going to cause troubles. And we can go ahead and commit, we can provide some sort of SLA and say, hey, we're willing to support these in production at some scale. And that's not quite the same in GraphQL. Again, because we're very flexible, we can do lots of things. And if we are trying to prevent some sort of pathological GraphQL query, whether intentioned or a malfeasant request, we kind of have to consider depth limiting. So if you imagine, you have a user and you select for friends and then friends of friends, you want to make sure that they're not going 10,000 levels deep because there's no service in the world that is going to be able to handle the explosion and complexity of that. You also want to limit the amount, right? So if there are 1 million items, you probably want to make sure that I'm paginating at maybe 100 at a time versus trying to pull down 1 million all at once. And then there are other kind of more crude mechanisms like just time or memory or CPU or some sort of resource limiting where you say, hey, we'll run your query for up to 30 seconds, but if it hasn't returned by then, we'll just kill the whole thing. So let's go ahead and take a moment for reflection. And say that, GraphQL has some really great points. It is flexible, it makes for happier users and happier developers after some time after getting used to GraphQL. But there are also challenges. Even consuming just a little bit of GraphQL typically requires understanding a whole lot of the GraphQL model, right? You have queries, you have variables, you have operation names, it's going over this post, you have a custom syntax. So there is kind of a lot, it's a bit of a step function in terms of the learning curve, where to even just to kind of start dabbling your toes in a production manner does require a lot of understanding. Also, it's easy to exceed the usage limits, as we've seen, and it's difficult to cache because of the flexibility. And then server-side auth can also be a bit tedious to implement, whereas in REST, you have a single endpoint that you can kind of lock down. In GraphQL, you kind of have to specify it at each field. What are the properties that go, the auth properties for each field? And so if we kind of look at it, we have this spectrum of the flexible, dynamic GraphQL API on one side and the more rigid and pre-coordinated REST on the other side. But as we saw, that REST tends to kind of, over time, grow this little additional appendage of expansion fields, trying to move a bit left on that graph. And maybe there is an equivalent if we were to take GraphQL and move a bit right on the graph towards that more rigid and pre-coordinated one. And that's effectively persistent queries. So GraphQL can do a lot of the benefits that we've mentioned inside of REST. And here's how it works. You're just going to use GraphQL normally during your development time. As a developer, you get to add queries and add fields and change whatever you want. It's great. But then at bundle or build time, whenever we're pushing production, we're going to have some tool that's going to walk through our entire code base, and it's going to extract all of our GraphQL queries. And then it's going to send them to the server and say, hey, I'm going to need these later. And during that storage process, the server is going to analyze them. We're going to do some depth analysis, complexity, cost, resource usage, auth, all that sort of thing. And it's possible that one of those queries will be too large. And we're going to say that, you know what, you cannot store this. You need to actually break this up because this will take too much resources of some type. And then the user will be forced to go, or the developer will be forced to go back and work around that. And this still happens at build time, so it never affects the user. But if it does pass, if the server is happy to support this, then it'll go ahead and store this, typically in a database somewhere, and it'll give it an ID and return that ID to the client. And then finally, the client is going to replace its GraphQL query locally inside of the JavaScript or the app bundle with just that ID. And the cool thing is this actually mirrors what is happening inside of the REST world. The devs and the server team are actually coordinating in this process. They're coordinating ahead of time about which queries are needed in production. And the ops and server team can kind of assign limits and say, well, we're willing to support up to this amount. That makes sense for us and for our resources. And as long as you're able to do that, then we'll provide that. And so as an example, if we take our previous query, getting a Twitter timeline, we can see it's quite large, but once we persist it, we get back just this ID. And the way we actually use this in production, going back to our original comparison, we have our REST API up here that we're hitting. We have our original raw GraphQL, very clay-like down here. And we have our persistent query, where we're calling that same endpoint down here, but we're providing a doc ID. And this is the document that was stored previously. And I would basically say that persistent GraphQL is kind of REST++. It's where the client gets to build the API, and the server just approves the API. And the cool thing is, once you have persisted that query, if we go back, no one needs to know that this is GraphQL, right? No sophisticated client or anything needs to be involved. Literally just making a curl request with a bit of JSON. And so you retain all of the flexibility for your GraphQL savvy clients, the ones who really want that. But the ones who are not yet bought into the GraphQL ecosystem or don't want to use sophisticated clients, they can just make a curl request. It's great. You get all of the build time verification that will reject pathological cases, so operations is very happy. And importantly, we now get back a single ID, which means that caching and rate limiting and auth are now infinitely easier. So I'll show a quick example of what this looks like. So over here, I have a couple of operations. I have one that is going to get the download count from NPM for a given package name. And I have one that is going to pull out some RSS feeds. So I'm going to go ahead and copy this. If I were to run this right here, this is just raw GraphQL. It would just run like normal. But what I want to do is actually come in here, and I'm going to persist this query. So I'm going to paste this in, and I'm going to go ahead and say that the user is allowed to provide a name variable, right? That's one of the variables that is inside of this query, and I want to go ahead and say the user can provide it. Importantly, whenever I persist this, I'm going to go ahead and say this can be stored, cached for up to 60 seconds. And now whenever I create this persisted query, I can just copy this. And if I go into my terminal, let's go ahead and check out the downloads for GraphQL. And so you can see, and I'll just prettify that. So you can see GraphQL has had quite a few downloads. You can see it's quite fast after the second time. And if I do React, and then again, after the second time, very fast. So you can see that I'm able to use this in a very, very simple way to just pull out the downloads from NPM. I don't have to know anything about GraphQL or any of that kind of stuff. This is just an endpoint I hit. I'll show another example where we have a RSS reader. So we're making a query into RSS, given a URL. and we're going to pull out some items and their content. And RSS doesn't change very fast, so I'll go ahead and say that 60 seconds is just fine. User can provide a URL. We'll persist this one. And now whenever I go into the URL, I can go ahead and say, let's go ahead and actually pull out one of my favorite podcasts, Jamstack Radio. So we'll provide that in there, and we'll pop that into Prettify. And here we go. We now have a podcast player inside of my terminal with little to no effort, right? I was able to take that and say, hey, I don't care about all the flexibility. I specify that ahead of time. Now I can just call it, and I get this great JavaScript-based feed. And again, caching and rate limiting is all much easier because we can just cache on that one ID. We can rate limit on that one ID and say, hey, this is an inexpensive query that we've cached, so hit as much as you like. Or this is an expensive query. You can hit this document ID up to this many times per second. And in fact, by kind of embracing the trade-offs between these two different tensions on the API spectrum, we actually end up with potentially superpowers. We can do things that neither could do on their own. We can actually attach metadata whenever we persist queries. We can do things like, who persisted it and when was it persisted and what was the client ID and the dev time, and we can get all sorts of interesting analytics. But the one I want to show today is actually auth. At persist time, we can also say, hey, here's a bit of auth that I want to provide for you. And I want you to associate this with this query. So whoever is calling this persisted document is going to go ahead, they can use my auth. And this is potentially quite dangerous because your auth may have access to very sensitive things, and an API may have access. Imagine GitHub or QuickBooks or Salesforce, where if you are embedding your auth or you're exposing your access to this API, you're potentially leaking lots of dangerous data. But sometimes you really do want to be able to set up an endpoint that can access just a subset of that API in a safe way. And persistent queries are great for this. And I'll show you an example of that using the Spotify API. So over here, I have a mutation on Spotify, and given a track ID, it is going to play that song. And I'm going to go ahead and copy this, but I'm going to persist it in a new way. So whenever I come over here to persist it, first, I'm actually going to create an auth token. And we'll say GraphQL in space demo. And I'm going to auth with Spotify ahead of time. And I'm going to go ahead and get a token back that has access to my Spotify player. I'm also, for the purposes of this demo, I'm going to give it access to GitHub. And GitHub is a very sensitive API for me. It has lots of data that I wouldn't want to make public. Similarly, Twitter. So with this one token, I'm going to have access to these three separate APIs in a really powerful way. And so I want to make sure that anything I give access to it publicly is very safe. So now whenever I paste in my query, I'm going to go ahead and say that when you persist this, use that token I just created. And the user is allowed to provide the track ID and the position to start the song, because sometimes songs, they take a little while to get interesting. And now whenever I persist this query, I'm going to go ahead and come in here and I'll paste this in. And I'll also grab that track ID. And you can see that even though this is associated, this auth, with lots of really sensitive data, I can only provide two values, right? The track ID and the position. So it doesn't matter. I've really taken this incredibly flexible, incredibly powerful API and just kind of made a tiny little serverless function effectively. And so now whenever I come into my Spotify and I run this, you can see now I'm controlling my Spotify player from my terminal via a persisted query. And I can tweet this out and I can say anyone who wants can actually run this exact same query here. And if you provide a different track ID, that will actually play on my Spotify player. So if I were at a party or something like that, maybe I had this up on the wall, then anyone could just, submit a track ID and the time when the song got good, and it would just work. And to drive this point home, I'll show one example where we actually use this. You can build full user-facing apps that are incredibly sophisticated using this technique. So we have a blog application that we use. We use it. We have lots of users who use it. And it's been on the front of Hacker News lots of time on popular subreddits. And because of the document ID, because of the persisted query nature, that means caching kicks in a really nice way. It means it doesn't even break a sweat at all. So I'll show you how this works. So over here, I have, let's get them side by side. So over here, we have our changelog, and this is just a way for us to blog quickly about small things that have happened on OneGraph. And over here, it's actually driven by GitHub issues. And anyone can come and open an issue. That's absolutely fine. So I'll come in here and I'll say, hello, GraphQL in space. And everything works, so, you know. So everything works exactly as you might expect. I'll come in here and I'll go ahead and create this issue. But nothing is actually going to change over here. If I refresh, nothing actually is live, even though this is making live queries to the GraphQL API, or the GitHub API. The reason for that is anyone can create an issue, but only project admins can add labels. So if I come in here and I add a publish label, now I can come over here, and if I refresh, you can see this works just fine. And actually comments work too. And it's very, very fast. And the cool thing is, you know, no one has to know that this is powered by GitHub. This is just basically taking our application flow and making it really nice for the user, but then powering it behind the scenes by something that we feel comfortable with. And now whenever I come in here and take off a publish label, because this is live, you can see it goes away immediately. So it's incredibly powerful. You can build very sophisticated applications. One other example of this in production is a doc editing site. So imagine that you have some API docs and you want to allow your users to come through and actually edit it, you know, add nice updates and whatnot. In this case, we actually built a thing where users can come and edit the docs, see the changes live, and then create a PR directly from the browser. Now, the stock site is actually a private repository that they don't have access to. But that doesn't matter because we've persisted a query with just enough permissions to be able to open a PR with changes for the docs part of the site. And again, you can see I come in here and I can actually see all the other PRs as an admin that are pending. And you know, if I like it, I can go ahead and see the original. And the very cool thing is you can see that the whole comment system, even the chat system, is powered off of GitHub chat or GitHub comments. And it works really fast for that user. They don't know that they're using, you know, GitHub behind the scenes. We're able to use persistent queries to really mold that incredibly powerful API in the backend, and it's something that is exactly useful for just us. And one last example to show off is the Gulp site. So Gulp is an amazing JavaScript bundler, can do all sorts of things. And they have a lot of support on Open Collective and on GitHub. And so they show all their supporters down here at the bottom of the site. And you can see that they're actually making that query to get those supporters live every time you load that page with just a GraphQL persisted query. So if we look at the request doc, you can see it's just a doc ID as we saw earlier. And if we look at the preview of the results, you can see they have data coming in from Open Collective. And part of the reason they do this is because Open Collective only has very powerful API keys. And they don't want to expose their API key to the front end where anyone could use it and potentially make financial mess. And similarly with GitHub, they're getting their GitHub organization sponsors here. And so they're able to kind of mold, again, that very powerful API, two APIs in this case, and put it down into exactly one query, one doc ID that's then cached for up to 60 seconds. So they never have to worry about rate limits, never have to worry about auth issues. And it all just kind of works really well together. And this technique is used in production at tremendous scale. So the TweetDeck team uses exclusively persisted queries for all of the TweetDeck application. And there was a great talk by Tom Ashworth at a previous GraphQL conference. Strongly recommend checking it out. Also, I would strongly recommend checking out Relay. It is an amazing GraphQL client in lots and lots of different ways. I was skeptical for the longest time, and I considered that wasted time. But it's a client that actually takes persisted queries very seriously, and it's kind of has first-class support for it. So that blog I just showed you is actually written in Relay. And the thing is, as a developer, you don't even know that you are using persistent queries. You set up a function once to persist them, and then you just use GraphQL. And literally at build time, it will go through, extract everything, just like we talked about earlier, store it on the server, and it's amazing. Okay, and that's it. Happy to talk about other things. Some other cool things I didn't talk about, for example, are once you have persisted a query with lots of different operations, you now effectively have a library of functions you can call. So imagine you had like Spotify play mutation, pause, next, search, query, and you can persist that all at once. And now you have one endpoint that has all of the auth, all of the functions you need to call. And also you can generate, for example, an NPM package for that will have all the TypeScript bindings or Swift type bindings. So your consumers don't even know that it's GraphQL. They just see a list of functions that they can call and named arguments that they have to provide with their types. So the autocomplete experience is just fantastic with persistent queries. Yeah, lots of other things I'd be happy to talk about, but I think that's it for today. Cheers.
Go.
Thanks, Sean. I absolutely love the frank discussion over the limitations of GraphQL and how the practical and the practical tips on how you should limit your queries. Good stuff, Sean. If you have any questions for Sean, please post them on our Discuss page. And again, please do fill out the post-talk survey so that we can send you a t-shirt. Speaking next is Jamie Barton. He's a developer relations engineer at GraphCMS, and he's co-founded the headless commerce resources GraphQL. His talk will talk about leveraging Jamstack to rapidly and programmatically generate forms, capture submissions, and handle data using GraphQL and the headless CMS. So take it away, Jamie.
Hi, I'm Jamie, and today we will have a look at how you can programmatically create forms with GraphQL. So let's dive in and have a think about forms and what they are and what they do before we come to having a look at a solution with GraphQL. Now forms. Not all forms are equal, and while they may look similar, it's guaranteed they all do something completely different and serve a different purpose. As we see here, we have a form on the left that is a traditional contact form. It has input fields for text, for phone numbers, for dates even, and then we also have select boxes, and we also have a text area as well. As you can see on the right hand side, we have an example here that is asking for what product you need support with, and then a input field for how can we help. And that text area, the text is then sent to a different team, and it could be the support team, and then they will get back to you and they can use that information to help you. And it's completely different to traditional contact form. We also have forms for something like registering for an ebook, and this is traditionally used with marketing teams. You enter your name, your email, and answer a few qualifying questions, and then you'll get access to that ebook. And that ebook could be delivered on the page, or it could be sent to you via email. That behavior, again, all changes based on how this is implemented. So that leads to the question, where do these forms all go? Well, they could go to an email, it could just go to a database, it could go to a CMS, it could even be a Slack notification or an SMS. There's tons of different possibilities on where your form goes, and more often than not, each one of those forms probably does something different, and wherever you fill a form in online, that is again going to do something different. There's not one solution that fits all here. But building forms, what does that look like? Well, imagine you're in a team and somebody in marketing requires a new field to be added. Well, we have to go and edit the form, we've got to submit a pull request, and then obviously that pull request has got to go through a review, and then eventually at some point will get merged. And these pull requests mount up, it takes developer resource away from the product, and it blocks the marketing team from getting to market quicker. So I'm sure there's a way we can improve this. Well, building forms there's been tools around for years that allows you to use CSS, HTML and JavaScript to control forms and their behaviors. We've seen this with things like Netlify forms. We can simply add a tag to any form in the field, and then we can hand that over to Netlify, and they will then process that and send it to wherever you like. Now the problem is, you still need to know a little bit of CSS, HTML, and JavaScript. Now you could believe that, with good usage instructions, you can get by on that, and you can just allow your team to edit those HTML fields. However, in some teams, or just, it's a bit scary. If you're not used to editing HTML or JavaScript, it can look a bit daunting to edit the HTML and submit pull requests. And frankly, it's just quite time consuming for a marketing team to get to market with new forms or new ebooks or whatever it be. We've seen solutions such as Google Forms and Typeform allow us to create these forms outside of the website and then link our users to it. And then we can integrate other services to, follow up with ebooks or questionnaires or whatever it be. But the problem is with these forms, and while they allow us to customize it to some extent of adding colors and images and anything else that's on brand, this is completely detached from the experience of the website or the product that the user is used to. And they're going off and they're filling out this different form, and anybody who isn't familiar with these other services may feel like they're getting tricked, or kind of, there's something fraudulent going on here because you're not using something that is, close to the brand they've been using. I've experienced this myself, where I've went to a contact form, and the contact form is asking for some really personal information, such as maybe my account name or my subscription ID or a reference from my bank, just to help with them find my account. And surely there's a better way that we can do this, and I believe there is a better way with GraphQL. So let's dive in, have a look at a demo, and see how this can really enhance your teams with using a content management system. So here we have a simple page. This page has a title, a subtitle, then it has a form. That form itself has fields, in this case a name and email field, and when we hover over, we can see that this field is required by the helpful "please fill in this field" text. And if we try to submit this form, we will get an error. Now note the text on the button here that says schedule demo. This is all configurable through a CMS. So if we wanted to add a new field, such as when the person would like to schedule a demo, traditionally, we may have to edit the file, submit a pull request, get it through a review phase, and wait for it to go live. Well, because I'm using Next.js, and because I'm using a headless CMS, if I make any changes to the content, Next.js is smart enough to revalidate the entire page because the data's changed. And that's what we can do here. If we go inside of the CMS and get an idea of how this is set up, you'll see we have a title, a slug, the subtitle, nav label, and we have this most important form. Now if we head over to the form model and have a look how this is set up, our form has a title, it has a CTA, which in our case was the schedule demo on the submit button, and then it has an array of fields. Now this fields array, or this GraphQL union type, allows us to define which field we want in our form. And all of these different fields have their own associated models. So we can see the models on the left here for our form input. Well, this has a name, a type, a label, a placeholder, and a boolean to denote whether this is required. And more or less the same for text area as well, maybe with a few less fields, and the same for our select. Now the select has options, and we have a look at the option. It has a value and then the option itself. So you'll see we're programmatically creating our form fields and kind of scaffolding them out, adding all the types together, and we're kind of putting this into a GraphQL API. But now we kind of have to figure out how this works. And we'll dive into what maybe is what the code looks like in just a bit, but let's go ahead and see how easy it is to add a new field. So you'll see it on the bottom here inside of our enumerations that we have the form input type. At the moment, our forms support email, text, and a telephone number. But what if we do want to support that date? Well, it's as simply as going inside of here, adding this to the list, and then updating that enumeration. That is then published to the GraphQL schema and is automatically available to us when we are defining more types and querying our GraphQL endpoints. Now, if we go inside of this form input, you'll see that inside of here we have the type, and this type is in fact of that form input type, and that is what changes the inputs for us. So why don't we go ahead and add that date field to our schedule form? I'm going to switch over to the content editor here. I'm going to go to page. I'm I'm going to shrink this side down, and I'm going to have a look for our home page. And we'll see here that it is the second entry. And if we edit this entry, you'll see that we have this form here. And I've used a helpful name for the form so it's easy to see if I have multiple forms. So let's go ahead and edit this form. Now you'll see we have fields, and these are our GraphQL union types. And we can see here that we have a name and email. Well, now let's add a new field. So it's simply clicked on here, and I can choose any one of the types I have defined for this field. And I'm going to choose the form input. Then I'm going to add the field when, and inside of the drop down for the type, I can now choose the new date enum. I'm just going to add when here as well, and when as well inside of the placeholder. Now, because we're using a date field, that placeholder is not going to show, but let's go ahead and add that, and we'll save and publish. Now, once we save and publish that, we'll save and publish everything else. And then what we'll have available is a new GraphQL response when we query that page. So now if we head back to this page and we refresh, you'll see that we have this new date field. We've not had to submit a single pull request to get to this point. I'm then able to add my name, I'm then able to choose my email address, and then I'm able to select a date. Then I can click schedule a demo, and if we open up the GraphQL in Space Google Sheet, in the background what this is doing is sending a webhook, and that webhook is then going to Google Sheets. So at any point of the day, my sales team can now come in and see which of our customers have scheduled a demo. I've not done any coding at all at this point. Everything has been done through the CMS, and all of that has been delivered through GraphQL. And you can see the date has came through because we've added that field. So it's really cool. I'm really pleased at this point. Now, what if we want to go ahead and we want to be notified through an SMS? Well, we can do that. We have a form here, and I'll show you what this looks like in just a second. So we can add some details in here. We can add a name. We won't add a phone number. We'll just add something blank here, and then we'll put a message in here saying hello. Now, if I try to submit the form, you'll see now that I can't because there's a checkbox required. So let's have a look at the schema and see exactly why that is the case. So if we load up our content once again, and we head to the content and we head to our page, let's have a look at the page that is for our contact form. So inside of the form, you see we've got all of these other different types now. We have this form checkbox. And if we edit that, you can see I've marked this field as required. And I could change that to false, and then when we go to submit that form, it would no longer be required. But let's leave that as is, and we'll close this out. Then if we head back to the form, and if we do choose to agree to the terms and the privacy policy, and we click Get in Touch, again, this is then going to fire a webhook via GraphCMS, and it's then going to send it to another service, which is able to send us a SMS. And finally, on this page, Submit Talk, we have a title and we have a subtitle, but we don't have anything in our box for our form. So let's now use the CMS to control adding a form to this page. Inside of the CMS, I'm going to look for my page Submit. And you'll see that the subtitle and the title of the page all match, and this nav label updates as well. Next, let's go ahead and create a new form. And we'll give this a name of About My Talk. Then we can create a CTA. That CTA is what's going to be on the Submit button. So let's just input register my interest. Then let's add the fields for our form. So let's go ahead and add a new form input, and we'll give this a name of name, and we'll say this is of type text. We'll also specify a label which will be visible to screen readers only, and we will display a placeholder of your name. We'll also make this required because it's nice to know what people's names are. We'll then go ahead and save and publish this. And then we will create a new input. And this input this time will be for our email. And we'll choose of type email. Again, we'll place a label for our screen readers and have it as email. And then we'll update the placeholder text to be your email. We'll also make this required because we'll need to get back in touch with anyone who wishes to speak at the conference. So let's go ahead and mark that as required. We'll then go ahead and save and publish that record. And finally, we'll add a text area. And we'll give this a name of message, and the label here will be message. And we'll leave a message here for the placeholder. Why do you want to talk at this conference? And we'll also make this required as well because we really want to know why people want to speak at the conference, and they can tell us a little bit about their talk proposal. Now at this point, I could go on and I could add things such as a form select. I could add a name, a field here, and give it a name such as, where are you located? And then we could add some options here and give the values for those, and all those will convert and move into a form. But for now, let's have our name, email, and message, and we'll save and publish this record. Then I will then save the page just to make sure all of that data has gone through. And then if we head back to the website and we refresh the page, Next.js is intelligently going to have a look at the data that it already has versus the data that is kept remotely, compare the two, and if there are any changes, it will go ahead and update the page for us, which is absolutely amazing. So here we have the new form that I've just created, and now I'm able to input my name, my email address, and leave a short message. So I've left a message why I should talk at this conference, and then you'll see we can click on register my interest, which was the text that I provided when I created the form inside of the GraphCMS. Now we've submitted that form. In the background, that is then sending a webhook. And because I've already previously configured Zapier, all of this data goes to Zapier, and I've not had to at all write any code to make this happen. Awesome. So we now have an email sent to us from a web page and from a form that I created using GraphCMS. Now all of this is configured using Zapier. So here I have a field and I can send an outbound email, and I can share and send some of the data that I've submitted via the form. So I've not had to code anything. I just had to code this once. So as a developer or as a team, you just need to implement the logic for the form once, and then you can hand it over to the rest of your team, and the marketing team, in this example, can go on to create forms and pages. So let's dive in and have a look at how some of the code works. So if we have a look at our page, for example, we'll just take the index page here. You'll see the query that it is running is a GraphQL union type. We're getting the page where the slug matches, and we are getting things such as the title and subtitle, and then for each of the fields, we are then getting the name, the label, the placeholder, and everything else we have inside the CMS. Then we simply pass this onto a component called form. And if we have a look up here, we are destructuring the fields, the ID, and a few other things. We're handling things such as the success and error messages. Then we have this on submit action. This submit action sends it to a Next.js API route, and then inside of that function, we send that on to GraphCMS. But as we scroll down, we see here that we have, if the form has been successful, to display a message and a way to kind of start over on the form, which is always helpful. Then we wrap our form here in a form provider, and then we simply map through each of our fields. And this is the important thing, which is really simple, and it allows us to do exactly what we've done and what I've shown already. We now have, for each of our fields, we have the type name. And we are simply grabbing the component inside of our fields array and then just rendering that to the page and spreading on everything else, which is really good. So if we have a look inside of our form fields folder, you'll see we're just exporting the names here, and these match up with the GraphQL type names. So that's how it's able to import, and it's very smart to do so, and it's just a kind of nice way in JavaScript to kind of cheat the system, which is nice. So if we have a look inside of that form input, you'll see we're just doing some things that you might expect here. We are destructuring the label, the placeholder, and then the enumeration for our types. And then we're simply returning that input to the page. And the same goes for our checkbox and the text area. And the real magic does happen inside of this part here. There's only around 5 or 6 lines of code, and this is where everything happens. all of our queries from GraphQL turn into components, and this is really, really helpful. So we're able to deliver all of the forms using the CMS and power all of these different fields simply by editing content inside of the CMS. So I think this is really cool. I'd love to hear what you think about it, but hopefully you've enjoyed it, and hopefully you can take something away from this talk today and implement this on your own.
Hi, so who knew forms are so rich? Thank you, Jamie, for showing me the whole new different worlds as to how you can think about forms and that CMS. Fantastic. Anyways, next up we have Yan Chui, who is a developer advocate at Lumingo and an AWS serverless hero. His talk basically will tell us how to build a new social network in 4 weeks, just using AppSync, Lambda, and Algolia using nGraphQL. Take it away, Yan.
Hi, welcome to this talk on how to build a social network in under 4 weeks using serverless and GraphQL. So I recently worked on a client project where I built a backend for a new social network that lets you find people to do sports with, and it supports instant messaging, group chats, and other common social network features. Users can also use the app to book classes and courses for sports that are offered by their universities. So the client is a privately funded, bootstrapped startup, so there's a lot of constraints on money and therefore development time. And they need something done quickly in time for university semesters to start again now in September. So in terms of the goals of the project, it needs to be done quickly, but it still needs to be able to scale to millions of users if it takes off. Right away, it's going to get rolled out to tens of thousands of students in Belgium, and then to other countries after that. It needs to require minimum upkeep because the client can't afford a full-time team to look after this, so it pretty much needs to run itself and not fall under. It also needs to be cost efficient as well, even as we scale to millions of users. So the project was put together with a small team of 3 engineers, including myself, in just a few weeks. And we didn't just build a new mobile app. We also built a CMS for the app as well, which will be used by the founders to onboard new universities and also used by the university admins to manage their profile and to publicize and configure their sporting programs so that students can book classes and book tennis courts and so on. So I'm not going to show you the full architecture, but there are a few of the key components here where we have CloudFront and S3 for image assets and such. And for authentication, we use Cognito. There's one Cognito user pool for the mobile app and then another one for the CMS. So the whole backend is done in the GraphQL using AppSync. Again, one for the mobile app and the one for the CMS. And they each have resolvers that point to DynamDB tables for simple get, put, and query operations. But for anything more complicated than that, I have a Lambda function resolver. And that function will probably do something against DynamDB tables as well, but typically more complex operations like transactions or batch read and batch write. I mean, you could do a lot of this using pipeline resolvers instead of Lambda, but I find it easier to do that with Lambda, and also it will be easier for me to hand it off to somebody else later who can understand JavaScript code rather than someone who have to read and write VTL. And we also use Algolia for search, and Algolia is probably the closest thing you're going to find to a serverless Elasticsearch. So to get the data into Algolia indices, I use the DynamDB streams to trigger Lambda functions to synchronize any data change to Algolia. So whenever a user creates or updates their profile, or they start a new sporting activity in the app and look for people to join them, those are all going to get synchronized to Algolia. And I also capture BI or business intelligence events from the different Lambda functions and use a Firehose delivery stream to buffer and batch them into S3. And so I can run BI analytics and the reports against them in the Athena. Again, this is not the architecture diagram per se, but it's a summary of the different services I used and how they all fit together from a very high level. So remember, all of this was done by one person working part-time for a couple of weeks, and it's only possible because I could stand on the shoulders of giants and I can use really good tools like the server framework to help me manage and deploy my application. So my name is Jain. I have been an AWS user for a very, very long time, and I've been running production workloads at scale on AWS for over 10 years. And since 2018, I have been an AWS serverless hero. And the last couple of years, I've primarily focused my efforts building stuff using serverless technologies, including in the 2016, I worked for another social network, and I migrated them to an entirely serverless architecture as well. So you can read about that particular journey in the link down at the bottom of this slide. So nowadays, I spend half my time working with Lumingo as a developer advocate. And the Lumingo is a troubleshooting platform for serverless applications that make it a lot easier for you to debug any problems you have for your serverless architecture, including performance, as well as any errors you see in production. And the other half of my time, I work as an independent consultant, where I help clients all around the world go faster by adopting serverless technologies through trainings, through advice, or maybe like this particular client, I help them build the actual product. I also run a weekly podcast called The Real World Serverless, where I speak with other builders to talk about how they are using serverless technologies to improve their business. And I also have an upcoming video course on AppSync called AppSync Masterclass, where I teach you GraphQL and AppSync by building a Twitter clone using AppSync, DynamDB, Lambda, Vue.js, Amplify.js, and so on. So in terms of what is AppSync, it's basically a managed GraphQL server that lets you map those query and mutation operations as well as your data types to different resources in your AWS account. And it supports DynamDB, Lambda, Aurora, and Elasticsearch, as well as just HTTP endpoints out of the box. So AppSync itself is very scalable, and they also have a GraphQL subscription implementation that can support millions of connected clients. And your AppSync API is deployed to multiple availability zones out of the box. So that also gives you a great baseline for resilience. And you only pay for what you use at the $4 per million operations. And it also supports caching out of the box, which does charge you extra, but essentially you're going to be paying for uptime for a memcached node, and the cost per hour is depending on the size of that node. It also has a built-in integration for monitoring with CloudWatch and the CloudWatch logs, where you get high-level metrics like number of API requests, error count, and latency, which is great, by the way, but unfortunately, all of these metrics are aggregated at the API level. So it's difficult to tell which resolver is causing any performance problems, since a single query can involve many resolvers, as we know. Luckily, you can also enable logging, which then gives you a lot more information about what's going on. So you can at least narrow down to specific requests that maybe took a long time, and you can then inspect the resolver logs for what that request is doing and to figure out what the problem was. For performance issues, I still prefer to enable X-ray on the AppSync API, which really shines a light on what's happening under the hood, and it shows you where the time is taken. And you can see that this single query has resulted in quite a few DynamDB calls behind the scene. And X-ray also shows you a service map, so you can get a high-level view of which services your AppSync API is talking to and the overall health and the latency and performance. And it gives me all of that, and I don't have to manage any servers, which is just great. So in general, I find the developer experience with AppSync has been really superb. And everything has worked well, and I haven't run into any major problems. In terms of authentication, as I mentioned earlier, we use a Cognito user pool, and I've set up identity federation so that users can also sign in using Facebook and the Apple account as well. So on the client side, we use the Amplify.js library to integrate with Cognito, which really makes things quite simple as far as authentication is concerned. However, I didn't use the AppSync CLI to create and configure the Cognito user pools themselves. I did it with the server framework and with CloudFormation. In general, I think the Amplify CLI hides too much important details about how your system is configured, information that you really should be more familiar with if you're going to be looking after this system in production. Amplify can provision and configure the DynamDB tables and AppSync resolvers for you. You can do a lot of this using CodeGen, but I don't agree with some of the decisions it takes. For example, how it defaults to using DynamDB scans for list operations. And in this particular case, the DynamDB schema and access patterns are really important, with potentially huge scalability and cost implications. So I want tighter controls around that, and I need to understand my access patterns intimately. The CMS also uses Amplify.js to authenticate users against the CMS Cognito user pool. The founders can use it to onboard new universities and invite the university's admin staffs to the CMS. Behind the scenes, we will have a Lambda function create a user for the university admin in Cognito and then add them to the university group to identify them as university admins. And we use a custom attribute to tell us which university they are the admin for, which is then passed along to our backend or the AppSync resolvers by Cognito when the user interacts with the CMS AppSync API. At no point does the client actually pass the university ID to the backend and say, hey, trust me, I'm the admin for this university. Just let me have access to the data. No, it's always based on your identity that's been resolved by Cognito. So when you're the university admin, you see a different set of options in the CMS UI, which are limited to just your university. The nice thing with AppSync is that you can restrict access to operations using Cognito groups. So if you are an admin, you'll be able to get university details by name, and you can edit the sports we have in the app and so on. But if you are the university admin, then you can only fetch and edit information about your university. And if we don't specify any specific auth option here, then any logged in users can perform those actions, like getting an upload URL for images and so on. So moving a bit closer to the code, I use the server framework to help me package and deploy the application. So in this case, I've got one repo for the whole backend, and everything is configured in one server YAML and is deployed as one CloudFormation stack. So resource reference and all that were very straightforward even as the project grew. And to deploy, I had just one command I need to run, server as deploy. So to make it easy for me to configure all these resolvers I had with AppSync, I'm super glad that this server as AppSync plugin, which really makes things easy for me. And as I mentioned, since we have two AppSync APIs, one for the app and the one for the CMS, I broke those out into their own files so that things are a bit tidier and more manageable in the main server YAML. And each of these files is going to look something like this, where I hook it up to the right Cognito user pool, and I configure logging, where in production we don't want to log everything because it generates so much logs to CloudWatch, and it's going to add just a lot of noise. But also there's going to be a cost associated with that as well, since CloudWatch logs charges you 30 cents per gigabyte ingestion, and then also 3 cents per gigabyte per month for data retention. And then I will configure my resolvers and the data sources in the same file. For many of these resolvers, we will go straight from AppSync to DynamDB. So the request and response have to be written in Apache VTO, which is the same templating language that API Gateway uses as well. So I'm kind of familiar with it already. And honestly, I think the official documentation for AppSync does a pretty good job and gives you a bunch of examples that you can just follow. So most of the time, I'm just using their examples and then I'm tweaking it to meet my actual needs based on the table designs I've got and the operations I'm doing. And as the project grew, I also hit the 200 resources limit pretty quickly, since I also try to follow security best practices and apply the principles of least privilege and have one IAM role per function. So it didn't take me very long to get up to 200 resources. Luckily, there's the split stacks plugin, which can split your one stack into multiple stacks by splitting some resources into nested stacks instead. And the great thing here is that it also lets you control the splitting logic yourself, which was very handy as I had several iterations around how I split those resources to allow the project to just keep growing as more and more features are added. Which at the time of writing, the project has over 200 resources across the two AppSync APIs, and it has a total of more than 600 CloudFormation resources as well. In terms of CI/CD, since the whole code base was in GitLab, I decided to use GitLab CI/CD. And one technique I've employed in most of my projects is to install the serverless framework as a dev dependency in the project, which means I don't have any extra dependencies on the CI server. And I can add a simple helper script in my package.json to run this version of the server framework that's installed in the project. So when it comes to deploying from CI, it's literally a two-step thing. To run npm CI, which restores my dependencies to the exact version as they are in the package.json, and then run npm run sls deploy to trigger deployment using that version of a server framework in the project. And of course, we also want to run tests in the CI/CD pipeline as well. And when it comes to testing, one of the challenges with using something like AppSync is that it's a black box. So how do you test it locally, right? There are tools that let you simulate AppSync locally, but I generally don't bother with them because they don't cover everything, including IAM policies. And honestly, those VTL templates are so simple, they just work. Where things tend to go wrong is in my Lambda functions, where I tend to do more complex things. So for those, I like to test my integration with other services like Algolia or DynamDB by executing the function locally, but talking to the real DynamDB table or Algolia. I don't tend to use any mocks or stubs or simulate them locally with things like local stack, which I find just takes too long to set up properly, and they're also quite brittle and breaks easily. It's just easier for me to provision the tables in AWS and use them in my integration tests. And I also have end-to-end tests that run user stories, like creating a profile, doing a search for other users, and then joining another user's activity, and so on. And I'll run this end-to-end test against the deployed GraphQL endpoints, so this will always be run after the deployment. And if you have any failed end-to-end tests, then great. Use this as a valuable rehearsal for how to debug problems in production. If it's difficult, then guess what's going to happen when you've got a problem when the system is live with millions of users using it. Use that as a signal that you need to improve your logging, how you're monitoring the system, and enable extra tracing and so on. If you struggle to debug problems in a controlled environment like your end-to-end test, then you're going to have a much bigger problem when this thing is running in the wild. So don't optimize for your comfort with things like local simulators. It's a false sense of security. With AppSync, Lambda, and DynamDB, our entire stack is pay-as-you-go and serverless, and the cost per million requests is just a few dollars. So the projected cost for this when we go live with tens of thousands of users is going to be really small and well covered by the AWS credits we get through the AWS Activator program. And that brings me to the end of this talk. Thank you guys so much for your attention and for being with us today. As I mentioned earlier, I spend most of my time as an independent consultant. So if you want to see how serverless can help your team go faster, or you just need some help upskilling your team, then let me know. Go to theburningmonk.com to see how we can work together. And finally, I want to remind you about my upcoming video course, the AppSync Masterclass, where you can learn GraphQL and AppSync by building a Twitter clone. So again, with that, thank you very much and enjoy the rest of the event.
Well, thank you, Jain. That was an amazing experience that you've just shared. It's pretty crazy. Yeah, so the architecture diagram was just, wow. Okay, anyways, Jain will be joining us for a Q&A session later, so do please ask him any questions in our Discuss page. And again, once more, please do fill up the surveys so that you can get your t-shirts. Now, last but certainly not least, we have Jain's Neuse, the founder of WunderGraph, which aims to help developers remove the burden from API to application. His talk will go into how allowing queries to be defined on the server will help certain patterns regarding authorization, authentication, and caching to be more flexible and simple on the backend. So please welcome Jens.
Hey, my name is Jens, and welcome to my presentation on rethinking graphical operations as a server-side language to build backends for frontends. I'm the founder of WunderGraph and happy to guide you through the next 30 minutes. So for me personally, GraphQL is a tool that has its place. It has its pros and cons. For me, it's not a religion. And we should always consider technology as a problem solver and not get into like too many discussions about should you use GraphQL or should you use REST or anything. And before we dive into the topic, I'd like to go through some of the like many statements I see in the community, just to get a feeling of where in the hype cycle we currently are. So one of the most famous statement you see is that GraphQL is better than REST. I think both have their place. Depending on use case, you should always consider when to use what, and not just use one over the other, because it really depends on your case. And for example, GraphQL could be a very good tool for GitHub, which offers a public API to many consumers that they don't know. But if you know your consumers extremely well, and the number of consumers, for example, is one, it's yourself, then you should really think about if you actually need a GraphQL API. The next one is GraphQL solves under and overfetching, which is true, and also true for a REST API that has a query parameter to define which fields I want to have. So is that really something unique to GraphQL? Questionable. The next one is GraphQL is type safe, and that's also true, and I quite like it. It's very good. On the other hand, gRPC is type safe too. And what about open API specifications? Those all go in the same direction, don't they? The next one is, so with all this complexity that GraphQL brings, we have persistent queries, and they seem to solve all your security and performance problems. We will be talking a lot more about persistent queries later, but let me just say that this statement is kind of true, but also comes with a lot of overhead and a lot of work you have to put in to organize persisting your queries and getting all that right. The next one is authorization in GraphQL is hard, and I think it actually is. With the REST API, for example, it's very clear to say, okay, I require those specific claims or something like a role for a specific endpoint. And with GraphQL, this is harder to distinguish. You have to put some logic into user resolvers, or you could use like schema directives. So there's many ways to tackle that, but it's definitely not simple. Another one is you cannot cache GraphQL queries, and well, you can definitely. And I think the best answer on this statement we have from last year's GraphQL Summit, that is from Marc-André, who said when you have a very dynamic API, it's harder to cache versus a very specific API, like for example a RPC API, which is easier to cache. And we will come back later in the talk to exactly this point, and we'll see if it actually holds true. The next one is you just need a GraphQL database or ORM, and you're almost done. So I see a lot of hype about tools like, for example, Hasura, where you take your Postgres database, you turn that into GraphQL, and all your problems are gone. And so from my reality, there's usually not just a Postgres database, there's different services, you have to combine them together, and then you have different systems that provide authentication methods. And so there's a lot more things to be done than just spinning up a database plus an ORM. So I quite like tools like Hasura or Graphile or you name it. They can help in specific use cases, but they are not the holy grail to solve all your problems. The next one is GraphQL is self-documenting. We have the GraphQL schema. It gives you a lot of information on your types and fields. That's very useful. And you could also add some descriptions that could also help. But the question is, how is that distinguishable from, for example, a Protoro that documents a gRPC API, or an open API spec that documents a REST API? And by the way, OAS files or open API spec also comes with functionalities to define what a valid value for a specific field or argument is. So it's actually, in that regard, a lot more powerful than GraphQL. And then there's also the transport layer, which the schema doesn't tell you anything about. Then you might need to authenticate yourself. You need to have some authorization rules applied. And all that information is not available through the GraphQL schema. So yes, GraphQL is kind of self-documenting, but also lacking a lot of information that you actually need as a developer to get going. And the final one is federation solves all your problems. So also on this topic, I see a lot of hype around federation and how people want to adopt that. And I think, so there's a very popular book from Martin Kleppmann on distributed systems. And I think distributed systems also always add a lot of complexity to your system. So if you split up one single monolith into multiple services and you turn a function call into a network call, there's a lot of things that could go wrong. And you should always consider the trade-offs, that what you actually get from something like federation and what are the costs. You need to deploy more services, you have those network calls fail, etc., etc. So just consider all the pros and cons before deciding for a technology, and not just choose technology because it's currently something that is super hot. So with all this discussion about pros and cons, the question arises, if we go through the hype cycle of GraphQL, what is actually a very good use case for GraphQL? What is something that GraphQL is very, very good at? And so from my point of view, I think where GraphQL actually shines is when you want to query data from different services and you somehow make it available that you get the data through a single GraphQL query. So when you can write a single GraphQL query to traverse different domain models from different services, I think that's very powerful. Another one is if you run a public API like GitHub, for example, they are not able to know all the use cases of their clients. So for them, it's very, very useful to offer a GraphQL API, because they don't have to adjust their REST API like all the time, because developers can pick from the GraphQL API whatever they need. The thing is, most of us don't build public APIs. Most of us build APIs for ourselves, for people that belong to our team or our organization, and we can usually talk to them. And even if you build partner APIs for partners, you're also able to talk to those partners, and they will not go into the millions. So it's always something to consider. Do you really benefit from using this technology? And if you think the answer is yes, then you should also take into consideration the trade-offs, because running a GraphQL API is not extremely simple. It comes at a cost. You have to secure it. You have to make sure it runs performant, etc., etc. And so with that, I want to head over to discussion. Would you open up your MySQL database to the front end? And the answer usually is no. So who would ever want to do that? I guess nobody. And the thing is, in case you run a GraphQL database and open that up to your front end, actually a GraphQL database and a MySQL, a GraphQL API and a MySQL database, it's actually kind of very, very similar in that regard, because it lets you do a lot of things that you might actually not want the user to be doing. So take into consideration the efforts it takes to protect a GraphQL API, and not just apply it to any problem you see. Okay. So with that, I want to head over to the next section where we talk about actually good use cases for GraphQL, at least from my point of view. And so to make this a bit more illustrative, I have a example scenario. So this is the GraphQL In Space conference. So let's say you're a freelancer and you're asked by acme.com to build a landing page for a rocket launch. So we will head over to the demo in a few minutes. And what you will see is a website where we have it's a landing page for a rocket launch. You can see the tasks that we need to do in order to launch the rocket. Users can log into that site and comment. Then we have the rocket control API. That's a REST API to actually control the rocket. We have the astronaut editorial. So we have some information like a picture, description, etc. about the astronaut that will sit in the rocket. And then the rocket control API, it tells us the country code of the rocket. So it tells us the country code above which country the rocket currently is, and we can then take the countries API from Turboblades and turn that into some country information with country and capital, so that we actually know, okay, the rocket is currently at that altitude and speed, and it's above this and that country. Okay, so this is kind of what we want to build, and we want to see how we can benefit in this scenario from using GraphQL. So some of the considerations we want to make here is we want to authenticate our users and we want to apply authorization. So we want to make sure that you can only post a comment or add a task if you're authenticated, and you should only be seeing your own personal tasks, of course. Then for the editorial part, we want to add caching. So it will not change that often, so we can actually cache that. So we want to cache the API results. And for the rocket launch, we want to have real-time updates. So we have, behind the scenes, we have a REST API that gives us the current altitude, speed, and country code above which the rocket is. And we want to take this REST API and turn it into a real-time subscription. And then finally, what we want to think about is how we integrate all those services. So if you go back to this slide, so we have tasks, comments, rocket control, astronaut editorial, and countries. So that's 1, 2, 3, 4, 5 services. Two of which or 3 of which cloud services. So we have /Dgraph, we have FounderDB, we have GraphCMS. We want to integrate them all into one unified API layer. And the question is, where do we do that? Like, do we do this in the client? Do we build a backend for front end? Do we build a custom middleware? Where do we put the API keys, etc., etc.? We need to consider how we build the user experience. So there's lots of ways how to do that. And finally, we want everything to be performant, secure, etc., of course. So the question is, how can we tackle that? And ideally, we will be able to abstract away most of those problems. So the integration part, so integrating all those APIs, ideally, we could just configure it. So we don't have to do anything. We could just configure it. The middleware for this specific use case, we want to build that without coding. Okay. The authentication, authorization, and caching layer, this is always also something that ideally we can just configure it and the problem goes away. And finally, based on the API layer, so the middleware layer that we generate, we actually want to have a code generator that takes this configured or this specified API, turns that into a very smart client that knows exactly how the backend works and can talk to it very easily. So with that, ideally, you as a developer, as this freelancer, you can fully focus on making this a very, very good user experience. You focus on your business and you don't have to write like so much glue code, okay? So the whole authentication, authorization, caching, I want my type-safe client, all those problems, ideally you can just abstract them away. And this was the motivation for me to start building WunderGraph, because I personally encountered those problems over and over again, and I wanted to build a solution that just abstracts them away from me. So part of the puzzle in this case is we're heavily using persistent queries, and I kind of see persistent queries as a way of defining JSON RPC. So you take a query, you store it on the server, and it kind of becomes an endpoint. So what are the origins of persistent queries? So if you look at this post from Lee Byron on Twitter, for example, it's from 2013. He said that Facebook used persistent queries in back in 2013 just to make things more secure and more performant. There are, I also heard someone at Medium say they use that too, and I guess there's many more who use persistent queries. You have different flavors, so not everything that is named persistent queries is the same thing. Some name it, for example, query whitelisting. And then there's a very specific group of persistent queries, and that is compiled queries, and that is what we use at WunderGraph. So by compiled query, what I mean is I'm not just taking a query, storing it on the server and then executing it later. Compiled queries instead mean at compile time, you take the query, you lex it, you parse it, you normalize it, which means you clean it up from white space and everything. Then you do your validation, and then you compile the query into a executable tree. And that executable tree, you will store it into a hash map, and it's very, very efficient to execute that executable tree. So at runtime, what we do is, so we take this query, we store it, we create an endpoint for it on the fly. So there's no build time step, or you don't have to deploy anything to do that. It's simply storing a query, and then everything happens behind the scenes. And at runtime, we take the executable tree out of the hash map and we simply execute that, and it's extremely efficient. So at runtime, the only thing we need to apply is we apply the authorization rules, so who can see what. We take your job, we validate that, we inject that into the query or the executable tree, and then we might add a caching middleware here and there to cache some results, and that's basically it. Okay. So from my point of view, GraphQL is an amazing technology if we keep it on the server. So whenever you can actually benefit from this approach a lot, because it kind of gives you the same flexibility as you know it from GraphQL, but without all those performance and security problems. Okay. So to the benefits of that, we significantly reduce the attack surface, because to the outside world there is no GraphQL server. And another aspect of that is, because the GraphQL queries sit on the server and never leave it, they don't get to the client, we can actually move authorization rules or authorization directives or rules from the resolvers into the queries, which means, for example, if you consider that, normally you have, for example, auth directives, which you apply to the schema. it kind of limits the use cases that you could have for your schema. If you move this logic to the query, it gives you a lot more flexibility on how you could use your services. And then finally, all this completely decouples the implementation from the backend and the API consumer. So here's an example which we can see. So this is our debugger. So on the top, you can see a JSON. That is actually the content of a JWT. So we have two claims, email and sub. And the query reviews, this is a persisted query. So by defining the query reviews, what we actually do is we create an endpoint, and that endpoint is named reviews. And what we also do is we take the email variable, and the user cannot supply that variable. What we do instead is we take the claim email from your JWT, so you have to be authenticated, and we take that and override whatever you supply as email. So it doesn't even matter if you supply something. We will always take the email from your JWT, and if your JWT doesn't have an email, then you will not be eligible to execute that query. So that is one. So this means we have authorization embedded into this query because you only get the reviews that are tied to your identity, while the upstream API, so the reviews API, that's in this case it's coming from GraphCMS, it has no concept of authorization. We added that on top. The next one is we have this cache directive. So we add cache control headers, max age 120, plus we add the JWT.sub. So the sub from the JWT, we add it to the internal cache key so that each individual user gets their own cache key. And something to say about the cache directive. So because this reviews query through the compile time step becomes a get endpoint, we can add those cache control headers. And this means that you could put a CDN in front that can totally cache those queries, or your browser could do the same thing. So it's very easy to cache, no problems. And with that, I would like to head over to a live demo. So let me just prepare my environment. So we have a bunch more minutes. That's amazing. Okay. So here's our browser. Let me just restart our environment. So we have the Wunder node, which needs to be up and running. So here's our console, which we will see in a minute. And this is the actual React application. So here we see the astronaut part, that's the editorial. All this content is coming from GraphCMS. So you can see here, this is the GraphCMS interface where we created that content. Then we have the tasks. In order to use that, we need to be logged in. So I just make sure I'm not logged into GitHub. So I log out here. And then I click the login button. I sign in. We get redirected. You see I have all these tasks. So astronaut is already in the rocket. That's amazing. Then, for example, I could ignite, and then we could proceed to the launch experience. These tasks, they are coming from Dgraph, so /Dgraph, that's their cloud service. It's coming from there. And then you have the comments. Those are coming from FaunaDB. So we've also added FaunaDB to the stack. So this is the comment. So hello from GraphQL in space. So we could add that comment, see it in our list here. Awesome, that works. And now we go over to the real-time part. So behind the scenes, we have the REST API. The REST API tells us the altitude and height of the rocket. and the country code that the rocket is currently above. And then we have the Trailblades countries API. I'm running it locally. And we take this subscription and join it with the countries API so that we always know the country above which the rocket currently is. So let's head over to rocket status. You see currently no speed. So we hit the launch button. You see it speeds up, altitude is climbing, and it's starting in United States, of course. And then after a bunch of seconds, so this is all scripted, it's just a demo, of course. No real rocket flying. So it's then moving to Canada, Antarctica, speeding up, then Ireland, United Kingdom, capital is London, then Netherlands, and finally it gets some acceleration above Germany, and that's basically the whole story. So if you look at the configuration, so this is our WunderGraph console, which is we're currently in public beta. So if you're interested, go to wundergraph.com. Just log into the console. It's free of use. Try it out and give us feedback how we can improve that. So we have the concept of data sources. So I added all those data sources here. So I have my editorial, the comments, the to-dos, the countries, and all that. Houston, that's our REST API. So we can take REST APIs, turn that into GraphQL on the fly. And then we have GraphQL in Space. This is a compose API. So I can say add new data source. I can then select composed. So I select a bunch of APIs, then merge them together to get like a single unified API on top of all of them. And then the next concept is we have the application. So here we combined all those APIs, and then we can define all the endpoints or the persisted queries or the RPC calls, whatever you call it. So we have add task, all the tasks. We can set the task completed. We can delete tasks if we want. This is the astronaut page where you see we disable auth because we don't need that here, and we apply caching. This is the record ID from GraphCMS. Here we get all the data, including the image. Then we have all the comments coming from, that was FaunaDB, add the comment to Fauna. And finally the launch API. So post launch, that is the REST API. And then we get a subscription. We don't need auth for that, so it's public. And the rocket status, it comes from the REST API, and then we take the country code and join that against the GraphQL API. So we can have a look into that. So we launch the rocket, and then we got the rocket status, and you see the data is updating. And with all that, so we configure the data sources, we configure the applications, then we configure auth. So I have my auth provider configured here, that is GitHub in this case, and I have created a client. And then the final step is we have a code generator that is WunderGen. It takes all this configuration and generates a provider. So that is our dependency injection container. It generates the hooks, so all the React hooks that you actually want, plus a client. And the client, it contains all the specifications for your whole GraphQL schema across all services. Plus, it's an OpenID Connect client that automatically does all the login. So if you look at our index file, you see this is all generated, this WunderGraph provider. It doesn't take any configuration because we can generate all that. So it's very easy to set up. Also, if you have like a subscription transport, you also don't have to set up anything. It's all batteries included. And now we can go to one example that illustrates how you would actually use that. So here's the comment view. So from WunderGraph, from the WunderGraph hook, we actually get information if the user is authenticated, and then we can run that operation. So here's our fallback. in case the user is not authenticated. And add comment, it's a simple hook. So you see, with that code generation, we can hide all the complexity of how do you log in a user and how do you make all those calls. We hide all that because behind the React hooks. Okay, so that is that from my demo. I hope you enjoyed this talk, and now I am happy to take any questions. Thank you, and see ya.
And we're back. Well, thank you, Jens. I love the whole notion of storing an executable tree in a hash map. And with that, welcome to the Q&A session. You know how I've been asking all of you to post questions and discuss, and well, there's a reason for that. You see, today with us is Alex, Andréa, Jens, Robert, Sam, and Manish. Yen will join later, and so let me explain to you how this will work. So we've collected the questions for our panelists, and I'll be asking them in turn. So I'll be going, Robert, so-and-so, the questions, and then panelists feel free to butt in with answers or follow-up questions if you have them. Cool. And I think we're live with the questions, right? So let's, can you all hear me?
Yep.
Yes.
Excellent. Right. So let's start with a question that's open to all. Anyone can pick up this question to answer. So if I'm brand new to GraphQL, what should I do next to get my head wrapped around this space? We'll start with let's see, Alex starts first. Go.
Oh dear. I don't know. I learned by doing stuff. So my first thing is just finding some docs or a tutorial and start walking through and just doing it over and over and over until I learn something eventually.
Andréa?
Yeah, so what was really helpful for me was I used a resource called How to GraphQL. And what I loved about it is there was text, there was also a video, and then there was a knowledge quiz. And then building a project is the best way to learn. For me, I learn by doing. So think about something you want to do with GraphQL and start it and figure out resources as you go. It's a really great community. You could always ask questions on Stack Overflow or Slack groups, but the best way to get started is just think of something you want to learn in GraphQL and a project that you want to do. And just keep it simple. Don't try to learn everything.
All right, Jens?
Yeah, maybe to add to that, I would just go to graphql.org. I think they have very good documentation on all the concepts, what you need to understand. And that's a very good starting point, I think.
Okay, Manish?
I'll give you an example of what not to do to get started with GraphQL, because like remember we started in 2015. So we started with the GraphQL spec. It's a long detailed document with a lot of intricate, interesting details. And we started there, and it takes a while to like wrap your head around it. Thankfully today there's a lot more resources available on the internet to get you started, get you building an app really fast and really applying GraphQL instead of like learning the GraphQL spec. But I do want to ask you, Chu, because you recently learned GraphQL yourself. Like, yeah. What do you think some of the resources are?
So I agree with Jens that having the spec actually helps a lot because different people think in different ways. I think in BNF. If you give me a BNF, I'll understand a lot faster compared to say most people. So yeah. I say have a spec, and the BNF is gigantic, by the way. Yeah, so let's pass this question on to Robert. And yeah, Robert.
Yeah, I don't know how to improve the answer that all the fine folks gave. It's pretty hard being last here. Come on.
Oh, Sam's not answered yet. So.
Yeah, I do think that there's two ways to interpret the question. How do you get started with GraphQL? One is how do you get started with GraphQL as somebody who is building an application with GraphQL, right? And you can subdivide that into how do you get started consuming a GraphQL API, and that might be for those of you who are front-end engineers. And another concept might be how do you build a GraphQL server for your front-end engineers if you're a back-end engineer? And a third variation on that might even be, how do I get my team to start using GraphQL? I know what it is, but how do I get my organization to adopt it? And then a fourth one, which is the least common, but in my opinion, one of the most interesting ways to ask this question is how do you get started by contributing to the GraphQL community, contributing to all the really exciting projects that we have. And I want to answer the last one first, because I didn't hear any questions about that. I have a great answer for this. We have GraphQL working group. The working group is the body of people who comes together and It helps push the various GraphQL projects forward. It's very interesting. It's very open. Lots of smart and passionate folks, and it's open membership. If you want to find the GraphQL working group schedule, just check out the GraphQL repo on GitHub. It's under agendas. Sign yourself up, and you're in. And it's very accessible. I don't know of another open source project that has this level of visibility while maintaining this level of openness and low barrier to participation. So the other three, I think, are all interesting topics that I would like to hear from other people. But definitely in terms of joining the GraphQL community, being a contributing member, check out the repo.
Cool. Sam, any thoughts?
Everybody basically answered it. The only thing I didn't hear that has helped me in the past has been to try to rebuild something that was in REST that I had and do that in GraphQL. So that would mostly be on the back end, but you could also experiment with that on the front end. Try to take a project that you have that's using a REST API and turn it into a GraphQL project. That has helped me a lot with just translating between, like, getting the mental model down between REST and GraphQL.
Right. Yep. All right. So now we're going to go into individual questions. We'll start with Manish. We'll do it in the order of the talks of the day. So Manish, we'll start with you. Credits are based on queries. What about layered queries? This is, of course, talking about /GraphQL. I may return 10 filtered records from a subquery that hits 100,000 records. What's the cost there?
Yes, so if you actually behind the scenes access 100,000 records, and that's actually typically what happens with graph queries. They can look very simple, but they can traverse to a lot of like records in the behind the scenes, do filtering, do joins, and so on and so forth, and then finally only return 10 results. In that case, I think we are still considering the query cost, the cost of running a query, and that would consider all the records that we had to retrieve in the back to be able to run this query. And so the query credit, the cost of the query would be proportional to that. And again, remember, this is actually using a logarithm. This is using a logarithm of the number of records accessed. So, 10,000 records is like 3 credits and 100,000 is 4 credits, and so on and so forth.
Okay, makes sense. I see we're joined by Jain. Hello.
Hey guys.
Okay. So what we're doing is we're going to go around by speakers, and I'll be asking individual questions to each of you. But if you have any answers that are good, you can just jump in and answer after the person who's targeted. So, right now, question is now for Robert. Is it good practice to make GraphQL proxy servers over REST API providers just to hide the REST endpoint? Or is that a waste of resources in case I don't want to, expose my REST endpoints to the front end?
Okay, let me see if I understand this. When you say proxy, you mean leaving your REST API in place and then putting GraphQL on top of REST?
That is correct.
And then is the REST API also still in production and serving requests at the same time?
That's the question, right? In case I don't want to expose my REST endpoints to the front end. So maybe not.
So I think the REST endpoints are still in production and they're just trying to hide it.
Okay, yeah, and I guess the decision to hide it can be kind of a pretty easy switch where you just switch over to a different path that expects GraphQL requests exclusively. Yeah, I think it's a good way to get started. Going back to Sam's point, it's a way to ease yourself in, and anything that makes you or your organization more comfortable in terms of getting your hands on with GraphQL goes a long way, because like everyone said, I think just about everybody who answered that first question mentioned that it's how important it is to go hands-on, to have the thing in front of you, to know how it works, how it breaks, what the limitations are. And if that gets you there, then that's the path. And I would even go one step further. I think there's some people, when they talk about REST and GraphQL, they seem to set these two technologies up as a dichotomy, like you got to have one or the other. And let's think about this for a second. That's impossible. You'll never have a pure GraphQL API, or almost never, because if you're dealing with anything like HTTP, something is going to transfer some resource, like an image or a binary or whatever, and it doesn't really fit in the GraphQL model anymore, right? And this is exactly how the Facebook GraphQL API works. If you fetch, profile picture for a user or your friend's profile pictures, you get a URL. What are you going to do with that URL? That's not GraphQL. That's HTTP, or that's just a resource-based HTTP. So I think the reality is that REST is never going to go away, and that's not a bad thing. Like REST is a powerful architecture. It has a whole host of benefits that GraphQL will frankly never match, and it shouldn't. Like GraphQL is a tool. It solves a specific set of problems, and when you use the two in conjunction, you can get a lot of benefits. So I wouldn't necessarily even see it as, oh, look, this REST API is a legacy, and we somehow need to modernize and move up to the GraphQL API. It's more like, what exactly was there a performance problem? Was there an overfetching issue? Do you need subscriptions for reduced latency? And once you have those use cases in mind about why exactly you're using GraphQL, then okay, you have reasons to move.
Okay, that makes sense. So anyone wants to jump in on that? No?
Yeah, I guess maybe I can I want to add something as well, because GraphQL is great for a lot of front-end focused teams. You can get you access to a lot of data in having the backend really easy and really quickly. But for a lot of backend processes that talk to each other, you really don't need GraphQL. REST is really easy, really good to do as well. So like Robert said, it's not going anywhere. They each have a really good use case, but they can be used and complement each other quite nicely.
Or to put it as Jens said, it's not a religion. Right. So the next question is for Andréa. Do you still overfetch data from your database, or do you have some dynamic way of generating what fields to query the database?
Can you say that one more time?
Yep. So do you overfetch data from the database, or do you have some sort of a dynamic way of generating what fields to query the database with?
Yeah, so we do have some overfetching. I think GraphQL abstracting over REST APIs is perfectly normal, just as it would be to abstract over multiple database calls. But yes, we do overfetch a bit. We use data loader and field resolvers, and that's still an open issue that we're working on. But for the most part, we are getting the data that we need, but it still does happen.
So you're not using like a dynamic generator for your queries?
Not yet.
Cool. All right, the next question's for Alex. So does Gatsby pull the entire data set from your GraphQL endpoint or on every deploy? And if that's the case, wouldn't that just get really slow for large sites?
Yeah, so there's a couple answers to that question depending on what kind of build we're talking about. So if we're talking about no cache, cold build, it's going to fetch all the data you've requested it to build. In that demo specifically, I filtered down just to films, and I actually filtered down to 100 films because the GraphQL or the Dgraph team who loaded that database was very kind and gave me a couple million nodes to work with. But I wasn't about to download those all into Gatsby. So that's the scale Gatsby's not even ready for. I think we're working on like the 10,000+ node level right now, and continually looking to improve that. But yeah, so it can be an issue, but that should be just the initial build time. Once you have that cache in place and you're doing warm builds, a good source plugin, which is part of what the GraphQL toolkit that we are releasing is helping with, is that source plugin should only be fetching the changes now. And that can be done in a couple different ways, but basically it should be able to reach out to the database or whatever and say, hey, what's new since the last time I built? It received those updated nodes and it just has to change those. The demo I had doesn't really do that yet, though with the future JavaScript functionality of /QL that Manish talked about, that is something that would be much more possible, because then every time I write a certain type, I could add basically some kind of change log in another type that says, hey, this node with this ID over here updated. And then I just need a timestamp cached on my Gatsby build that says, hey, this is the last time I built, and it just pulls all the latest from that data type. And the final one, which is what I demoed at the end, was incremental builds. And again, I kind of hacked that one together, but basically I passed the ID of the updated node for the film into Gatsby, and the toolkit just handled saying, oh, I know how to fetch just that node. It fetched just that piece of node, updated just that page, and rebuilt the site and redeployed it. So initially you have to fetch everything, but if the plugin is built correctly, it doesn't have to rebuild on every fetch or refetch on every build.
Yeah, okay, that makes sense. Yeah, and you did show off the incremental build. Okay, yep. Thank you. So the next question, moving on really quickly, sorry, we've got time to keep. Moving on really quite quickly, it's for Sam. So in the case where granular permissions are required instead of roles, what would you recommend for authorization? And follow-up questions to these would be like wouldn't storing the entire permissions in a JWT be a terrible idea because it's going to be quite huge in this case, right? So yes, over to you.
Yeah, so I mean, there's different ways that you can store permissions. Sometimes it makes more sense to store permissions in the database and pull those when you grab the user, and then do it that way instead of storing the permissions in the JWT itself. So you can be flexible on that. It's also, yeah, I saw in the question on the Discord about changing the token to reflect the updates and things like that. If that's another issue that you come across, that might be another good reason to store your roles or permissions separately in a database. And then when the user is authenticated and they log in, then you can go pull those permissions based on the user ID. As far as granular permissions instead of roles, it really kind of just depends on what you're trying to do. If you need like access on the field level or the object level or things like that, but all of those are valid use cases. So it's kind of hard to answer without knowing a little bit more specifically what the situation is. But yeah,
use cases. Yeah. Okay. Now that makes sense. And our next question is for Jain, about AppSync. So how does AppSync figure out what to cache?
AppSync doesn't. You configure it. So for AppSync, you can cache your entire request, and that's kind of the default behavior. But you can also tune it so that you can decide which of the resolver you actually want to enable caching on. You can also do that by saying, okay, for this request, I can cache. I want to take the user ID as make it part of the cache key. I want to also include maybe the user's identity username, so that those becomes a unique data points that gets cached. Or maybe if I'm doing a nested resolver, maybe I want to cache the university a student belongs to. Everyone from the university is going to be querying the same data. It doesn't make sense for you to fetch the same data from the university table every single time. So I'm going to cache by the university's own ID. So you have a lot of control over which piece of data gets cached with AppSync. And I guess all you have to configure in that case is just what goes into the cache key.
Cool. That's good to know. And so AppSync is only AWS. Have you seen something like that from GCP or Azure?
Not yet, but I don't use those. I don't use the GCP or Azure as much.
Fair enough. You're an AWS hero, so.
Well, yes, there's enough coming out of AWS that keeps me busy, so I don't have enough time to try everything. But as far as I know, they don't have a GraphQL as a service on those platforms, at least yet.
All right. So
Go
the
AWS.
next, sorry.
Go AWS.
So the next question is for Jens. It's about best practices on when or when not to use persistent queries. See, on the one hand, you've got like the benefits of caching, but on the other hand, the flexibility of GraphQL, allows the users to send queries without overfetching, and those things are not predefined upfront. So Jens?
I would actually rephrase that question to what happens when you don't use persistent queries, because when you start up using GraphQL, you feel like, okay, in the client, I can write my query, I get all the data I want, no under overfetching, blah, blah, blah. And then maybe there's some sensitive data and you haven't really thought about how a user could traverse your schema, or how could they get from one field to another that they should actually not see. So there's a lot of complexity because it's a graph and you can traverse. There's a lot of problems with that. And so before deploying your GraphQL server to production, if you don't have the knowledge to make a GraphQL deployment really secure, you actually shouldn't be doing it. And you need an expert to do that, who knows all the problems that can occur. And for some problems, persistent queries are a solution. I'm not saying you must use persistent queries, but for some, they are a very good solution because, for example, what we do at WunderGraph is you persist the query, you attach, for example, a required scope, and that simply means you only can do that with the scope, and that's it. So by that, we're eliminating a lot of security problems. There might be other solutions. I'm not saying this is the only way to do that. It's more like, yeah, if you want to use GraphQL in production, be sure that you understand all the problems that it brings with it.
Cool.
Yeah, and I just want to add a quick note on the power of persistent queries. This is really something that helps out a lot in production because it helps you identify that query. So for instance, without a persistent query, you would have no way to know which clients are sending what queries, right? And so, for example, I'll go back to Facebook again because I think it's just the largest scale GraphQL server out there. What we had at Facebook was a database of all of the persistent queries that were ever written. And we know which version of which client application sends that query. So for instance, we might have a persistent query hashed to, ABC123. We know this comes from iOS version, 212 or something. And we also know what that hashed text resolves into as far as the GraphQL document goes. And so if you introduce an API breaking change, well, think about the tooling that we can do. Now we can say something like, okay, if you remove this field, or if you retype this field from an int to a bool, it will affect the following set of persistent queries, which will affect the following set of client versions. And then you can then make a decision like, is that okay, right? Maybe the version that you affected is from 5 years ago. And if you look at the graph of the number of users sending these requests in, it's down to a trickle of maybe a couple dozen. So you can make that kind of judgment call, but that would not be possible without persistent queries. So really, really insightful here. Persistent queries, very often overlooked, and it would solve a lot of problems, not least of which is security, bounded complexity, but also just in terms of end-to-end tooling.
Actually, on that note, can I ask a follow-up question there? So I think does Facebook also manage two different versions of the same GraphQL schema with like slight variations, where something could be string in one version of GraphQL schema and could be bool in the other version, to maintain backwards compatibility with the older clients?
No, not as far as I know. Maybe it's changed, but there's no notion of versioning that GraphQL schema. I'm talking about the Facebook universe. So there were 4 GraphQL universes at Facebook. What the other ones did, I'm not 100% sure, but the main one, the big one, that had no notion of versioning.
I wanted to add one more thing to that, because I really like the example. So you usually have the problem with native apps that you deploy them, you go through the Apple App Store process, it takes some time. You cannot change the app when it's out there because people have like super old versions of your app. You cannot change it, but the query is there. And with persistent queries, it's not just that there's a client with that old query. You could actually, because it's persisted on the server, you could actually add a middleware that makes this client still compatible to the breaking change. You see?
Absolutely.
That's a pretty good way to think about it. And I think in our talks today, Sean Grove also echoed a very similar point of view. So That's very interesting. Okay, our next question is open, and we're going to go the opposite direction. So we're going to start with Sam, right? And this question is quite a mouthful. So and we'll start with Sam because Sam is pretty much the guy who talked a lot about directives. So with the implementation of directives left to the discretion at the server framework provider, the people who are actually implementing the server, what happens is we'll end up with a landscape full of very deeply fragmented frameworks to the point where we don't even have a standard way to handle dates. What gives? How would you tackle this problem? And would a new GraphQL standard help with this thing?
I personally think that is a problem that can come up. You might try having a shared date directive inside of your organization. I'm not sure. There are other people here who have a lot more sway on the spec and things like that as far as prescribing something like this in the spec, but it seems like this would be something that you'd want to do internally as an organization and have a standardized date directive that you use throughout your organization and not try to solve it for the world at large, just since dates are so frustrating and complicated due to time zone issues and things like that. But I'd definitely be curious to hear what any of the other panelists would have to say about it as well.
Yen? Any thoughts on that?
Yen or Jens?
Yen.
For me? Okay. Don't have anything to add.
Okay, Robert.
Maybe Jens does.
Yeah, dates are the most commonly requested custom scalar, and the way we've gone in so many circles around datetime custom scalars in the spec. It's got a really interesting history, and it's well worth following. But customs. So one of the approaches. Let me back up. I don't want to assume any prior knowledge here, but the problem here is that GraphQL doesn't have a very rich type system. There are 7 built-in scalars, and in a lot of languages, a date is a scalar itself, right? Or at least it's embedded type that is available to every implementation of like JavaScript, for example, just has a notion of a date somewhere. Same thing with .NET. Same thing with a lot of. I don't need to give any more examples, but the problem is how do you like Sam was saying, how its date time is super frustrating there's like at least 4 different major specifications out there, each with sometimes conflicting or contradicting representations of date and time zones and standardizations. So what do you do? Well, in GraphQL, we have the ability to create something called a custom scalar.
Yeah.
And this is like, you might create a custom scalar for a simple data structure that, remember, scalars as opposed to object types are fields in GraphQL where you can no longer select into. So you can think of them as dead ends in the graph, right? They're leaves. And the ability to create custom scalars has been around for a long time. So you can always go in there and you can create a custom scalar like, lat long, let's say, right? But with datetime, you have to be a little bit more careful because what is the format that you're using? If you choose something like Unix epic, you should have the ability to say that this is not just a number, this is a Unix epic.
Yeah.
Or let's say that you're using ISO 8601 and you use a certain extension to ISO 8601. You should be able to say, this is the encoding format for this datetime. And now, to be 100% clear, GraphQL will never solve this mechanism will never solve the problem of unifying everybody in the world under one interchangeable datetime format. Nobody will solve that problem. But what it will solve is it will have the ability to say, not only is this a custom scalar, but this custom scalar is to be encoded and decoded in accordance with the following specification or set of specifications. Right? So you could say something like custom scalar, and then the specification is ISO 8601 plus extension B. And then what that will do, hopefully, is in the tooling, you can parse that and you can say, okay, I got it. Now, if I'm building an iOS application, the package that I pull in needs to be compatible with ISO 8601 and extension B. I'm making this up. I don't know if there's a library like that but hopefully that gets the point across, right? It's not just the ability to express custom scalars. That's always been there. It's the ability to express the specification behind the custom scalar within the GraphQL schema.
Okay, fair.
I just want to ask a follow-up on that to understand this. So Rob, what you're saying is you want to change the GraphQL schema so that when the client downloads the schema, they can actually understand how to encode and decode a scalar.
Yes.
Okay, I see.
Not me. I cannot take any credit for this work. This is all stuff that's happening in the working group.
Okay.
Manish, do you have any thoughts on that?
Yeah, I actually have a lot of thoughts on on that because we in the fork of GraphQL that we maintain, GraphQL plus minus, we sort of like added date time, we added geo, we added even a password type so that if you set the password type, then automatically encrypts it and you can never like get the original back, and we made it really secure. And date is hard. It's a lot harder than people imagine it is. And so I think to Robert's point about how do you deal with all these different like formats. I was just actually while Robert was talking, I was looking at like the Go time package, right? And it has like a long list of formats that you can parse, and one of them is RFC 3339. Right? Obviously, Epoch is another one, and there is even a kitchen format, which is like this. It just contains a time with like an AM or PM and nothing else, right? And we have the hard job. And remember, Dgraph has a flexible schema, so we actually have a hard job of trying to determine, does it look like a date, right? So we actually like go through steps where we will first try to see if we can parse it as an epoch. Then we'll try to see if we can parse it as a kitchen timer. Then we'll try to see if we can parse it as an RFC 3339. Then we'll try to see if we can parse it as something else. So we kind of like go through like 4 or 5 different parsers just to see, hey, does this look like a valid date to us? And then when we return back, that there's another problem, because just between Go and JavaScript, they cannot agree upon exactly what the formatting should be. The way JavaScript uses the date is different from the way Go uses the date. So we actually like have to convert it back into something that most languages would be able to parse when you ask for it back. So you can in Dgraph you can give it as an epoch, but then get it back as a JavaScript understandable sort of date format. And actually, I don't know if you saw the tweets live today, but the script that I have is sending it from Twitter datetime format, which is like epochish, into Dgraph, and then back as like a properly formatted string. So that is, that is tricky. And then if you think about geo, that's even like kind of weirder, because you have polygons and you have lines and you have like multi-polygons and so on and so forth. And password is something that we created, right? Like there's nothing like that exists. So that's the question that we always have around GraphQL spec. How much should GraphQL spec prescribe, and how much should the different implementations of GraphQL server add on, right? Like if you look at GraphQL plus minus, it has so many things. It has things like variables, just like SQL has variables. Should GraphQL spec also have variables? Probably not, because most users of GraphQL, like most implementers of GraphQL spec, it would be too hard for them to implement those things, and maybe they don't even need those things. So GraphQL spec
Turing complete,
right? And so GraphQL spec actually, the way I see it is that it has to be a subset of the functionality that everybody needs, and everybody agrees that yes, they want to implement it, right? And I think at this point, looks like datetime is something that everybody sort of generally agrees that it would be good to have. But do they agree that geo would be good to have? I don't know. It remains to be seen. So I think it's really about, it's almost like it seems to me from an outsider, it's almost like a democratic building, right? It's like when enough people say that they want something, then it becomes useful to have. Until then, you can kind of add on all of these interesting types, which would be useful to your users and probably would not be useful to, let's say, Facebook or an Airbnb or something.
So based on that description, do you think that the custom scalar specification feature, as I described it, would be useful for you?
I actually need to look a bit more carefully into that. So we actually have been, I think in the /GraphQL, we actually have datetime as a special type that we specify. And then you can use things as datetime. But I think a custom scaler there, just like directives, would be quite useful because then it'll become part of the spec. Probably not part of the spec, I'd say, but become part of the implementation.
Jens, anything else to add to this?
What was the question again?
The question's about fragmentation of the backend due to having the directives. So having a directive requires you to implement something in the backend by yourself. That leads to a fragmented backend. So what can we do to solve that? Robert and Manish and Jan has been talking about, and Sam has been talking about standardization process and focusing mainly on the date time, but the question is much more open than that.
Yeah. So one directive that I see quite often when we talk about security is that people like to use auth directives in schemas. And this is, for me, it's kind of a pet peeve because when I started using GraphQL, I first thought that tools like GraphQL Shield, for example, are really, really nice because you can annotate your schema and then you have the auth rules applied. And the problem with that is whenever something changes, you have to redeploy your server. That's super stupid because I'm in production. I have a security leak. I need to redeploy my server for a security issue. That doesn't make sense for me. It needs to be a layer in front of that. So that was the moment when I stopped using those auth directives and tried to put something in front of my GraphQL server to do that. So this is one thing. And the second thing I'd like to share is the problem with directives is when you add custom directives and you annotate your schema, those directives they get thrown away when you run the introspection query. You cannot see them anymore. So you have that meta information and it's lost to the client. So even if you want to give some hints to the client what they can do or not with directives, that info is lost. So that's actually a problem, and that kind of holds you off from actually using that more.
Cool. I have some deep thoughts about that, but let's not get distracted by that. Andréa, what do you think of this fragmentation thing?
Yeah, so I wish I could be more helpful on this question, but we haven't run into this because internally we just convert everything to milliseconds since Unix epic, excuse me. So a date time scaler would make this more expressive, but internally we just use epic, so it just hasn't come up yet. And we use milliseconds since epic because they're just really simple integers. So even if they aren't expressive, they're really easy to work with.
Cool. Well, simple solutions often trump things. Alex.
Actually, on that note, maybe I can add one more thing. That some interesting thing that we figured out about date times is that when we're doing indexing with date times and we're trying to index by hour or day, it's quite interesting on how you index. So initially we're parsing times in individual local time zones, and the same time in different time zones might have switched by an hour. And so you'll search for that string, and it would turn out that on that day this event didn't happen. But actually it did happen on that day if you were to look in terms of UTC. So then we learned to convert everything into UTC and then use it for indexing. And some of these interesting things, date is just such a poorly understood complex problem that I think you can write lots of articles about it and still miss out something about how
falsehoods programmers believe about date and time. There's actually an article called that.
I have a question for the group here. How much time do you think software engineers have collectively spent on time on this time?
I mean, Python's SF, the string passing, the string passing of time is actually a website. There is actually a website for you to go pass in your format. So, yeah, plenty of programmer man hours have been wasted on date time.
I guess we should ask people who actually had to solve Y2K, right?
Yeah.
And it's still not solved. It's still going on.
It's 204. It's coming. Alex, what do you think? What are your solutions?
unlike most of these people, I spend most of my time on the front end, so I have never thought about this. I'm just enjoying listening and learning here. So I deal with dates, but not at the database level like y'all have. So.
All right, no problems. And now we're going back to individual questions, and we're reversing the order. So we're starting from Yan and going back up to Alex. And then we'll have one final round of quick fire questions. All right, so Yan, in your talk, you mentioned that the social network is backed by two separate AppSync APIs. Is there a reason to have two, or could they have just been one?
Mostly because the CMS is not meant to be used by end users. It's only meant to be used by the founders and also by the university admins. So they've got a very different authentication model. So, well, different community user pools altogether. Since there's no overlap, there's no reason why I have to lump them together. So just easier to have two rather than one. But they talk to a lot of the same data sources, DB tables, Lambda functions, and whatnot. So there's a lot of sharing between the two. So having the two of them inside the same project and having a monolithic deployment process makes a lot of that development, I guess, effort a lot simpler.
Cool. Thank you. And now Jens. Is the method that you did, the compiled query where you stored an executable tree in a hash map, is that the best way to cache queries? And how would you compare that against other persistent query methods? Pros and cons. Go.
Pros and cons. It's simply the best method because it's just that because when you look, for example, at how the GraphQL.js implementation executes query, and once it gets super complicated and you want to extend the execution process, there's this ominous info object that gets passed along all the resolvers, and people try to figure out what is in there and how they can manipulate the execution of a query. And so when I started using that, I kind of came to a point where I was like, okay, the way GraphQL.js interprets queries, it could be correct, and it's the reference implementation, it's fine. But when I want to build something like, for example, a GraphQL proxy, it needs to be a lot more efficient. And so the way I build my engine, so to say, is I take the GraphQL query, I turn that into an AST, then I traverse the AST, and I have a configuration object that tells me, okay, if you want to have that field, you need to go to a database. If you want the other field, go to REST API. If you want to have that field, go to a GraphQL API. So I traverse the AST, I take all that information, and I have this kind of compiler, so to say, and then I built up a simple tree of functions. And I guess Dgraph is written in Go, so you guys are familiar with that. Go is it's a memory based language. How do you say that? Garbage collected language. Sorry. So it's kind of a hard thing to optimize to run Go without garbage collection. But the thing is, when you have a query compiler, the compiler can be a bit slower because you persist the query, and the tree that you will finally execute that has zero garbage collection. So it doesn't go anywhere on the heap, and it's just blazing fast. It's, I don't know, microseconds. And so from my point of view, there's nothing you could do to beat that.
Cool. Anyone wants to chime in?
I would say that I think when Jens said something about Go and garbage collector, my ears just kind of opened up because it's as a database, we have dealing with Go's memory. I almost feel like Go is like a memory monster, right? And you have to just continuously struggle with it to make sure that you won't go out of memory. But I completely hear you when you talk about Go and GC.
All right, next up, it's a question for Sam. It's quite long and quite complicated, so ears open. Most server-side authorization implementations I've seen actually involve checking the permissions from the JWT scopes at the start of each type resolving function. This means, for example, that a query may execute multiple database queries, like a GraphQL query will have to execute multiple database queries before reaching a nested resolver that fails a permission check. Is there any recommended way to verify all the permissions ahead of time to avoid this unnecessary computation?
So this came up in the chat as well with this person, and we talked a little bit about this. It's a really interesting problem to solve. We had talked about traversing the query AST to check permissions. One other way that you could probably solve some of this is to check some roles first to try to categorize your permissions in ways that would try to prevent maybe 60 or 80% of that happening. If you can check for a role at the beginning in the context, and then, gracefully handle the deeper query levels, you might save yourself a lot of engineering time of trying to really go complicated with this. Otherwise, yeah, I think trying to do having some sort of middleware to traverse the query and gather up all of those different permissions needed might be a good way to do it. But again, this seems to me kind of like a smell of maybe your permissions are a little too granular at that point, or maybe you need to kind of cluster them together or control the way the user is trying to reach that data. That's my 2 cents.
Okay, that's interesting. Yeah, so you think this is a code smell then?
It can be. I mean, there's probably a valid use case for it, but it may be before trying to do the complicated, AST traversal thing. There might be some low-hanging fruit of just saying okay, look at the data and figure out okay, when does this actually happen? When do these fail? And is there a way, are they failing in a way that maybe that's a sign that we need to create a new role that only has these certain permissions in it, and prevent the user from even trying to access that query to begin with. There might be some ways that you can take care of some of those issues without having to go too hard into a really complicated algorithm to pull it all together.
Well, one tiny thing to add here, permissions is one thing. So you could say, oh, you need to be a logged in user, but then are you allowed to see a record? Are you a viable viewer of that record? And most of the time, only the database can actually tell you that. So you actually need to fetch the data to know he can see that.
So what you're saying is some failures are inevitable. That's a good thing to think about, I guess. Yeah. Okay. Cool. The next question is for Alex. In your demo source code, it had some boilerplate. That's what you say it's a boilerplate. But some of our audiences have found it to be slightly confusing as someone new to Gatsby.js. So the question is will we be able to use Dgraph as a data source without those boilerplates when the toolkit's launched, or do you have to write these boilerplates for every GraphQL source that I'm going to use?
Yeah, so the good thing about that source toolkit is the boilerplate that's there is probably around 100 lines of code. Don't quote me on that, but it's my guess from what I've used it's about that. That's down from probably anywhere from thousands to tens of thousands of lines without a toolkit like that, and rewriting a lot of loops and other things that you would have had in custom schema design and stuff on the Gatsby side. So all that's been eliminated. It doesn't mean all of it has, but I was able to get that demo working at a basic level within a couple hours based on the examples that Vlad and team have put together. So that's a huge step forward. Then once they are able to release the toolkit, the next thing is turning, I believe on their plan, is to look again at the source GraphQL plugin for Gatsby and look to see if we can use toolkit either to update that, or we might just leave that plugin as it is and create a new source plugin that if functions similar, so there's, again, not all this, we can eliminate all of the that boilerplate code and just throw in a GraphQL endpoint and maybe some basic configuration, and you're off to the races. So.
Yep. Okay, that makes sense. So minimal change of code is required. Okay, gotcha. The next question is for Andréa. Is there any scenario where you will not choose GraphQL as an API format?
That's a really good question. I can't think of one. I've been really loving my experience with GraphQL so far. It may not be the right solution for everything. So I guess that kind of depends on what you're doing with your project. For me, I really don't want to go back to using REST. I've really been enjoying my experience with GraphQL. It's made development a lot easier, and our users are very happy, so probably not so far, but you never know. We really like thinking in graphs. We have a graph-based product, so I don't think going back to linear thinking would be something that we would do at Grapl, because it's the basis of our product to think in graphs.
Mm-hmm. And like I said, when you said that you can think of attacks structurally, that as a mathematician, that was very, very pleasing.
Yeah, it's so interesting. And if your data just isn't related, maybe not using GraphQL, but it's hard to imagine data that doesn't have relationships. So it's really cool to think in graphs. And it's been really helpful for our users and for our product. So I would encourage everyone to use GraphQL because it makes you have a much more powerful relationship with your data, and it's easier to understand.
Okay. Fair. Right. The next.
I have a good example of that if you want me to jump in.
Do jump in.
Yeah. So I think my general response to that would be is it depends on kind of the complexity of your data. If we're talking about anything that's going to require a large database, and there's a lot of relationships going on there, that's fine. But if there's a lot of standalone data, so like the perfect example of this from the front end world is like a web form, a contact form. There's no relationships there, it's just a couple fields. And so for me, it's way easier to create a quick function that's as part of a REST API that accepts that form data than it is to throw together a whole GraphQL server to not build relationships. So
yeah. Okay, anyone else?
I have another, sorry.
Yeah. Go on. Jens,
I wanted to say, to add another example. So let's say you have something like an AWS console where you configure like planet scale applications and you fill out like, I don't know, 10 sites of forms, and you just want to dump that struct and then load it again to the front end. Would you actually want to take like all those configurations and then try to get them into a graphical input? That's crazy. You really don't want to do that. So if you have like those kind of use cases where you build dashboards that just dump something and then show it again, there's really no need for something like GraphQL.
Makes sense. Yeah, absolutely. Makes sense. Anyone else? When not to use GraphQL?
OpenID connect callbacks.
All right. So the next question is for Robert. So do you have to do some practices to keep the server and client types in sync? Like if you ensure that a new field is deployed to the server and before the clients go live, and what sort of testing can you do around these sorts of changes?
Yeah. That's a hard question because there's many different things you could do. And I think what you should do depends on the scale that you're operating at. So I'm going to assume that we're talking about a pretty large scale GraphQL endpoint, pretty complicated schema, and we're dealing with native applications like we discussed earlier, where every version out there is going to live indefinitely, whether you like it or not. So if that's the case, then the first thing to realize is that you have to design with backward compatibility in mind. You have to do that. The notion that you can just kind of deploy and you can flip a version back and forth, maybe you can get away with that if you don't have any mobile applications. If you're a pure web app, in many ways, we're, as web developers, we are entirely spoiled because the application via caching can basically just be completely refreshed on demand, and we blow away any sort of old incompatible API protocols that the client expects to use. But you can't do that with native applications. You can't do that with iOS, Android, or even to some extent Windows native applications. So if that's the case, then yeah, you need to be really careful. The first thing you can do is just design the schema to not be backward compatibility breaking. And you can do that. You know that there are many things that you can do in GraphQL that are not destructive like that. So you can, instead of modifying an existing field, you can just specify a different query. And now obviously that can get ugly. Your schema can bloat out and reduce the signal to noise ratio of reading the schema. It's a trade-off that you'll have to make at some point, that the schema will no longer be, it won't fit into a single screen and you can read it and make sense of it. You'll have to go through and find parts that you need. The other technique is that you can definitely use some of the affordances in your GraphQL toolchain. So you can use deprecation warnings as for, if you have hundreds of client developers, let's say, and when they perform schema sync, you want to tell them to migrate off of a certain field because you're choosing to deprecate it for performance reasons. It's a very good reason to stop using a field. And the difference of making sure that the head version of your Android application is not calling that field versus getting rid of it forever is totally different, right? And then finally, I alluded to another missing piece earlier when we were discussing persistent queries, but persistent queries can go a long way to telling you when it is actually safe to deprecate a field. And there are a handful of cases where you may be lucky enough to push an API breaking change that happens to break nobody or breaks one person. And in all those cases, I mean, this is why it's so important to kind of have a whole picture of how you're going to deal with these things as soon as possible. Because if the client application could say something like, hey, we detected an API error. We don't know what happened, but try updating the application through the App Store or something like that, right? That goes a long way to making sure that even if you do end up introducing an API breaking change, that it is it is not as frustrating as it could be to the end user. The user doesn't feel like it's their fault or that they did something wrong. So I know that that answer was all over the place because
No, you actually brought up something interesting, and it reminded me that protobufs are designed to be backward and forward compatible. Is there some way you can link up protobufs with schemas?
There's certainly projects out there that I believe stitch together protobufs and GraphQL because they do have a lot of overlap in the sense that they both generate bindings that you can use as a type system that spans the client and the server. I think there's just kind of there seems to be a leaning where protobufs is more for service-to-service communication. I don't see protobufs used as often between client-server communication across the internet. Yeah. Although I have seen it, and it's pretty interesting. But definitely, a really interesting piece of technology.
Actually, right, you kind of got words out of my mouth because that's exactly what I was thinking as Robert was explaining some of the backward compatibility issues. Is protobuf, at Google, we saw the exact same issues, and protobuf was sort of designed to solve for them. So I think a follow-up question there, and hopefully I didn't cut you off, Chu. A follow-up question there, Robert, is that so protobuf actually has a bunch of these systems in place so that once you're there's best practices. Once you assign a number to a field, you never reuse that number. The number is you're supposed to create a new number so that all the previous data stays can still be read. Are there things that you think GraphQL spec should enforce to avoid sort of backward incompatible changes, or is something more of there's a list of best practices that people should do, but whether they choose to do them or not, that's up to the users?
Yeah, I mean that's a really interesting distinction. Nothing prevents you from going and making a backward compatibility breaking change to your GraphQL schema at the specification layer, or even at the framework layer, right? I mean, whether you're using GraphQL Java or a GraphQL.NET server, you can just go and change the annotations to switch the type of a field that would break all existing clients, or make a nullable field non-nullable, for example. And so the best practices, I think, are don't do that if you can avoid it. But there's nothing else in GraphQL that is that doesn't prevent you from shooting yourself in the foot. But I do want to. One of the really interesting things about GraphQL is like the reason why it ends up missing all of these affordances, and people look at it, you're like, okay, well, why is it just this one thing? And a lot of people seem to have brought this up. I think Manish, you and I were talking about this at GraphQL Asia. Seems like forever ago, doesn't it? But it was still this year. But
this year is a hard year.
Yeah, it's a hard year. But the reason is because the boundaries around what we know of as open source GraphQL are really arbitrary. If you rewind back to before GraphQL was open sourced, there was no clear line of this is where GraphQL starts and this is where GraphQL ends. There was just this sprawling set of tools and protocols and practices at Facebook. And it was really a dedicated effort from Lee and from Dan and from Nick to say, no, GraphQL stops here and here, and this is what we're open sourcing, and then we're specifying it as a separate document. But actually, there could be alternate histories where you don't draw the lines where they drew them, right? You could imagine that. I mean, and this is why when you look at client-side state management libraries like Relay, and Relay has corresponding libraries on iOS and Android that were never open sourced. But the idea that GraphQL would ever be its own thing, just floating out in the middle of nowhere with no solutions up and down the stack, it was never the case. That's why when you look at GraphQL, you end up with all of these integration problems. You're like, okay, where's data loader? Where's caching? How does it talk to this database? How does it construct efficient queries? How do you do persistent queries? How do you do client-side state management? There's just this buffet of problems because these were not real problems. Like Facebook can't work with these problems, right? It had solutions for all of them. It's just that the history is that there was an arbitrary line drawn. I shouldn't say arbitrary. I don't mean that in a bad way at all, right? The line had to be drawn somewhere. You can't just open source the entire stack. But the line was drawn somewhere to say this is GraphQL. And this is what gets open sourced. And that leaves, by definition, all the things above and below the lines. So you end up with this system where you're asking questions like, what about custom scalars? What about performance? What about caching? What about, like subscriptions and all these things? So anyway, that's a bit of a tangent, but hopefully it's an interesting one.
I think it makes a lot of sense because essentially like what Facebook released was a spec, right? And how it gets implemented was really up to the various implementers of the spec. And so they actually had to go and solve those, like, I would say infrastructure problems about, hey, do we put the caching there or not? How do we execute these queries? Do we iterate upon the results or do we try to do them in a batched way? Like all that stuff was really something that Facebook must have solved internally, but then they'll have to give a system out to the users, and then it would not be a spec that they release, then it would have to be like a GraphQL system that they release, which is a very different kind of a release, right?
Yeah, and at the same time, it also creates these very interesting misconceptions based on the use cases. Like one that I'm sure almost everybody here has heard of is this notion of caching in GraphQL, right? Like GraphQL breaks HTTP caches, breaks CDNs. And it's like, okay, well, let's think about that for a second. If that were a problem at Facebook scale, how could it have worked? And so the answer is simply that the data that comes back from the social graph of like, who are your friends, what events, where do they check in, that shouldn't be cached anyway. And I mean, asterisk, right? There's obviously like many different things that you can mean by caching. I'm talking about caching en route to the client, right? Where you really want that data to be as live as possible. But then people are like, okay, well, if I'm approaching this from a REST mentality where I did have these static resources that did take advantage of a CDN and I want that same benefit moving over from REST to GraphQL. Now you can see where there's kind of a disconnect. But again, I think that's all attributed to this kind of like this action of saying like, here's this really mature stack, this really comprehensive stack with solutions to all of these problems, and you take a piece, you're like taking a Jenga block out, and you're like, well, where's the rest of the thing?
Yeah, that makes sense. I think we have to wrap up quite soon for time. One more question for Manish, and then one more quick fire question for everyone, and we'll close off. So Manish, when will native JavaScript, which is currently in /, when will it be available in Dgraph?
That's a tricky one because so we were hoping initially to Dgraph is written in Go, and we were hoping that we would be able to call JavaScript from Go, and we looked at a couple of JavaScript sort of executors, but turns out they are quite limited in what they can do. So there's actually an open RFC at discourse.io, our forum, where we were discussing exactly what the best way would be. And I think from what I understand, the best solution that we have found so far is in /GraphQL, we're going to spin up a Node.js server, put the JavaScript code there, and have Dgraph call that. So I think if that's the way that we end up sort of going, then it would probably never be in Dgraph. It would just be something specific to /GraphQL, and you would probably still have to like run your Node.js server. And then I think before going to JavaScript, we were like, hey, can we just like run this in Go, or can we run this in some other language? Something which is probably easier to call from Go. But Go has to be compiled. You have to create a plugin. It becomes tricky, and I think parsing JSON with Go is also not easy. It's a lot of like map interfaces and very kind of complicated. If
you use structs.
Yeah, you need to use, the thing is you need to predefine all of the, so I think we are sitting as a vendor, right? We cannot assume anything about users' data because each of them have their own data. So either we need to generate based upon the schema a Go code for them that we can use to like parse their data types or not. And that becomes tricky as well, because then you're doing compilation every time schema changes. But the whole promise of this thing is that you one-click deploy, right? Like it just works. So it becomes different when you do not control the infrastructure. And I think like in a way, it's the same problem with persistent queries as well as that if you control the infrastructure, then you can say that, okay, all the queries must be persisted upfront. But if you have users who are a 3-person startup somewhere and they're like persistent queries, I don't even know what I'm going to run tomorrow. So it might just change like, tonight. We can't expect those things. So it becomes very different when you are running on somebody's laptop or you're running like 100 node cluster on Amazon. And the software has to work across both of them. So long story short, I think it might never come in Dgraph, but it would definitely be on /.
Cool.
Well,
just
one
FYI,
quick question.
I've got a Lisp engine that you can embed Lisp in, but sorry, Jens, go ahead.
I just wanted to ask one quick question to Manish. So when I built my demo, I tried to use /Dgraph, or I actually used it. And I found that when I don't use it for a long time, it kind of falls asleep and I need to wake it up first. So the first requests fail. And then at some point after, I don't know, a few seconds, it's done. Is that intended, or am I doing something wrong?
No, that is intended. That's actually like, I think what happens is that, and this is specific to /GraphQL, what happens is that after a few hours, I think after 4 hours of inactivity or something, it just shuts down the server. And then as you hit again, it would bring it back up and then run the query. It apparently should not fail. So if you're seeing failures, that's unintended. But this is all just to make sure that the costs are, that we don't go bankrupt like running all these Amazon queries.
Yeah.
Yeah. So we do shut down if the instances are not being used.
I see.
Cool. Right. Last question, which is a fun question for everyone. We'll start with Alex, go Manish, Alex, Sam, Jens, Andrea, and Robert and Yen. Okay.
Hugh,
Sorry?
Just before you ask question, actually, I had a question for folks as well. I know that we are sort of running slightly out of time. Is it okay if we take a couple more minutes for that question? Okay.
I've got a hard limit at 9 o'clock. So
okay. Time. All right. So maybe just a quick question. I think maybe and maybe like Robert, I think you might be the most you might have the most experience for this. Is that what makes GraphQL so successful, right? I mean, we have gRPC, we have protobufs, we have seen like REST JSON, we have seen all kinds of stuff. What is it that GraphQL? Why is it GraphQL? Why is it that we are having a GraphQL conference and not necessarily a REST conference right now?
I think everybody else is probably going to have great answers too. So, Andréa, Alex, you want to take this one?
The first thing I just thought of was what Andrea said earlier. Is like it's more natural for us to think in graphs and in relationships, and that's all these other things. That's kind of unique to GraphQL and graph databases. So. Yeah.
I would actually say it's marketing, because I think the website that describes REST is just not that fancy. The GraphQL.org is better, and then people started talking about that, and someone went to a conference about APIs, maybe they talked about GraphQL, and then the whole thing developed, and now we say, oh, GraphQL is better, but maybe it's just more popular because it's more popular, and because of that, it's getting more popular.
Honestly, I don't think it's more popular, because REST is really it's really widespread. It's everywhere. GraphQL is, I think, in terms of popularity, is probably quite small compared to REST. REST has had a very long history, to be fair.
It depends, because I would actually say most people who use RESTful APIs and not RESTful APIs, they actually don't know that they are doing it. You actively use GraphQL. You know this is a GraphQL query, and you have no clue that you're maybe trying to use RESTful or REST patterns. And I think most people actually don't.
And I guess if you go back to the Roy Fielding's original definition of REST, what we call REST now is not really what he meant either.
Yeah, exactly.
We should have an after-hours party where we debate the definition of REST.
Yeah, I gave up on that.
That would be really fun. You can sell tickets to that, Manish. REST definition debate next conference.
Yeah, next conference, exactly. Yeah, and that would be in person, so people can actually fight.
Is that before or after we define what a sandwich is?
Yeah, yes.
Awesome.
All right. So last question. This is going to be a fun question, two-part question. Favorite GraphQL editor, Postman, Insomnia, that sort of things. And the second question is, if you're an astronaut in space, what would your favorite part be in space? Alex, start.
GraphQL editor, like graphical? I mean, that's what I generally use in Gatsby world, but
yeah.
And then
basically GraphQL client of choice.
Okay. Oh, client, Gatsby. Anyway, and then space, I don't know, the views would be great.
The views.
That would be definitely worth it.
Right. And Manish?
I use graphical as well. I think I just love the way you can just pick and just create the queries. I think the first time I saw it, I was just like mind blown. I do think it could use support for subscriptions. So in fact, in today's demo as well, I had to switch to using GraphQL Playground and had to hand type my query, which is so rudimentary, right? So yeah, I think support for subscriptions there would be great. My favorite thing in space, to land on some planet actually, or something like being on Mars, or well, Moon is not a planet, but just being on a foreign object like a moon or something.
Okay, Sam.
So yeah, I tend to just use the graphical and GraphQL Explorer and things like that. I do like Insomnia. I don't use it that often. And then I think the coolest thing to be in space would be like if you could be over the rings of Saturn and like swim through the rocks of the rings of Saturn. I think that would be pretty awesome.
They did a documentary in Attack of the Clones, Star Wars Episode 2.
That would be so cool.
Jens? Favorite client?
Yeah, favorite IDE. just graphical and then generate all the rest. And in space, I think I would enjoy the silence because I can just deeply focus on something, but then I don't want to be like too isolated, so maybe not for too long.
That's a very German response. Andréa.
So for the editor, I'm going to stick with everyone else and go with graphical. I love writing queries that look like JSON because it's really familiar and it gives clients a lot of power. So I think that's also one of the reasons why it's so popular, is because the developer experience is really, really wonderful with GraphQL. And that's probably why we're having this conference today. As far as space, I think the coolest thing would be to see my planet from a different perspective, because sometimes when we're down here, we think things are such a big issue, but when you see it from like Scott Kelly was talking about, when you see the world just as it is, we are very small, and it makes whatever we think is so big down here a lot less important.
Robert?
Yeah. Favorite GraphQL editor? I'm using conjunction of GraphQL Playground and the VS Code GraphQL extension from Prisma.
Here we have someone who's contrarian. Okay, go on. Sorry.
Yeah. And it's just, they're all fine. I mean, all the tools that I've used I haven't played with the Postman GraphQL feature. I know that they launched that recently, and that seems pretty interesting because I use Postman for a lot of other things. That may be worth looking into. And then favorite thing about being in space, was that the second part?
Yep.
Oh, I think it'd be really cool to just experience 0G.
Cool. Yeah. And Jain, last but not least.
All of my GraphQL endpoints are protected by Cognito, so I kind of just use AppSync console because that gives me nice integration with Cognito. Otherwise, I'm gonna have a hard time just getting my my auth token. Favorite thing in space, I guess 0G for me as well, because it's something I've never experienced.
Yeah, and we should connect offline. You can grab the auth token out of the HTTP header and stick it into.
Yeah, but it's just a bit more work. Just easier to just use the console because it's all integrated. They've done a lot more work recently on the console experience as well, so that I don't have to remember the app, the client ID and all of that. It's just all in the drop down.
Yeah, that's a good point. Yeah, less of a hassle that way for sure.
Yeah.
All right. That was fun. Thank you, folks. And to our audiences at home, that was GraphQL in Space. Please do remember to check out our Discuss page. Some of the speakers have already answered your questions, and I'm quite sure you speakers would also spend some time answering questions there. And thank you. And we'll meet again, this time in hyperspace.